Hello friends, Sumit this side. Welcome to this playlist on Learn SQL the right way. Even if you are a beginner or an expert, this SQL playlist is for you all. Right? So now let's get started in this amazing journey on learning SQL, and I'm very sure that you will enjoy this journey. So now let's get started. And the very first thing that you might ask as a student to me is, sir, what is a database? I might go a bit slow here, and if you are a more advanced learner, probably you can see the video in 1.5 or 2x speed. That's your choice. So, what is a database? This is the very first question which might come to your mind. I am not someone who will give you a bookish answer, but let me tell you what I understand about a database. A database is a collection of data and holds the data in the form of tables. So, it is nothing but a collection of data and holds this data in the form of tables. Now, this is a very simple definition as per me. And now we can go further beyond thinking what is a table? What is a table? A table is nothing but a way of storing the data in the form of rows and columns, right? Holds the data in form of rows and columns. And this is almost similar to a Excel spreadsheet which you might have encountered a number of times, right? So it is similar to SQL, Excel spreadsheet. Okay. Now you might ask me a question, Sumit sir, then when a Excel spreadsheet can hold the data same way, then why do we require these databases and tables? Problem with Excel spreadsheet is that what if there are, let's say, 1,000 spreadsheets which hold more than 1 lakh records? It becomes very tedious, cumbersome, and totally unmanageable to deal with such huge data or with so many spreadsheets. That is why a better way is to have a database, and it will provide you n number of other functionalities also. So I hope this is clear. So what is a database? A collection of data in the form of tables, and a table is nothing but an entity which holds the data in the form of rows and columns. Now, apart from storing the data, database also gives you a way to access and manipulate this data. So the database provides us the capability to, to access and manipulate this data. Because storing the data is not the only thing. We should be able to interact with this data. We should be able to retrieve the data. We should be able to update or modify the data. Whatever we want, we should be able to do that. And that is also one capability which our database will provide us. Okay. Now, once you have understood what is a database and a table, now let us talk about the kind of databases that we have. Mostly these databases can be grouped into two categories. So two types of databases. The first category can be relational database, and second can be non-relational, also called as NoSQL database. NoSQL database. So what is a relational database versus a NoSQL database? A relational database is the one in which we store the data in the form of rows and columns. The one we have seen in the form of tables, right? The data is stored in the form of rows and columns, just like an Excel spreadsheet. And also, multiple tables have relations between them. For example, we might have an employee table and a departments table. I mean, each employee can have a department ID which will relate to a department table. That means two tables will have some relation among them, and that is why we say it as a relational database. So first thing is data is stored in the form of rows and columns. Rows and columns. And also the tables have relation between them. This is what defines a relational database. And a NoSQL database or non-relational is the one where we have a key value store, for example, key value store, or a document database, right? Or it can be a graph DB, things like that. So here the data is not stored in the form of rows and columns that way, right? And also two tables do not have any relation among them. Each table is different and does not relate to other table. Right now you do not have to worry too much about it. I might cover it in more detail in my subsequent sessions. I want to keep this session very light, and that's why I won't talk in a lot of detail. This is just like an overview that I am trying to give. So as you understand relational and NoSQL database, what is an example of a relational database? Which databases come in this category? It can be your MySQL, it can be SQL Server, it can be your Postgres, or it can be SQLite, MariaDB, and many others. So we will have a lot of databases which will come in this category. Now, what comes in the category of NoSQL databases? So in NoSQL, we can have HBase, MongoDB, Cassandra, and many others, right? So right now we are not interested to understand that, okay, what is the entire list, but I just want to give you a feel that databases can be divided into two categories: relational and non-relational. Relational is like MySQL, and NoSQL or non-relational is like HBase. Okay. Now, in this course, we will be interested to learn the relational database side of things, not the NoSQL side. Okay. And which database among these we want to prefer? We want to go with MySQL. Why? Because it is something which is used at a lot of places, very high demand. And that is why we want to go ahead with this. Now you might ask me a question, sir, what if I want to work on SQL Server or PostgreSQL? I would say you do not have to really worry. The SQL statements that you will learn still will be valid for these databases with minor changes. So I do not intend you to master the syntax and all. Syntax will keep on changing. If you understand the logic, if you are able to write that syntax for at least MySQL, I am very sure that same thing you can implement for any other database with minimal changes. Okay, fine. So let's go ahead. So you have understood what is the database and what categories the database belongs to. Now, there are so many databases. So how do they differ? Remember one point, they do not differ in the terms of SQL statements we write. We interact with these databases using SQL the same way. Rather, these databases differ in terms of the features they offer. For example, some database might offer a better security than other database. This is just one example I am giving. So by writing SQL to interact, we won't be able to differentiate. It remains the same. Only thing is that all these databases differ in their functionalities or features. Okay, so let's proceed. Now you have understood what is a database, and you understood MySQL is a database which holds the data, also gives us a way to interact with this data. Let's talk about what is SQL. SQL stands for Structured Query Language. Structured Query Language. Why is it named Structured Query Language? Because this language is used to deal with structured data which is in the form of rows and columns. So basically, SQL is a language through which you will be interacting with the databases, right? For example, you have a MySQL database and you would write certain SQL query to insert the data, to update the record, or to retrieve the record from your MySQL database. So MySQL is a database. SQL is a way to interact with that MySQL database. So next question is MySQL versus SQL, which I have already talked about. MySQL is a relational database which holds the data. SQL is a way to communicate with this MySQL whatever operation we want to do. So SQL stands for structured query language used to query a database. So and is used to query a relational database. Just to let you know one more thing, your SQL holds good for all these relational databases. And all this NoSQL would have their own language. HBase has its own language, right? Cassandra has its own language, like that. But for this relational databases, SQL is one common language through which you will be interact or you can interact with any of this relational database. And whatever SQL you might write for MySQL, 99% of that syntax would be the same for other databases also. Might be a slight syntax change and you should be able to write your query for any database. So let's proceed. Now, as I said, there are some slight differences which you do not have to worry in terms of syntax. Mostly it remains the same. Now talking about installation. That means you really want to practice these SQL queries, that how should I write the insert query? How should I write delete query? Or how should I do group by, joins, whatever. You do not have to worry if you have not heard about these terms. We will be covering that. So how do you do a local installation? In this session, I really do not want to do that. Why? Because even if I am able to tell that from my side, not everyone might be able to execute that. And sometimes, due to laptop constraints or machine constraints, software requirements, it might not work. Even though I am trying to tell it in the simplest possible way. I'll be covering installation in subsequent sessions, but just to make sure the first session is not overwhelming, I do not want to take care of this. Rather, I want to show you a simple way to get started with your practice without doing the local installation. And what is that way? There is a ID called as 𝐻𝐽 IDE, and we will be using that, and you can access this through your browser by doing a quick sign up. I'll be showing this. So what you need to do is you need to say 𝐻𝐽 IDE, and it says ide.ghom.io. Click on that, okay, and say get started. And what you can do is you can try to sign in through one of your Gmail. So let me try doing it. I am trying to register through or sign up through a Gmail, and then this you can skip. This says additional information, skip that. So, okay, go back. Let me try doing it again. Sign in. Yeah, you can see this is created. Now, what I need to do is I need to create a container. So this is as simple as that. That means you log in via your Gmail and then you create a new container. You can see here. And what you need to do is give a container name. Do not worry about any technicality here. I want to give you a quick environment where you can practice. As simple as that. Now you do not have to worry what is a container, why are we creating a container, and so on. I want to keep this session simple and just want to give you a working environment where you can try a few things. As simple as that. And if you have already installed MySQL or any other database, feel free to use that. So I will give a name, let's say MySQL. The region would be Mumbai, India. Okay. And apart from that, here I want to select the stack as uh, the stack would be node.js. Okay. Install MySQL, enable MySQL-ctl command. That's it. And then what I will say, create container, and this will try to create a container where I can fire my SQL queries. So let's see. Let's wait for 1 minute and this should be all okay. So definitely in some subsequent sessions, I'll talk about how to install MySQL so that you are able to, start that on your local system and all at your convenience. So till now, what we have covered, we have talked about what is a database. We have talked about relational databases versus NoSQL databases. We have seen some examples of relational databases like MySQL, SQL Server, Postgres, and all. And we have talked about some examples of NoSQL databases like HBase, Cassandra, and all. Okay. So the container is successfully created. Let me say run container. The container is running, loading basically. So let's wait. Yeah. Now I talked about why do we say it as a relational database? Because the tables have relation. For example, a primary key versus foreign key relationship. If you do not know about it, do not worry. We'll be covering it in our subsequent sessions, right? And we talked about difference between SQL and MySQL. MySQL is a database versus SQL is a way to interact with the database. So the IDE has started and we can now run MySQL. Let me first of all do one thing. I want to first of all change the color scheme of it. Black does not look good. I want to make it white. So what I can do is, not this. Okay, just a second. Okay. Now what I will do, I'll click this and say theme, and in this theme I will say light, and I will say apply and close. Okay, now we can see this light theme. I will make this window full size and I will increase the font. Command plus control plus plus or command plus plus based on the laptop that you are using. And I will type in a command mysql -ctl cli. You do not have to by heart this command, nor you have to remember. This is just to make sure we run mysql on this terminal. And this command is valid only for this particular IDE, so you do not have to by heart it. I want to start MySQL, and you can see we got this prompt. That means MySQL is running, and here we can write our SQL queries. And you do not have to worry about any technical stuff that we have done here. It's just that we want to get to the screen, as simple as that. Okay, so I will write this command here so that I can share this document also to you. MySQL-ctl CLI. That means command line interface. This is a command line interface because we'll be interacting on a command line shell rather than we interacting with a GUI graphical way, right? And this is the industry preferred way. So let's talk about few things now. Now we have connected to MySQL database. If we want to see what all databases are present here, because this MySQL would have many databases already. So there is a command called as show databases. Show databases, and each SQL command you have to give with semicolon. It will give you a list of databases which are already present. So we can say information schema, MySQL, performance schema, system, SYS. These are already available. You do not have to worry, but make a note of this command show databases is to get a list of databases which are present already. Okay. Now, what if you want to create your own database? You have to say create database name. Let's say I want to create a database name Trendy Tech. Now, just to let you know one more thing, ideally, my habit is to write even the keywords in small case, but some people say that it's good that, I mean, it's recommended that whatever are the keywords, for example, create and database are keywords, you should give it in uppercase. But I generally write it in lowercase, that's what I'm doing here also. But a recommended way is you can say create database trendy tag so that we can identify that these two are keywords and this is our user defined name. Okay. So if we do this, we will be able to create a database name trendy tag. Let's do this. How to clear the screen? Control L. Control L. Okay. Create database. Database name is trendy tag. We have created a database. How do we know it's created? We can say show databases. You can see this, that this database is created. Okay. Now, just like we have created a database, we can even drop it. How to drop? Drop database name, trendy tag. How do we know it has worked? Press up arrow to go to show databases and then do that. And you can see the database trendy tag is not available. That means it's dropped. But I do not want to drop it. Let me recreate it back. Okay. And when I say show again, it is available. Now, what I want to do is, I want to go inside a particular database so that I create some tables and all. How do I go inside some database? See, right now I am not in any database. But if I want to go in a certain database, I have to say use and database name. Let's say I will say trendy tag. That means I am saying I want to connect with trendy tag so that whatever I do later should be done inside trendy tag database. Done. It says database changed. How do I know in which database I am right now? How do I know in which database I am? You can say select database like this. You have to give this brackets. And this says that your current database is trendy tag. That means right now you are connected to trendy tag database. This is quite an important command to get to know this. I hope this is clear. Okay. Now let's say inside this trendy tag database, I want to create a table. So I want to create a table. How do I create a table? Create table and then table name. Let's say I want to create an employee table. Because trendy tag company has employees and there can be a simple employee table. And what can be the table? Let's say in this table we have employee name. Now this name will have a data type. We have age. Age will also have certain data type numeric. Okay. And then let's say salary. See, the table will be bigger, but in this session I just want to give you an overview of things, right? I just want to help you get started. That's where we are creating a table only with 3 basic columns, nothing else. So what data type name is, what data type age is, and what data type salary is. When you would have learnt any programming language, we talk about integer data type, float, right? Double, all of that. Same way in SQL also we deal with lot of data types. There are a lot of data types. It can become overwhelming for you, but the very basic ones are int for numeric and varchar for string, this one, and for numeric. And then when we learn other things, we will get to know more data types. But for now, these two are good enough. Int holds integer numbers, which are whole numbers, and varchar holds string up to 255 characters. Okay. So name is it string or numeric? It is string. So it becomes varchar. Varchar. And let's say I know that I do not want to give a name of more than 50 characters. So fine. Comma. Age. This is numeric, so I will give it as int. The value is quite long, so do not worry about it. And salary, again int type. And then I have to give a semicolon, copy this and paste it. Done. I have created a table employee. What if I want to see a list of tables inside the database I am connected to? To which database I am connected right now? Trendy tag. If I want to see a list of tables inside that, I can say show tables. And it says you have one table with the name employee. Okay, fine. What if I want to see the structure of this table? If I want to see the structure of this table, you can say describe. Let me first clear the screen. ESCRIBE employee. And you can see we have three columns. These are the data types of it. We will talk about nullable and default later, but this is just to give you an idea. The describe command gives you the structure of the table or the schema of it. And even DESC command works the same way. Exact same results. So why not type less? Why should we type the complete thing then? So DESC employee gives you the schema of the table. So just have a look at this document also, whatever we have learned till now. So we have created a table. Now inserting the data and all we will be doing in a later session, but this is just to show you how to create a database, how to create a table after connecting to the database and so on. Now how to drop this table? How to drop this table? We have to say drop table name. What is the table name? Employee. Dropped. And if I say show tables, you won't be able to see it because there is nothing inside it. I hope this is clear. Okay. Now if I say, so first of all, let me check in which database I am. I'm just pressing the up key. I'm in Trendy Tech right now. What if I drop Trendy Tech at this moment? Drop database Trendy Tech. Now if I see this command again, what do you feel? Will we be still connected to Trendy Tech? No. We won't be in any database at this moment. And that's why it says null. Null has a special value in SQL, which we will be talking about in great detail later. But right now, we are not connected to any database. And if at this time we try creating a table, it will give us an error. Let me show you that. Let me copy the same command and try running this. No database selected. And this is expected because we should be inside some database in order to do that. Right? So what we can do is, again we can create a database, create database Trendy Tech. Okay. Now let me do one thing. Let me say create table trendytech dot employee. I'm not connecting to trendytech by saying use that one, but just I am using the dot notation here. Will that work? Yes, it has worked. Because we have mentioned that this employee table we want to create in trendytech database. Earlier what we did, we explicitly said use trendytech so that whatever commands we perform after that will be a part of trendytech database. But in this case, we have not connected to trendytech. Rather, we were not inside any database, but we said trendytech.employee, showcasing this table we want to create in trendytech database. And now, let me check in which database we are. What do you expect now? In which database we are right now? Well, because we have still not connected to any database. Now let me just say use trendytech and show tables. And you can see this employee table. I hope this is clear. Okay. Now you understood these two are main data types. I'm not saying these two are the only ones. There are so many data types that you will find or you will feel confused at this moment, as and when whatever we require we will use, but these two are good enough to start with at this moment. I hope we are good here. Okay, so what we have learned in terms of practical: how to create a database, how to drop a database, how to create a table, how to drop a table, right, and things like that here and there. Fine. So with this, almost I'm done with whatever I want to cover in this session. Let's do a quick recap of what we have learned. We talked about what is a database. Database is nothing but which stores the data and also give us a way to interact with the data, right? We talked about relational versus NoSQL databases. Relational is the one where data is stored in the form of rows and columns and tables have relation among them. NoSQL is the one where tables do not have any relation. Moreover, data is not stored in the form of rows and columns. Data is rather stored in the form of key values, or it can be a document DB or it can be a graph DB, things like that. Now we talked about what is SQL. SQL stands for Structured Query Language, and it is the language through which you will be interacting with your databases. If you have to insert a record, if you have to update a record, retrieve a record, or you have to do anything. We talked about difference between MySQL and SQL because it looks almost the same. Remember, MySQL is a database and SQL is a way to interact with the database. Okay. Now, after that, we talked about, we did some practice and we understood how to create a database, right? How to create a table. We talked about two basic data types, int and varchar. We talked about dropping a table and we talked about dropping a database. And we have not seen the installation part because we do not want to get into the complexity of running into issues with the database. So that's why I showed a simple way to get a thing working so that without doing much of work, you will be able to run your SQL commands easily. And for that, we have seen this 𝐽𝐬 ID, which is a very good way to get started. And in subsequent sessions, I'll be talking about how to install a database because eventually that is required because we won't be able to do a lot of complex stuff here. So to get started, this is good enough, but we will be seeing more. So friends, I hope you have enjoyed this session. This was the session 1 in this playlist. In the next session, we will talk about insert commands and CRUD operations. If you have not subscribed to my channel, please do subscribe. And if you have any feedback, do mention in the comment section because that will help me a lot in making sure I give you quality content. Thank you. Hello friends, Sumit this side. So this would be the session 2 in this playlist. I have got wonderful feedback from my session 1 and believe me, it means a lot to me. So this will be the session 2 as I mentioned. And if you have not watched session 1, I would highly recommend that first watch that before jumping on to this session. Also, one more thing that you have to remember, you have to be consistent in practicing. It's not that you are just watching the videos without practicing. Because without practicing, just seeing the videos is not gonna help you. So without wasting any further time, let's start with session 2. This is the session 2 in the series Learn SQL the Right Way. In the previous session, we talked about how to create a table, we talked about how to get a quick setup done and things like that, which are very, very basic. Now let's dig a bit deeper into it and let's try understand the CRUD operations. CRUD operations. I think I discussed at a very high level that what is the meaning of CRUD. CRUD stands for create, read, update and delete. Create, read, update, delete. That means when we have created a table, using create we can insert the record. That means creation of new records, which can be done through insert commands, insert statements. Read means once the data is in table, we are reading it. How do we read? Using select statements. Update means updating a record. If some record is already there in table, how do we update? Using update statement. And delete means deleting a record, as the name suggests, and we write delete statements for this. And this is called as CRUD operations, where we can interact with records in a table. So in this session, let's talk more about insert statements, and also we will see various ways in which we can create a table. In the last session, we saw at a very high level that how do we create a basic simple table, but in this session we will explore more. So two things, creation of table and insert statements. This is what we are looking to learn in this session. Okay, so let's get started. Now consider that you are a small startup and you are looking to hire some employees and you want to have an employee table to manage their database. So you are looking to have an employee table, and now you are a Bangalore based startup in India and your preference is to hire more employees from Bangalore. That's what you want. You prefer to hire from Bangalore location. That is one preference that you have, for example. Now, what table structure you can keep? I mean, there can be a lot of fields in this table, but let's keep it simple. We can create a table, for example, create table employee. Okay. So basically, initially we will keep the table structure simple and then we will refine it later. So when you hire employee might have a first name, last name, middle name. Okay, and apart from that, you want to capture the age, salary, and you might capture the location. Let's begin with this. To start with, this is good enough. So create table, table name. Create table is a keyword. That's why it's preferred that you keep it in uppercase. But it's not that if you put it in lowercase, you get error. No. But recommended that you put in uppercase. I mean, but generally speaking, I myself keep it in lowercase. But for your reference, so that you follow right practices, I have kept it in uppercase here. Now, first name, what will be the data type? This is like a string, so it will be varchar. And we can say 255 characters. Ideally 255 not required because we know it won't consume 255 characters, so we can keep it, let's say, 20 characters. Middle name, varchar of 20, last name varchar of 20, because all of this is string type, comma, age, it's numeric, so this will be integer. Salary is also numeric, so it is integer. Location is again varchar, and I will say 20 characters. Good enough. And after this, semicolon. So let me take this and go to my uh, database or the terminal. You know how to reach to this. We are using 𝐽𝐬 ID, and now I will say show databases. TrendyTech is available as one of the database. Let me start fresh. What I will do is, just a second, I will just keep it on the right side. Okay. So what I want to do now is I want to drop TrendyTech and recreate it. So drop database TrendyTech. Okay, done. I want to recreate it now. Create database TrendyTech. Why I'm doing this? Because I want to start fresh, because there will be some tables which are already there. I want to start a clean slate. Okay. Let me clear the screen, Control L. And when I say show databases, I should be able to see TrendyTech as one of the database. I will say use TrendyTech, so that I go inside this. It says database change. Okay. Now I say show tables. What do you say? What all tables will we see? There are no tables, then why will we see anything? It's empty. Now let me create the table that we have, the definition we have written. By the way, just for your understanding, this command is called as a DDL command, because we are doing something with definition rather than data. This is called DDL, definition. And we see, I'll talk about DDL and DML later, do not worry, but since it came, I just brought that. We have created this table now with all these columns. Looks perfect. Okay, let me clear the screen again and say show tables. I should be able to see employee table. Okay. Now let me see the structure of it. Describe employee. I am able to see first name, middle name, last name, age, salary, location, all the data types, and null yes, default null. I will talk more about it. What does it mean? So there are other things too which we will talk in a while. Now we have created a table which is empty right now. How do you see the data inside a table? Using select command. Select star from employee. There are no records inside it. That's why we say we see empty set. Okay. Now let me insert some records. How do I do that? Let me go to my favorite notepad and say into insert into employee. That means insert into table name. Now if you follow right practice, make it caps. Insert into employee. Values. Again, values is a keyword, so you say values. Right? Insert into table name, values, and then you give the values. So for example, the values are, let's say, first name can be Kapil, and then second name, let's say Kumar. I'm just randomly giving this. I do not know any person named Kapil Kumar, but still, it's fine here. Last name is Sharma, and then age, let's say 28. Salary, let's say 10,000. Okay, and then apart from that, location we can say, for example, Bangalore. As I said, the company's preference is to hire from Bangalore, so Bangalore. Okay, and then semicolon. So I will take this and run. But let me tell you one good practice, that it is not must, but it is recommended that you give the list of column names here. So for example, insert into employee and then you give this first name, comma, middle name, comma, last name, comma, age, salary, location, values. This is how we should be proceeding. Now let me try running this and see if it works. Done. I am able to insert a record. Now let me go back to my notepad. Let me create one more insert command and I won't put this list here. And let me make slight difference in value. Let's say instead of Kapil, I will say Satish. And let me put this record. Will it work? Yes, it will. But not recommended this way. We should give complete list of columns. Okay. Having understood this, let us try to do a select on this table. I can press up arrow so that I can get the history. And my command that I want to run is select star from employee. And I can see both the records are there. Just have a look. Now what if I do not want to insert data for all columns? Let's say someone do not have a middle name. So let me just go back to my notepad, make a copy of it, or a copy of this rather. And then what I would say here, I do not want to give the middle name because a lot of people do not have a middle name. I do not have, for example, first name, last name, age, salary, location, and this I will remove. And then here I will say Rajesh. Randomly I am giving some names. Salary, let's say Rajesh is a boss. He has a salary of 20,000. Location is Bangalore. Age is, let's say, 32. Just to make the data more realistic, I changed some of the parameters and I will clear the screen and run this. It is inserted. We have not given the value of middle name. Now, if you would have done the same without bringing this list into play, for example, what I am trying to say, if you try to remove this list and run this, this would definitely give an error. Because when you are not mentioning the list of column names, then you should be giving all or the values for all columns. In your table, you expect how many values? 6, but you are giving 5. So this will throw me an error. Let me show you that. Column count doesn't match value count at row 1. That means if you are doing it this way, you are expected to give value for all the columns. You cannot leave any of them. Okay. So we understood that this value or this insert does not work and that's why it's not inserted. Let me do a select star again. And this is the last record which worked. And the middle name shows null. That means when we do not give value for anything, it goes as null. You might be wondering what is null. Is it 0 or is it no value? Null is basically undefined. You cannot say that it is 0 or you cannot say that there is no value like that. You say that we do not know. We cannot treat it like a 0 or something. Basically, it's like unknown, I would say. The value of it is unknown. So this is how this works. Just have a look at these statements, what I have written. Okay, fine. Now, what if, let's say, uh, let's say for any reason, you want to have some single quote inside name. Ideally, name would not have, that's not the right example, but let's say you are having some column where there is a requirement that you want to put a single quote as a value. For example, in Rajesh, let's say I have to do something like this. Will it work? Now, will it work? So first of all, let me give a list of column names, because I am not putting all the values. That's why I should be mentioning explicitly the column names. Now, will it work? No, because you can see this single quote is getting closed here and this becomes extra. Let me try running it and showing you that this is not expected to work. You can see this, that somehow the structure is all messed up. It's expecting me and then it gives some error and all, because it's not closing the single quotes properly. Then how do you tackle this scenario? Okay, so what you should do is, there are basically two ways. Instead of single quotes, if you give this double quotes, this will work, because single quote you can replace with double quotes, it's not an issue. So this double quote which is starting at the beginning is getting ended here, and that's why this single quote becomes part of value, and this should not give any issues. Let me try running it. You can see this has worked, and let me fire the select command. You can see this value. I hope this is clear. Now I would show one more way to do the same, or to achieve the same. What you can do is, let's say you want to use single quote only, for example, and then you want to use it, you can give a backslash. Backslash acts as, I mean, I would say, when you are giving a backslash, it will understand that next character I have to consider, right? So basically, we say it as a escape character, so that this will be treated as a value now. So let me show uh, this also, that this will work. So you can see this is working. Same way the way we did previously. I hope this is clear. So this should be pretty much clear till now. Okay. So now let's see that how do we insert multiple values in one go. For example, let me go to this one. Let me copy this and consider I want to insert more values. Let's say this one record is Kapil, another record can be Satish and all. I want to insert. What I can do is I can give a comma, and then I can give the record here Satish, let's say Kumar, let Sinha, any random name, age 30, and then salary 20,000, city Bangalore. Now if I do this, if I take this and run, this should work. Okay, somewhere I have messed up with the single quotes. I will check. This will give me error anyways. So let me quickly check. Okay, so this is not ending. Satish Kumar Sinha. This fine. Let me take this. Done. And now, if I do a select star, it should be able to show me that Satish Kumar Sinha and Kapil Kumar Sharma, both are inserted. So in this case, I have shown that how I inserted two records in one go. You can do 10 records, 20 records. So this is like bulk insert. I hope this is clear. Okay. So we have understood how to write normal insert, and how to write a multiple insert. How do we enter the value of single quote? Same way we can enter the value of double quotes also. If double quote is also coming as a value, then we can do it. How we can enter double quote? You can give single quote here, and then give double quote here. This will work. Or you give a backslash also. This will also work. Anything is fine. Okay. So let's proceed. So next in our list is, what if you have a data type mismatch? For example, uh, let me take this only. And you remember that first name, middle name, last name, we say 20 characters. What if we are trying to give more than 20? Ideally, it won't be more than 20, but let's say for some reason it is more than 20. Let's say I'm making it this way, right? And now let me try running it. Data too long for column first name at row 1. This is what it shows. Why? Because it could hold 20 characters as per our definition that we have given. But now we are trying to enter something more. That's why it's not taking. And same will be the case with even age. For example, let me now reduce this, and age, instead of uh, numeric, let me make it string, 20. Let's say. Will it work? No. Let me show that. Incorrect integer value 20 for column age, because it's expecting a numeric value and you are giving a varchar or a string. That's why it has not worked. You can see here. Okay, so I hope we are good, and you see that how strict is the database, that it won't allow you to enter wrong things. That's why the integrity and all is quite well maintained in a database. Fine. Now let's talk about more things. Let's talk about null. What is null? As I said, null means something which is unknown. For example, middle name, not everyone will have, that's why it can be null. But can the first name be null? No. In our case, I mean, we can still enter no value for first name and it will take as null, which is wrong. What I am trying to say is, for example, if I do this insert, first name I am removing, and uh, first name I am removing, and then just doing this. Ideally, this will work. So, but instead of this 20, I will make it 20 like this. Yeah. Technically, this will work. But is it correct? We have to understand that. Select star from employee. We can see first name is coming as null. In what actual scenarios will the first name be null? Right? None of the cases. So we should not allow null value for such things where we should not allow. I mean, it's not that we give a freedom that anything can be entered as null. That's wrong. Right? So let me structure this table well so that no one can enter null value for first name. Let's do that. So what I would do first is, I'll drop this table. Drop table employee. Okay. Now I want to recreate it. Let me take this definition and tweak it slightly. So create table employee, first name varchar 20. Can it be null? No. So what we need to say, not null. That means null values are not allowed for this. Middle name, definitely it can be null. By default, it is nullable. So we do not have to mention anything. Last name, of course, I do not want this to be null because a person should have a last name also. Of course, age should be entered without any second thought. I mean, it cannot be null. Salary also we should enter, so it cannot be null. Location, definitely it has to be not null. Only middle name in this can be null. Other than that, all fields are compulsory. That's what we are trying to say. Let's try to run this now. Done. We have created a better definition than the previous one by putting the right constraints into play. so that no one can enter null values for things where we should not be entering null. Now let me see the structure of this table. DESC employee. We can see that first name is null allowed? No. Middle name is null allowed? Yes. Last name? No. Age? No. Salary? No. Location? No. That means now at least this is correct. Just have a look at this. What create table definition we have given. I hope this is fine. Now, if you try entering a record where first name is null, it won't allow you. Let me try running the same, and this won't work. Earlier it worked, but now this will say field first name doesn't have a default value. Do not worry about what it's saying, but why this error we have got is because it is or it cannot be null. I hope this is clear. Just have a look at this create table definition here. Okay, but still middle name can be null now. We can ignore that. Fine. Now let's talk about default values. The next concept is about default values. Now consider this thing, that this location, as we know, we intend to hire mostly people from Bangalore. That was the first preference we have mentioned at the very starting. If I go up, we said you prefer to hire from Bangalore. That means whatever mostly you will be entering will be people from Bangalore location. So why do we have to always mention Bangalore? If we do not mention and it takes Bangalore by default, won't that be great? Because 95% of the population you are hiring is from Bangalore, then why do you have to explicitly mention? You say that if I do not mention, consider it as Bangalore by default. Otherwise, I will mention if it is something else. Makes sense, right? So let's try to get that model. So what I would do is, I will drop this table employee. Okay, and I would create it with new definition, which is again a better definition than the previous one. Create table employee, first name, that's fine, middle name, last name, age, salary, location, and this location, what I would say is, I would say default Bangalore. In small, let me give. Okay, this is what I am trying to do. Just have a look. Now what I would do, I will create this table definition and I will show you describe table employee. Oops, what happened? Create table TESC table name. Let me just check. What table I have created? Create table employee, first name, middle name, last name, age, salary, location. Looks good only. Table already exists. Okay, describe employee. So it's not describe table name, describe table name, right? So you can see by default the value is Bangalore here. That means if you do not give anything, it will be Bangalore. I hope this is clear. Now let me try inserting some records in this. I will pick some records from here and we'll try inserting. Let me just pick something from here. Okay. Now what I want is, let me remove the middle name because it can be still null. So just want to show this also. So first name, last name, age, salary, location. First name is Kapil, last name is Sharma. age is 28, salary is 10,000, location I do not want to again give. Now in this case, what do you expect? What will be the middle name? It should be null. And what should be the location? It should be Bangalore. Let's see. Okay, and I will say select star from employee. Kapil, null, Sharma, 28, 10,000 Bangalore. By default, the value is Bangalore. As we said, out of 100 people whom we are hiring, 95 are from Bangalore. Then why to explicitly enter? By default, system will consider it as Bangalore. But by chance, a rarest of rare case, if someone is hired from Hyderabad, Chennai, we can mention. How? Let's see. It's straightforward again. We can say this location, and then we can mention the location. Let's say Hyderabad. So let's run this, and then when we see the records, you will be able to see Hyderabad. But by default, the value is Bangalore. I hope this should make sense. Okay. So this is how default values work. Even for age you can do, I mean, if it is logically feasible for you. So this is how you can give any number of default values for any column. I mean, for each column it will be one default value, but you can give it for multiple columns. Fine. Now, in this case, I mean, let me just again describe the table. You can see this location field or column has a default value, and is it nullable? Yes. Right? Is it nullable? Yes. That means when we are not giving any value, it's Bangalore. But what we can do in this case, we can manually set the value as null. This permits us because it is nullable. So for example, what I am trying to say, null is allowed basically for this. So we can manually set this value as null if it is unknown. This is what I am trying to convey. Let's say here the name is Rajesh. So as per the current definition, null is allowed, and you can set null like this. Let me run this, and let me say select star from employee. You can see here Rajesh, middle name is null and location is null. If we would have not given anything, it would have taken Bangalore. Otherwise, we could specify, and null is also allowed. If we want to restrict this null, then we have to make it not null. So let me quickly drop this table definition and recreate it very quick. Drop table employee, and now I would recreate it. I will just copy this, and then I will say not null. That means null won't be even allowed manually then. Done. And now if I try to insert the same thing, it won't work for sure. It says column location cannot be null. So that is where you can combine not null and default. Right? If I do not give anything, it would have taken as Bangalore. If I remove this, now this worked. And when I say select star, you can see this. By default, it's Bangalore, and you cannot set as null explicitly also. So this is where a combination of, so combination so combination of not null and default. This is what we have seen just now. And you might be wondering that how does both of it make sense together? So I explained a scenario where manually we were able to set it as null, but if we do not want to allow it, we can again do this combination, not null and default. So let's see what all have we covered. So what all have we covered? Just recall, we have covered what are CRUD operations: create, read, update, delete. Create means inserting a record, read means select statement, U means update statement, D means delete statements. Right? In this session, we talked about simple inserts, multiple inserts. We talked about data type mismatch. Apart from that, we talked about what is null and not null, null and not null. For example, middle name can be null, but first name should not be null. So we can define those constraints. We talked about default values. Okay. Uh, we talked about combination of not null and default, not null and default, where we do not want someone to explicitly also set the value as null, right? For example, for example, location. We do not want it to be set as null in any case, and we want default value as Bangalore. So friends, I hope you liked the session. Whether you have liked or not liked, do let me know in the comment section, because that will help me to incorporate that feedback in order to make the sessions better for you. If you have not subscribed to my channel, do subscribe and do not forget to press the bell icon so that you are updated with the new updates. Thank you. Let's meet in the next section. Hello friends, Sumit again. This is the session 3 in the playlist Learn SQL the Right Way. Before jumping on to this session, I highly recommend that you should check the session 1 and 2, because without doing that, if you directly jump onto this, you won't be able to get much. So without any further delay, let's quickly start with the session. This is session 3 in the SQL playlist. In session 2, we covered a few things. Let's quickly recap. We talked about what is a CRUD operation, and we majorly talked about insert statements, which is like a create operation in CRUD. We talked about simple insert, and we talked about multiple inserts, where we can enter multiple records in one go. Multiple insert. Okay. Apart from that, what have we seen? We have seen scenario where data type mismatch happens. Data type mismatch. Right? And then we talked about null and not null. Null versus not null. We talked about default values. Okay. And then we talked about combination of not null and default. So basically this is what we covered at a high level in session 2. In this session 3, we will talk about a few important things. What are those? Let's have a look. We will talk about primary key, and we will talk about auto increment keys, and we talk about unique key, and we will differentiate how a primary key is different than a unique key. Primary key versus unique key. So this is the agenda for this session. So let's get started. Let's talk about what if, for example, whatever table we have, this one, there can be two employees with the name, let's say Rajesh Joshi, two employees with the same name. How do you uniquely identify both? In this case, how do you uniquely identify both? That is where we have a concept of primary key. That means when we define a primary key, we can uniquely identify each and every record in a table. What I mean to say, let me do a select star for now to see what all is there. Rajesh Sharma. Okay. Let me again try inserting one record. I will fire the similar insert. Rajesh Sharma, another person with same age, let's say, and his salary is also same. Okay. Now, if when I say select star, you can see there are two people, different people with the same name, same age, and same salary and same location. It can happen, right? Definitely, it can happen in extreme scenarios. But then, how do you uniquely identify each person in this case? For this thing, we have a concept of primary key constraint. So, primary key. So this helps us to uniquely identify each record in the table. So what we will do is, let's drop the definition of this table. Uh, drop table employee, and let us recreate it with the right definition. Let me copy this, and now what I would do is, I want to add one more column called as employee ID, or let me just simply name it as ID. And then this will be, let's say, integer type, and this is what I want. But additionally, I do not want any duplication on this. So let me first do it. Let me first create this ID, and what I would do is, I would run this and try inserting some records. So insert definition, I will copy from the previous one, and will make some changes after that. Okay, so last name 𝐻𝐶. I am copying from here. So insert into employee first name, last name, age, salary. Before this, we have to give ID also. ID, and this ID is, let's say, 1. Employee ID is 1, and I would run this. So in this employee table, I have one more column ID, and I have inserted a record Rajesh Sharma, whose age is 28, salary 10,000. When I do a select star, we can see one Rajesh, middle name is null, Sharma, 28, 10,000, Bangalore. Fine. What if I insert one more record with the same thing? It worked. And even when I do a select star, you can see this ID is 1, ID is 1. By default, it is not a primary key or something. We have to make it so that whenever we try to create one more record with that ID, it gives an error. This is what I want to show. So let me quickly drop this table. Drop table employee and recreate it by using this primary key. So what we can say here, ID int, and we just have to mention primary key. That's it. If I do this, then definitely multiple employees cannot have a repeated ID. And let me show you through describe command, DESC employee. You can see this ID is a primary key, okay, and location is a default thing, where default value is Bangalore. I hope this is clear. Now if I try running the same insert statement two times, 100% it won't work. Let me show that. First time it worked, but next time it will say duplicate entry 1 for primary key. A primary key says that I won't allow any null and I won't allow any repeated values. That means null is also not allowed and repeated values are not allowed. Okay, so I would write here for a primary key null is not allowed and also repeated values are not allowed. Let me try entering some null value just to see if it works. Okay, let me just take it as null. Column ID cannot be null. Why? Because it is a primary key. That's why it cannot be null. So primary key does not allow duplicates. It does not allow any null. So what is a good candidate for a primary key? Something based on which you want to uniquely identify someone. For example, a customer ID in a customer table, employee ID in an employees table, student roll number in a class, things like that, where you know it cannot be duplicated. I hope this is clear. Now, one more way with which we could have defined a primary key is, right now we have mentioned primary key here, right? If we do not want that, there is one more way. We could have done something like this. Towards the last row, we can mention primary key and then we mention the column name, on which column you want. This works the same way. This works the same way. There is no difference. A slight syntax change, but I am letting you know here. I hope this is clear. And now sometimes you can have a primary key on a combination of two columns. Then in that case, let's say if it is, for example, two columns, where column 1 is this one, column 2 is, let's say, something like name, we can do that way, which is like a composite primary key which is on two columns. I hope the logic and the idea is similar. So you do not have to worry. So sometimes based on two columns, you want to have a composite primary key. That means a combination of these two cannot be duplicated or should be unique. We will be seeing that more in our practical demonstrations later when we talk about some quality examples once we have done the basics and all. So I hope this is fine. Now, ideally, if we are entering a new employee always, what we have to do, we have to again think that, okay, what's the, ID of the previous employee? Then we have to enter the next one. For example, you have 10 employees right now. Then you know this ID value will be 10 and you have to now enter 11. But how do you remember it has to be 11? It gets tricky to identify that. So that is why we should go for a auto increment. That means we do not have to worry. We do not give this value. What if this value can increment again and again 1 1 whenever we are inserting? Let's try to create that. So I will drop this table employee. Okay. Now let me make some slight changes here. In this, what I will do, id int, and I will say auto increment. Auto increment. That means what I'm saying, I do not want to manually give this value always. Please start with 1 and then keep on incrementing that. That's what we want. Now let me just run this. Done. And I will say describe employee. You can see under the extra column we are seeing auto increment for ID, which is primary key also. That means it won't be duplicated and it's auto increment. I hope this is clear. Now let me try entering some values for this. Of course, I cannot enter null here. So I will remove this ID because I do not have to worry really about it. Okay. Done. Select, I have done insert. And what do you expect will be the value of ID in this case? I have not manually given it. Let's check. Select star from employee 1. The value is 1 here. Let me try running insert again. Might be some other name. Kapil Sharma, let's say. What will be the ID in this case? 2. It will auto increment. You do not have to really worry about it now. So, auto increment is a good candidate for primary key because then, of course, when it's incrementing all times, it will be unique, distinct. So, I hope this is clear. Now, let's talk about unique keys. What is a unique key? As the name suggests, it looks very similar to primary key. That means it holds only unique values, values cannot duplicate. Then you might question me, Sumit sir, primary key was also doing the same. Then what's really unique about this unique key? I'll tell you. Remember one thing, you can have only one primary key. You can have only one primary key, and the primary key cannot hold any null. Primary key cannot hold any null value. And ideally, we should use primary key when we have to distinctly identify or uniquely identify each record. We should use primary key when we have to uniquely identify each record. I hope it makes sense. Now I would talk about unique key. What is a unique key? Unique key also cannot hold any duplicate, just like primary key, but unique key can hold null. How many null values it can hold? Now, based on databases, this might change. For example, in MySQL, a unique key can hold any number of null values. That means it feels that all nulls are different, unknown value, right? But in some of the other databases, it holds only one null. Only one null. In some of the other famous DBs, unique key hold only one null. We cannot give more nulls to that. But since we are using MySQL, you will be able to find that you can give any number of null values to a unique key. And what is the whole purpose of unique key? Unique key is to make sure that you do not get repeated values. For example, email IDs. You do not want to differentiate each user based on email ID, but you want to make sure if someone has taken an email ID, other cannot take it. Right? So the purpose of unique key is to make sure the values do not duplicate. But the purpose of primary key was to make sure we can uniquely identify a record. Right? One more important thing, you can have unique keys on more than one column. That means there can be 3 columns where you have different unique keys. But in case of a table, we can have only one primary key. Now you might get confused with a composite column or where 2 columns together have a primary key. That's a different thing. But still we have one primary key, right? So we can have only one primary key but multiple unique keys in a table. We can have only one primary key but multiple unique keys in a table. For example, when we talk about an employee table, I would say employee ID can be the primary key, employee email can be a unique key. Make sense? It would make, right? So that's how it is. So now what we can do, let me show you a random thing. For example, let me take this table and let's change few things. Let's say first name, middle name I am removing, last name, age. I am just taking all of this. Okay. And now I want to create, let's say, a primary key on these two columns, first name and last name. That means what I am saying, a combination of first name and last name has to be unique. Ideally, it might not be the scenario in real world, but let's think that this is a scenario. Then what we have to do, primary key, and then we can say first name comma last name. This is what we can definitely do. Now let me try first dropping this table, drop table employee, and now I would create this table. Okay, I have created this table and now I will say describe table, describe employee. You can see the primary key is on a combination of first name and last name. Now I will try inserting this thing, records, insert into employee. Let me not give explicit list of columns because I want to insert for all. So values, and then I would say Kapil Sharma, okay, and age 28. And let me give a semicolon towards the end. Oops, okay. Will it work? Yes, it would. Now, if I run it again, will it work? Let's say if I say Kapil Sinha, will it work? Yes, it would. A combination of first name and last name is unique. But what if I say Kapil Sharma again? Will it work? Duplicate entry Kapil Sharma. See, it's concatenating first name and last name, and that is now the primary key. So I hope how a composite primary key works, composite key works. This should be clear. So I think we should be good. Now similarly, if you want to give a unique constraint, what you can do, instead of doing like this primary key, you can say unique key. You can say unique key. Now whatever we have right now, in this can we enter, let's say, null? Not this single. Because primary key do not allow null. Remember that point. It cannot be null. I hope this is fine. And moreover, we have explicitly given not null. Okay. Now let me remove this not null constraints also. And let me create this. First of all, let me create a unique key on single column. Let's say, let me have ID also. ID. ID is what? Int. And I'm saying unique key. This is what I am trying to have now. ID, first name, last name, age. And now let me try running this. First, I will drop this table. Drop table employee. I would recreate this table now, and I will say BESC employee. You can see this ID is a unique key now. And of course, unique key will allow null. Let me try inserting the records. What I would say, insert into employee values. I will say, let's say 1, first name is Kapil, second name, last name is Sharma, and age is 20. Let me just run. This will definitely work without any second thought. Now, if I run this again, will it work? It won't. Duplicate entry 1 for key ID, because we have applied a unique key constraint. It cannot have duplicate values. And what if we put null here? Will it work? Yes, it would, because it allows null, and in MySQL it allows any number of nulls also. I will say select star from employee. You can check that out. But if ID would have been a primary key, you would not be able to enter this nulls. Right? So I hope you got a right idea that, let's say, if you are having an employee table, employee ID can be primary key, and only one thing can be a primary key, not more. And in that case, phone number, email address, all of that can be unique keys, because we do not want duplicates among them, but we want to uniquely identify each employee based on employee ID. So that's the difference between primary key and a unique key. I hope with this you would have got complete clarity on how exactly it works. And you can have a unique key constraint on multiple columns also. I mean, a combination. See, of course, you can have on multiple columns, but I'm saying combination is also allowed. For example, we could have said, instead of having unique key on this, we can say unique key, and then let's say if we want it on a combination of ID and first name. I mean, logically it does not make sense, but this can be done. Fine, then in this session we have covered a lot. So let's see what all have we covered. And in this session we talked about primary key, auto increment keys, and you can just understand that auto increment is a very good candidate to be a primary key, because we do not have to worry about increasing the value. It will automatically be incremented. We talked about unique key and how a unique key is different than a primary key. Remember, we can have just one primary key in a table, but we can have more than one unique keys. And the role of primary key is to make sure that we can uniquely identify a record in a table. But unique key has a different purpose. It is to make sure we have distinct values for a column. So with this, let's wind up, and I hope you enjoyed the session. तो फ्रेंड्स, कैसा रहा सेशन? अभी तक सब्सक्राइब नहीं करा यार, अब तो कर लो, किस चीज का वेट कर रहे हो? सी यू इन द नेक्स्ट सेशन. Hello friends, Sumit this side. Welcome again. Learn SQL the right way, session 4. Till session 3, we have already done a lot of hard work, and I believe that you would be enjoying this playlist. One thing is that you need to keep on practicing. Videos alone won't help. I am repeating this multiple times because as a mentor, I just do not want to give you content without any effectiveness. I want to make sure that you practice that well so that you get the best out of it. If you have not subscribed to my sessions, do subscribe, and let's start without any further delay. Thank you. This is the session 4 in the SQL playlist that we have on YouTube. Now, in the previous session, we have talked about few important things. We have talked about what is a primary key. We talked about what is a unique key. And we talked about auto increment. It is a very good candidate for a primary key, which you have understood. Okay. So having covered all of this, let's quickly focus on few other aspects. Let's jump our focus on CRUD operations, which we started with earlier. And as you know, that CRUD stands for create, read. So let me increase the font. Create, read, update, and delete. This is what CRUD means. Create is actually insert, which we have seen quite extensively in the previous sessions. The insert statements on how to insert the data. Read is basically to read the data using select commands. Update is to update the records, which we will be seeing definitely in this session, and delete is to delete the records. So we have till now seen insert, but now we have to see little bit on the select, update and delete. So let's focus on this. Now by this time you know how to create a table, and by this time you know how to insert the records. And I have a sample create table structure. Let me quickly explain this. I think we have covered this, but still let me quickly go through. We want to create a table employee where ID is the primary key and the type is integer type. We have various other columns like first name, middle name, last name, age, right? Salary and location. All of this we have. And by default location is Bangalore. If we do not provide, it will consider as Bangalore. Okay. Now middle name can be null because we have not given the not null constraint, and you pretty much understand this definition by this time. So let me go to my 𝐽𝐬 IDE and I will say show databases just to see what all databases I have. Trenditech is the database which I have created in previous session. Let me delete that and recreate just to make sure we start from beginning. So drop database Trenditech. Okay, drop. Now I will recreate it. Create database. Create database. Just a second. Create database Trenditech. Okay, I have created a new database. What I want is I want to create a table structure named employee. First, I should say use Trenditech. That means I should be first connected to my database, then I should create a table. I said use Trenditech, it says database change. Let me give this definition and we have created the table. If I want to see the structure, DASC employee. You can see this. ID is the primary key, and for location we have a default value of Bangalore. And middle name can be null. Apart from that, all other things have to be not null. Okay. Let me insert a few records. Insert into employee, and I am giving the value for ID, first name, last name. I am skipping the middle name. Can I skip or not? Yes, I can, because by default the value is null. And I am not giving the value for location because by default it will be treated as Bangalore. Let me take all these three statements and run it. So we have inserted three records now. Okay. Let me say select star from employee, and we will be able to see the data. You can see location as Bangalore, middle name as null. Fine. So all our prep work is done now, and let us see how to have variants of select. This is a simple select where we are getting all the columns. Star means please get me all the columns. So I will write here. So we are talking about select. It is nothing but reading the data. So we talked about simple select, selecting all columns, and the command for this is select star from employee, which you very well know. Okay. Now what if I just want to get first name and last name? How to get only two columns? I can say select first name, comma, last name from employee. We will get two columns. So this is pretty straightforward. I don't think it would require much explanation. You can give the column names whatever you want, selecting specific columns. Okay. Now, what if I want to get only a few rows? In the previous case, in this case, we got a few columns only. But what if out of three, we want only two rows based on some condition, based on some filter? How do we do that? Let's say I want people whose age is greater than 29. How many records are there whose age is greater than 29? Two records, Kapil and Manish. Rajesh is less than 29, so we won't see. How to run that? Select, select, star means give me all the columns, star from employee. We can give a where clause where age is greater than 29. And we can see the two records. Just have a look. So we can give a filter clause like this. Let me write here, or let me just copy this. So select by applying a where clause. Where clause is like a filter condition. Select star from employee where age greater than 29. Now I can say select star from employee where first name equal to Manish. That can also be done. Where first name equal to Manish. We can see the record. We can give any condition whatever we want. But do you see one thing here? That in our table we have given Manish M in capital. And now when we are searching for Manish where M is small, the first letter is small, then also it's picking up. That means by default, it is case insensitive. It does not matter whether you give it in uppercase or lowercase. I hope that you understood what I'm trying to convey. So let me just take this and copy here. And by default, it is case insensitive. What if for some reason you want to make it case sensitive? You can have a business use case definitely, but what if you want that? Then what you need to do, the same statement you have to run, but you just have to use a keyword called as binary. Select star from employee where binary first name equal to Manish. In this case, it will look or match the specific case. And you can see it has not pulled out any records. Why? Because there is no data where the name is Manish and M is lowercase. And if I give M capital here, it will be able to retrieve the records. I hope this is clear. Quite easy to understand. That's why I'm going a bit fast. Okay. So this will, the above statement will match the exact case and is case sensitive. Fine. So this we have understood. Now, for example, you have to get the first name and last name, but you want to name it as name and surname like that. Then how do you do? So we can say select first name comma last name from employee. In this case, you can see it shows first name and last name, but what we want to give it some other name, alias. How to do? What we can do is we can say select first name as name, whatever we want to give alias name, and last name as surname from employee. You can see it has changed here. So if we want to have a alias, we have to use the as keyword. So alias, use the as keyword. I hope this is fine. So we have seen how to get all columns, select all columns using the star, select specific columns, we can mention or specify the column names. We can give a where clause to filter the records. By default, it is case insensitive. If we want to make it case sensitive, we can use the binary keyword. Okay, we can use the binary keyword. And then we have checked alias so that the column names show differently. Fine. With this kind of, we have understood that how select works, and it's nothing but the read operation in CRUD. Now with this, let us talk about update. Now consider a scenario. So first of all, let me say select star from employee. Okay. Now consider a scenario where let's say you want to update the last name of Manish. We understood that we by mistake entered as Sharma, but it is Manish Sinha, let's say. Then how to do that? We can run the update command. How to run? Update, and what is the table name? Employee. Update employee. Set is a keyword again. Set last name equal to what name we want to give? Sinha. Where first name equal to Manish. That means we are giving a where condition. That means we do not want to update all records, but we want to update a specific record where first name is Manish. Where first name equal to Manish. Okay, let me run this. Semicolon, done. It says this command is able to match one record. We can see here, and it changed one record, which is true. Let me say select star from employee. And we can see in this case Manish Sinha rather than Manish Sharma. I hope this is clear. Now consider we understood that Kapil moved from Bangalore to Hyderabad and we want to change location for Kapil. How to do? Update employee set location equal to Hyderabad where first name equal to, what was the first name we were talking about? Let me just see what was the first name we talked about. Kapil, let's say. Kapil. Kapil moved from Bangalore to Hyderabad. It says it is able to match one record and it changed that. Let me run select command and we see Kapil Sharma has moved to Hyderabad. I hope this is clear. Now let's say, what if I say update employee set location equal to Hyderabad? What will happen if I do not give a where clause? Then in that case, it will do the update for the entire table. Right? It will match all the records. In this case, it will be able to match all the three records because there is no where clause, and it will update two records because one record already has Hyderabad. So we can see rows match 3, change 2, because when we do not give a where clause, it will meet, or it will kind of get all records to update, and in this case two records will be updated because third one is already done. I hope this is clear. Now consider one more use case where, let's say, I want to increase the salary of each person by 5,000. I want to increase the salary of each person by 5,000. What I can do is update employee set salary equal to salary plus 5,000. I'm not giving any where clause. That means it will be applicable for all records. Done. Match 3 records, change 3. And if I say select star, you will be able to see the salary is increased for all the employees. I hope this is clear. Now, what if, let's say, you want to, for example, give a clause where in the where clause you give end condition. That means you want to match two clauses. For example, set, let's say I want to increase or change the location of Manish to Bangalore, but I might have multiple records with the name Manish, so I want to go for the complete name. So set location equal to Bangalore, set, sorry, update employee set location equal to Bangalore, where first name equal to Manish and last name equal to Sinha. Okay, I think this Bangalore let me just get a error first and then I'll correct this. Single quote is missing in Bangalore. Oops. You can see rows match 1, change 1. So all what I wanted to say is that we can use this logical AND or operators when we want to filter based on multiple conditions. I hope this is clear. So with this, we kind of understood how update works. We have talked about update commands. Okay, now let's talk about delete. Delete. So while doing the update, you have to be very careful, because if, let's say, your where clause or you're not filtering it properly, you might end up doing changes to the records which you do not want. So always a good practice is first run a select command with the same where clause filter. And then once you feel that you are able to pull only the necessary records, then you put the update command. Because you do not want to run into a issue where you end up updating unnecessary records which you do not want. I hope this is clear. Now let's talking about delete. So in your CRUD operation, delete or D stands for delete. And let's see how to delete a record. So let me say first select star from employee. What I want to do is I want to delete the record where employee ID is 3. Why? Because that person is, let's say, leaving the company. So what we can do, delete from employee where delete from employee where ID equal to 3. Just a second, let me check what has happened. Delete from employee, check the manual correspond. Oh, I didn't give any space, looks like. Okay. Okay. Some syntax issue. Delete from employee where ID equal to 3. Delete it. Now let me say select star from employee. We won't be able to see the record. Now again, when you are doing a delete, make sure first you kind of check it with the select statement that it is pulling out the right record for you or not. Select star from employee where ID equal to 3. And then you see, okay, that record is only pulled out. Then you put delete because you do not want to run into an issue where you end up deleting something which you do not want. Now, what if I say delete from employee and I'm not giving a where clause? What do you expect now? In this case, all the records will be deleted. And it says 2 rows affected. Now, when we say select star from employee, what do you expect? Nothing, of course, because we have deleted all the records. I hope this is clear. So let me just put this command also here. So with this, we are kind of done with the CRUD operations, which are very important. Create, read, insert, create, read, update, and delete. CRUD operations. Now, let me talk about alter command. This is not a part of CRUD, just to let you know. So it's a separate topic in itself, alter command. For example, now, let me do one thing. Let me say DESC employee. I want to see the structure of employee table. Now I realized that this location, or let's say this first name, some of the people have very big first name and we want to increase the size of it, right? This can be one structural change where we are not dealing or changing the data. We are not updating the data, but we are updating the structure, either the data type of it, or we might be willing to add one more field to it, the column. Such structural changes we have to do using alter command. And update was to update the data actually. Because you might get confused, then what is the difference between alter and update? Update deals with data manipulation. Alter deals with structure manipulation. Right? So alter is to alter the structure of the table. When we say structure, I mean to say schema of the table. So for example, in this table, I want to add another column named as job title. How do I do that? I can say alter table employee add column because I want to add a new column. Add column job title, and what will be the data type? It will be string, so varchar of, let's say, 20. 20 might be less, let's say varchar of 50. Let me take this and run. Okay. Now I expect that in my table definition, I should be able to see job title column varchar 50, which is here. I hope this is clear. So what have we done? We have changed the structure of this table. How? Using the alter command. Okay. Now, what if I want to drop this column? So let me go here, copy this, alter table employee, drop column job title. Here data type of course is not required. If I do this, the column will be dropped. Alter table name, drop column job title. Done. And let me say describe table. You won't be able to see that column again. Okay. Now consider I want to increase the length of this first name. By default it is 20 and we realize some of the people have first name which is greater than 20 characters for some instance. Then how to do that change? Alter table employee modify column, because we are modifying a column rather than adding or dropping. We want to modify an existing column. Alter table name modify column. Which column we want to modify? First name. First name. And what we want to make change? Varchar 30. Earlier it was varchar 20. You can see here we want to make it varchar 30 now. So let me just copy this and let me say describe table. You can see now this data type has changed. It has become varchar 30. I hope this is clear. Now there is a primary key on ID. Let's say for some reason you want to remove this primary key. How do you drop this primary key? This also can be done with alter command. Alter table employee drop primary key. As simple as that. If I run this, the primary key will be dropped. Let me, right now it shows primary key. Let me run this and then show you the structure. The primary key is dropped. Now we can even have duplicates in this. Now what if again I want to put a primary key on this? Let's say you have a table where there is no primary key and you realize you want to keep one column as the primary key. How to do that? Alter table name, add primary key, and you need to tell on which column you want. Let's say ID. We can see this command, alter table name, add primary key on ID column. Now if I show you the structure, you will see this has primary key. I hope this is pretty clear to you. Okay. Now you have understood the alter command. We are at that stage where you should be able to understand making changes to data or schema. These are two different things. And that is where we have two things, DDL and DML. DDL versus DML. What is DDL? Might be if it sounds tough to you, believe me, it's not tough. Just listen and you will be able to understand. What is DDL? DDL stands for Data Definition Language. Data Definition Language. And DML stands for Data Manipulation. Manipulation Language. Data Definition Language and Data Manipulation Language. What are these? DDL statements are the ones which change the table structure. They do not manipulate the data. Only the definition. Definition means the schema or the structure it changes. Okay. So basically DDL or data definition language consists of SQL commands that can be used to define the database schema or alter it. So deals with table structure. And data manipulation language, here the commands deal with changing the data or deal with exact data. So here we deal with the data directly. Okay. So now in data manipulation language, we have commands like insert, update, delete. All this actually deals with data because we end up inserting a record, updating a record, deleting a record, and things like that. All of this are part of data manipulation language or called as DML commands. When we talk about data definition, create table, alter table, drop table, all such things deal with the structure rather than data itself. So these all are part of DDL commands. I'm not saying these are the only commands, there will be more, but to differentiate, I would give these examples. DDL versus DML. I hope this is clear. Just have a look at it. You should understand what commands are DDL commands and what operations are DML operations. So as I said, create, alter, drop, all these are DDL, and insert, update, delete, all these are DML. Now you understand, I talked about one thing, that delete from employee. What will this do? This will delete all the records from the employee table. What command is this? Is this a DDL command or DML? Does it deal with data or does it deal with structure? This deals with data and it deletes the data. That is why delete is nothing but a DML command because we are manipulating the data. Now same thing we can even do using truncate. I won't talk much, but I am giving you a rough idea. There is a command called as truncate. So for example, let me see if there are some records inside this. Select star from employee. Now, so let me quickly put some records inside this. Just give me a second. Okay. Now let me run the select command. So I have inserted few records. If I want to remove all these three records, which command should I use? You will say we can use a delete command. Where is the delete command? Delete from employee. And this will remove all the records from this table, and this is a DML command because it's dealing with data. It has something to do with the data rather than structure. Now, alternatively, what we can do is we can truncate this table. We can say truncate table employee. And done. What this will do, if I do a select star, you can see it has removed all the records or truncated all the records. So truncate also removes all records or deletes all records. But this is a DDL command. You might not be expecting this. You might think that okay, it's removing the records, then how come it has something to do with the structure but not with data? I'm saying it's a DDL command. So you might be confused that okay, what is happening when we are doing a delete and what is happening when we are doing a truncate, because the results that you see are the same. There is no difference in the result. For you, what you see is that even delete is removing all records, truncate is also removing all records. Then what is so different about it? Let me give you a rough idea on this. When you do delete, which is a DML operation, it deletes the records individually one by one. So it has something to do with the data itself. But when we do truncate actually drops the table and recreate the table. So truncate internally drops the table and recreates it. So do you feel it has something to do with data now? Yes, of course. And this is a much more efficient operation. Let's say you have billions of records in a table. So rather, if you want to remove all the records, you would like to do a truncate rather than delete. Why? Because delete will be inefficient and will take a lot of time. But truncate will be quick because all it has to do is drop the table and recreate it. That is why truncate is a DDL command. There will be other differences between delete and truncate, but for now I will leave it at here and we will talk about other differences sometime later. So all what I wanted to convey is delete is a DML command and truncate is a DDL command because of the way both command works. Eventually you see the same results, but if you have a lot of records in a table and you want to delete all of them, you should prefer truncate because it will be more efficient. I hope this is clear. So what all have we seen in this session? We saw how to use select and select all columns using star, select specific columns by specifying the column name list. We saw how to get only few records by applying a where clause filter condition. Also we saw how to get a alias using as keyword. Then after that we talked about update, where we say how to set something based on certain condition. We talked about delete, where we saw how to delete a record based on certain condition. And we talked about alter command, where we are dealing or changing the table structure. We are either adding a column, dropping a column, adding a primary key, dropping a primary key, or we are changing the data type, anything of that sort. It is something to deal with structure. And then based on whatever we have learned, we understood what DML is and what DDL is. And we differentiated both. And we concluded where we understood delete is a DML command and truncate is a DDL command because of the nature they work internally. So this was quite a lengthy session and informative session, I believe, and I hope you have liked the session. So in the next session, we will continue our discussion on further topics and I hope you liked it. So friends, I hope you have liked the session. Do mention in comments if you have any feedback. I would incorporate that in order to make the sessions better. If you have still not subscribed, what are you waiting for? Do subscribe now. Hello friends, welcome again. This is the session 5 in the SQL playlist, and in this session we will talk about what is a foreign key constraint. Foreign key constraint. I won't give you any definition at this moment, and we will try to build a scenario through which I will explain it first and then I will give the definition. So let's quickly start with it. So let me take a scenario that I am a edtech company and a lot of students do register for my big data course. As you know that I have a edtech company named TrendyTech and a lot of candidates register for my course. So consider we have to create a table for that and I want a students table with these all columns. What are these columns? Let's quickly see. I want a unique student ID like a roll number. I want to capture student first name, last name and middle name. I want to capture student email, that is the email address of the student. I want to capture student phone number, alternative phone number on which let's say WhatsApp is available, something like that. Enrollment date, that means let's say if someone is enrolling today, then today is the enrollment date. Might be they are joining for a future batch, but when they have enrolled, right? So today is, let's say, 25th January. So 25th January would be the enrollment date. And they might take my batch which is on 5th Feb. That's okay. Now also we capture years of experience. For example, if someone is joining my course, we ask them how much experience do they have, like 8 years, 9 years, 12 years. This helps us to do some analysis that, okay, what's the average experience of the, I mean, people who join our course, something like that. And then we also ask for company name in which they are working, but this is, we do not keep it mandatory because, I mean, some people might not find it right to tell. And why we ask is because, let's say, if there are any drives in those companies and all, we can contact these people. Now apart from that, we do ask for the batch date, that for which batch they want to join. Let's say if someone is enrolling today and they want to join for 5th Feb batch, right? So enrollment date is today, batch date is 5th Feb. Source of joining, we just ask them, okay, through which source you got get to know about us. For example, is it LinkedIn or YouTube or Google, something like that, so that we understand that how exactly candidates are getting to know about us. And then of course we ask from which location they are. Okay, so I want to create a table based on these columns. So let me quickly take this and try to create a table. So create table student ID. Let me see if recording is happening. Yeah. So create table, and then uh, what name I have to give? Let's say students, and then I can start creating this definition. How do I create student ID? What would be the data type for this? This would be int. Do we have to manually enter this? Because I understand that this will be unique or like a primary key. So it's better if we can give like a auto increment, so that we do not have to manually give this. Okay. Student F name. First name would be of course varchar, and I would say, let's say 30 characters, even though 30 might not be required, but let's give it. And I'm saying this should not be null. The first name of course cannot be null, not null. We are using a not null constraint. Last name again should be the same way, should not be null. How about this middle name? This, of course, we do not have to put this constraint of not null because some people do not have this middle name. For example, my name is Sumit Mittal. I do not have a middle name. Student email. Of course, this should be again string type varchar and should not be null. Phone number. You might think this is integer, but see this way, that would you ever add two phone numbers? Add in the sense, do a sum operation on that? No. You do not have to treat it like a numeric value. So it still can be a string for you. So varchar 30 of not null, because this should also not be null in any case. Alternative phone number. We can just give varchar of 30. This can be of course null. Not every person will have that. Okay. Now after that, enrollment date. And this even phone number, do we require 30 characters? No, probably 15 is good enough. Enrollment date. Now enrollment date, here we require timestamp data type. Timestamp is current date and time. So whenever this record is going, it will take that time, whatever it is. So I would use timestamp data type. So this is beyond the two data types we have talked about. What two data types we have talked? We have talked about integer, that is int, and we have talked about string, which is varchar. Now timestamp is one more important or also an important data type which is used. Now again, enrollment date should not be null. Years of experience. Of course, this will be integer, like 3 years experience, 5 years, 10 years, like that. Okay, and this should also not be null. Student company, of course, we cannot force a student to fill that. This will be varchar of, let's say, 30. And of course, this can be null because we are not forcing someone to fill this. Batch date. Batch date, again, varchar 30, but should not be null. Batch date would be something like, I would say, uh, like 5th Feb batch, 5th Feb 2021 batch, something like that. We'll see. Now, source of joining, that how does this student get to know about us? This will again be varchar 30 and not null. Okay, source of joining. Now, location would be again varchar 30 and should not be null. So quite straightforward. We are doing this and this is it. We have created this definition. Now what I would do is I will go to my IDE and first of all I will drop drop database and detect. I want to start fresh. Okay. Create database trendy tech. I've created now. Let me create this table. First, I will say use trendy tech so that I want to ensure I am connected to this database. And now to clear the screen, I have to say Control L, Control plus L key. Now I would paste this definition. Okay, looks like I have not pasted the entire thing, or copied the entire thing, sorry. And let me copy and paste. It says incorrect table definition. There can be only one auto column and it must be defined as a key. Let's see what we have done. Okay, of course. So whenever we are doing this auto increment, we have to give it as a primary key. In this table, what we want to be as the primary key? Primary, or I can just mention it like this, primary key. And then which column do I want as the primary key? Student ID. Okay. And also this email address, I do not want duplication in that. So we can have it as the unique key. How to do? Unique key. And then I should say student email. Now let me take this and run. You can see this. This has worked. Now I can say describe DESC students. And you can see the structure of the table. We have one primary key which is student ID. We have one unique key which is student email. All the data types are shown. Whether the column is nullable or not nullable, it is shown, right? And student ID, as you know, is auto increment. And this timestamp column, that enrollment date, if we do not give anything, it will take the current timestamp. It will take the current timestamp. That means whatever time it is right now, along with the date, it will enter that. I hope this is clear. We'll see it practically. Do not worry if you cannot understand at this moment. Let me clear the screen and go back. Now what we will try to do is we will try to enter some seed data. Generally we use this word seed data to talk about initial insert statements that we make as a whole in a bulk, right? So we say this data is seed data generally. I do not know the official definition of seed data, but generally you will find this term used a lot, that this is seed data. That means initially when you insert something in table in one go. Okay. So I have this insert statements with me because it will take a lot of time to type it. That's why I have this notepad. Let's understand. Insert into students, and I'm not giving the first column here. I'm not saying student ID because automatically it will take it, right? It will start from 1 and it will keep on incrementing that. Also, I'm not entering enrollment date because if I do not give this, it will take the current date and time. So that's also okay. So you can see student first name, last name, email, phone, years of experience, company, batch date, source of joining and location. And then I am giving values. And since I am fond of cricket, I have used the name of cricket famous cricket players. For example, Rohit Sharma, right? Rohit Sharma won't be joining my big data course, but still, I mean, that's an example for you. So, Rohit Sharma, his email ID is rohit at gmail.com. His phone number is this, some random number. And then, apart from that, uh, he has 6 years of experience. He is working in Walmart and he has registered for 5th Feb 2021 batch because my next big data batch is on 5th Feb 2020. So basically it should be 22, but in this case let it be. Okay, so sometimes we do not get used to the new year, right? So that's how it is. And Rohit Sharma got to know about my training through LinkedIn, through his connections, and he stays in Bangalore. Similarly, we have other records also. Another one is Virat Kohli, Shikhar Dhawan, and then apart from that, Rahul Dravid. And again, we are also talking about multiple inserts. I mean, single insert with multiple insert values. So this is there. I would not talk much about insert because this is quite self-explanatory. Let me quickly run this. First of all, this three inserts. And now let me even run this multi-insert. I think semicolon I have to give towards the end. Okay. I have run all these inserts. I have not done anything so special. Let me try to do a select star on this table. Select star from students. Oops. Since we have a lot of records, right? So that's why, I mean, the columns are overlapping. That means it's not able to fit in one row. So to see it properly on this terminal, we will use this select statement where we are not like pulling out one or two column. We are skipping, for example, the phone number. What analysis can we do on phone number, right? I'm skipping that. You can see this. So only why I'm not doing select star and selecting only certain columns so that it can fit in one screen. That's the simple thing because I want to demonstrate it cleanly. So you can see student ID is auto generated, right? Enrollment date. This is something what is current timestamp. Right now, if you see here, it is 6/7, 25th January. Now it is 25th January, but you see, time is not 6/7. Why? Because we are talking about UST time. UST time. What is the current UST time? 12:38. And what have we got here? Almost same. So basically, we are referring to the UST time. We are like few hours ahead of that, 5.5 hours ahead of that, right? So we are talking about UST time here. Student name, email, years of experience, company name, batch date for which they have joined, how did they get to know about Trendy Tech, and location from which they have joined. All of this. I hope this is clear. Okay. Now let me clear the screen. All this structure is good when we have one single course of big data. But what if tomorrow I want to start some new courses, let's say data science, DevOps, web development, and things like that? Then, of course, things will change slightly. Let us see. So, what will happen in that case is, in that case, you will have one more table called as courses table, the course table. And that course table can have some columns like, let's say, course ID, course name, it can be course duration, and let's say course duration is in months, course duration in months, course fee, and there can be many other columns, but let's limit it to this. So these are the things that will be there in courses table when we have multiple courses. How to create a table? Create table courses, okay, and then we do this. Now among this, first of all, course ID, what data type will it be? It will be integer type, not null. Course name, what data type? Varchar, let's say 30, not null. It cannot be null, of course. I forgot comma here. Okay. Course duration. Of course, this will be an integer because it's in months, integer and not null. And course fee. Course fee again will be integer and not null. Among this, what will be the primary key? Course ID is something which will be unique, right? So we can keep it as the primary key. We can say primary key course ID. This is what we can do. And we have this courses table which we can create now. Done. I have created a courses table. Now in this courses table, let us insert some seed data. So I want to insert that, okay, there is something called as course ID 1 and the course name is big data and duration of this course is 6 months and let's say the fees is 50,000. Insert into courses values 2, web development, and the course duration is 3 months, the price is 20,000. Data science course, 6 months course, 40,000 fee. DevOps course, 1 month course, 10,000 fee. Randomly I have put in. Right now I do not have any of these courses apart from big data, but let's say tomorrow if TrendyTech scales up and creates these courses, then this can be one table structure, simple table structure. Now let me first put it here and then try inserting this. Okay, and I cannot repeat this one again because it's a primary key. I hope you can understand this. Now what if someone is enrolling as a student? I mean, we should ask, right, for which course they have enrolled. That should be there now. So this definition of students table will slightly change. Let us see that now. So what we will do is we will drop the students table, drop table students, and we have to recreate it. Let me copy this definition and then we will just add one more column. What will be that column? Just think of it. Selected course, right? Selected course, you can keep it anywhere. Let's say I'm keeping it here. Selected course. That means for which course they are opting. And I mean, course ID is of course integer, right? We had course ID 1 for big data course, if you can recall. So selected course, which is integer type, and of course it should not be null, not null, not null. And let's say big data is one of the famous course. Other courses hardly people register. Most of the candidates enroll for big data. Then we can keep it as a default this thing. That means default value can be 1. 1 is for big data. That means if I am not entering any value for selected course, that means by default it means that candidate has registered for big data course. Makes sense, right? Okay. So let me drop the students table and then let me create the students table with the new format. Slightly the syntax has changed. The structure has changed. Nothing much. So we have created the new table now. Okay. Next what? We should again insert the seed data for this, and this insert statements will be slightly different than the previous ones because these insert statements would have one more column called as selected course. If it has it, then manually whatever we are entering, that value will go. If we do not give it, by default 1 will go, right? So I do not want to type all of that, so I have this insert statements ready. So for example, here we say that this candidate has enrolled for course ID 2. What is this course ID 2? Web development. This candidate has enrolled for big data course only because we have not given. By default it is 1, right? And so on. So I have certain records. Let me quickly insert. First, let me do all of this. Clear the screen and let me do this multi-insert. Okay. And I will say, I will do a select star now. Instead of select star, I am doing selecting some columns. Only reason is because if I do a select star, it won't fit in one screen. You can see this. All of this, that selected course is 2, 1, 3. That means wherever you see 1, these people are for big data. Wherever you see 2, that is for web development and so on. I hope this is clear. Now, you are selling 4 courses: big data, web development, DevOps, and data science. What if someone mentions 5 here? In the sense, this record, if you see, here I am saying I want to enter course ID as 5. Is course ID 5 there? I mean, do you offer such course which has course ID as 5? No. Now what will happen if I enter this record? Will it go or not? Will we be able to enter this or not? I am saying this person, Jasprit Bumrah, right, one of the best fast bowlers, he is opting for a course whose ID is 5. We are not selling such course. We do not have any course with course ID 5. What will happen if you insert this? Nothing. It gets inserted. Do you feel this is right? No. Because this is not right. How can someone join for a course which is not available only? But system is taking it. How do system know about it? That is where the role of foreign key constraint come into play. I will explain that, but I hope you get to know what is the problem statement. Right? If I say select star from courses, oops, this courses should be lowercase. We offer 4 courses, course ID 1, 2, 3, and 4. And Jasprit Bumrah joined a course with course ID 5. How is that possible? Right? But system has taken the details. If I show you a select star on the students, you will be able to see that. Okay. If you see here, selected course, let me just do a control. Now you can see Jasprit has joined for course ID 5. And this is there in the system now. But we know somewhere we have gone wrong. So we will try to correct it using foreign key constraint. Okay. I have to again do Control L to clear the screen just so that you can see everything on one screen. Fine. So let me go back to my actual notepad. I hope you understood what I am trying to convey, that what is the issue. Just have a look at this create table statement. Okay. Now, just to clean all of this, we have to drop this students table. Drop table students. Why we have to drop? Because we know somewhere we have gone wrong and we have to redo it. Let me first drop it. And let's think what we have to do. I will again copy this definition, put it here, and then now time to investigate that what we have to do. Now you know that this selected course, this selected course column is something which we want to check whether it is a valid course ID or not. If it is in course ID, then it is fine, otherwise not. That means we have to put a constraint on this selected course. How to do that? We will see. We can say foreign key, foreign key. Okay. And then I will say selected course. I will explain you this. Do not worry. Foreign key selected course, and to which table we want to check, or in which table we have to first of all say references. That means it has to refer somewhere. References, which table it has to refer? Courses table. And in courses table, which column it has to see? Course ID. That means we are saying that this selected course is dependent on courses table course ID column. Right? That means we should refer courses table course ID column to see whether it's a valid one or not. If it is not there, then you will not be able to insert it only. Right? So in this case, which one is the parent table? Parent table will be your courses table because we have a dependency on that. And which is the child table? Students table. This is a dependent table. If something, or if a course ID is not there in courses table, then of course you won't be able to insert a record in students table. So I would say the parent table is which one? Courses. And child table is what? Students. Right? So the dependency is on courses table. Now let me take this and run this. Done. Let me say describe students. What do you see now? On this selected course, you have some constraint which you can identify that something is there now. That's fine. Now, what I will do is I will try inserting the records again. Let me go here and take the same insert statements, whatever I did. First of all, let me do all of this. And then let me take the multiple insert ones. All of this is fine. Okay. Everything is inserted fine because nothing was wrong. We tried to insert students who have joined either course ID 1, 2, 3 or 4. But the moment we try to insert this record, Jasprit's record, who is selecting for course ID 5, we will get an error. Let me show you that. What does it say? Cannot add or update a child row. A foreign key constraint fails. Right? And then it is giving more details about it. This is where we are ensuring that data is valid. We do not end up entering invalid records, because it does not make sense that a candidate is joining course 5 when course 5 is not even sold, right? So I hope with this you should have got a clear cut understanding. You will be able to enter records only when course ID is among 1, 2, 3 or 4. If you have more courses, then of course in students table you will be able to enter those also. Just have a look of what I have mentioned and also see the table definition. This one. Now, what I will try to do is, first of all, I will say select. Let me reduce the size of it. Select star, not star. If I do a star, it won't again be proper. I have to select the columns only. Okay. Reducing the size. Only reason is so that it can fit on screen. Now also it has not fitted in. Now, now if you see, there are people who have opted for, I think in this one we do not have this course ID. So we have to add course ID also. That will be a different select. Let me quickly check that. Okay. If you see selected course 2, 1, 3, right? That means some people have opted for course ID 1, big data. Some people have opted for course ID 2, which is web development. And some people have opted for course ID 3, which is data science, right? No one has opted for course ID 4. 4 is not opted till now. Now with this, I want to show you some important things. What if I want to say that I want to discontinue the course ID 2? That means I want to discontinue my uh, web development course, because the one who was teaching web development is not, is going somewhere. The trainer who was teaching web development is saying that I won't be able to teach and please discontinue this course. Then what I'm trying to do, select star from, not sorry, delete from courses, delete from courses. This ID sometimes behave weird. Just a second. Delete from courses where course ID equal to 2. What will happen now? Do you feel it will work? Do you feel this will work at this moment? Just think of it. Is there anyone who is enrolled for course ID 2 in the students table? Yes. Then if we are able to delete it successfully, then don't you feel that record will become invalidated? Right? That will become bad data. That is why this will give you an error. And this basically is a violation of foreign key constraint again. Since there is a record or there is a student who has opted for course ID 2. What if I do the same for course ID 4? Right now, there is no one in our students table who has opted for this DevOps course. So it won't give any issues and we are able to delete this. So I hope you would have got a fair enough idea of what I am trying to say. So I took such a big scenario in order to explain you that how exactly a foreign key constraint works. Now let's talk about bookish definition. I have given you a practical overview. Let's talk about a bookish definition or a more theoretical way of saying it. The foreign key constraint, I'll write it. The foreign key constraint is used to prevent actions that would destroy that would destroy links between two tables. Of course, you have seen this practically. I do not have to again tell that how it happens, right? So foreign key is a field. A foreign key is a field. A foreign key is a field in one table that refers to the primary key in another table. Right? It's a field in one table which refers to a primary key in another table. In this case, whatever we have seen, what was the primary key in courses table? Course ID. And what was the foreign key in students table? It is selected course. So the course that a student is selecting, the selected course is a foreign key which refers to the primary key course ID in courses table. So I would say selected course is a foreign key in students table which refers to course ID, which is nothing but a primary key in courses table. I hope this is fine. The table with foreign key is called the child table, and the table with primary key is called the parent table. The table with the foreign key is called the child table. The table with primary key is called the parent, or even sometimes we say reference table. Parent or referenced table. Okay, so with this we understood that what is a foreign key constraint. We have talked about other constraints also earlier. If you can recall, we talked about not null, constraint, we talked about unique key constraint, we talked about primary key constraint, we talked about foreign key constraint. Foreign key, primary key, unique key. Okay, this all we have talked about. So what do I mean by constraint? Why am I using this word constraint? See, basically constraint means we are defining some rules. Only based on that data should go. If the rule is not satisfied, data should not go in a table. Right? So basically constraints are used to limit the type of data that can go into a table. We have seen that practically with any of this. For example, if a primary key is violated, we won't be able to enter the data. Similarly with foreign key, similarly with unique key, similarly with not null constraints and things like that. Okay, so what's the benefit of this? This ensures the accuracy and reliability of the data is maintained in the table. If there is any violation between the constraint, then the action is aborted. If there is any violation, right, then the action is aborted. So this is what we have seen. In other databases other than MySQL, there is something called as a check constraint also. Check constraint. Check constraint. What is this constraint? Just to let you know, first of all, it does not work, or it's not supported in MySQL. Not supported in MySQL, right? There might be some variants in MySQL where it can be supported also, but with the one that we are using, it's not supported. And check constraint is something like we can say that okay, if there is a age column in students table, the age should not be more than let's say 50, right? Or if there is a employee table, we can say the age cannot be more than 150, because we know ideally based on how things are, a person cannot live more than 150 years on a idle note, right? So that's why we put a constraint that okay, if someone enters more value, then we do not have to take it, right? So it's like a check constraint. That means whenever we are entering some values, it will try to check whether it is less than 150 or not. If it is less than 150, it will accept. Otherwise, it will say the check constraint is violated. Things like that. But it's not supported in MySQL. That's why I have not demonstrated, but quite easy to understand. So with this, we understood what is a foreign key constraint, and we have covered almost all the constraints which are supported. With this, let's wind up the session, and I hope you liked it. Thanks a lot. Hello friends, welcome again. This is the session 6 in the SQL playlist. Okay, and in the previous session, as you know, we talked about foreign key constraint, and we just did a recap on the kind of constraints that are allowed in SQL. In this session, we will talk about four things: the distinct, order by, limit, and like. So let's get started and see it practically. So, to start with, we should have the students table ready. In the last session, we created a students table and we inserted few records. Make sure it should be there. Then only we will be able to practice. So I have my IDE open. Let me just see show tables. Show tables. I have students table and I have the data too. So I can say select star from students just to see if some data is there or not. Yes, there are around 8 records. So we are good to go and let's get started. So first I will talk about the distinct keyword. Distinct. Let's say I have a problem statement that I want to check that from which all locations the students are joining. Like in India, there are various cities: Bangalore, Hyderabad, Chennai, a lot of cities and other places, towns, right? I want to know that from which all locations are the students joining. Then I might say select location from students table. This is what I would do. If I do that, what will happen? Let's see. I get Bangalore, Hyderabad, Bangalore, Chennai, Pune, and Chennai. But you can see there is a redundancy. I just want to know from which all cities people are joining. Then I do not want redundant data. Pune should not come 3 times, right? Bangalore should not come 2 times. How to get this done? We can just use the keyword distinct. We can say select distinct. Ideally, keyword should be in uppercase. Distinct location from students, right? So this is what we can do. Let me just copy this and put it here. And you can see in this case, we are getting only, I mean, one time, the data is coming only one time, not, it's not duplicated basically, right? So we just use the keyword distinct like this. Now let's say I might have another problem statement saying, okay, a lot of students are joining my big data program. From which all companies are they joining? I mean, in which companies they do already work. Then I might say select distinct. I mean, let me just take this query and then just change the main part. So instead of location, I would say student company. because student company was the column where students have mentioned which company they are working. And this might have null also because this was not a mandatory column. So we can see that, okay, students are working for Walmart, Flipkart, Microsoft, TCS, and Wipro. All of this coming one time. But if I do not use the distinct keyword, then you can see a lot of duplication in the data. You can check this out. Wipro coming two times, right? And similarly, Walmart coming two times, like that. I hope this is clear. Let me clear the screen. Fine. Now, what if I want to see that, okay, from which all sources people are getting to know about me? Might be some people get to know about me from LinkedIn, some people get to know about me from YouTube, and things like that. I want to see all those sources. I can say, let me take this, and instead of using student company, I can say source of joining. Source of joining. And if I do this, it says people are joining through LinkedIn, Google, Quora, Friends, that means referrals, and YouTube. So this is how you can use the distinct keyword, very easy to understand. Okay. So now we have covered distinct. Let's talk about order. Order by. Now, what happens when I say select star from students? Or let me not do select star because I mean it won't fit on the screen. Just for that reason, let me just show a less number of columns. Okay, right now also it's not in one screen. Let me again reduce the size. Okay, so this is how it is. Now, when you see here, for example, when I'm entering this, it does not give me the data in any order as such. The data is not in any order. For example, if I say select, let's say student F name, student first name, student F name from students. Now I am getting this data. Is it in any specific order? No. This is just randomly given to me. Right? So what if we want to apply some ordering to the data? Then we have to use this order by clause. So order by is mainly for this ordering. We have used this query, right? So location from students, and we can say order by, and then years of experience. That means I want to, let's say, list them down in terms of years of experience. Let me again show you that. Now, right now, when we see the years of experience, you can see that, okay, 6, 3, 12, 8, 15, 18. Is it in any order? No, not at all. What if we want to sort these students based on this order? How do we do that? So we say order by uh, years of experience. Years of experience. We just add this clause, order by clause, and then let's see. Now you can see by default, I mean, when we are using it, the data is sorted based on years of experience in ascending order. That means smaller one will be at the top and the highest one will be at the bottom. I hope this is clear. Okay. Similarly, we can say what we can say, select student F name, select student F name from students, order by student F name. We should see all this in, dictionary order basically. B is first, C is second, and all of that. So you can see it's arranged alphabetically that way in terms of the dictionary order. Now, what if I want to have the student names, but I want to order based on experience, order by years of experience? Will it work or not? Why I'm asking this is because this years of experience we are not selecting as a column. So will this work or not? I am basically saying the person with least experience should be at the top. This will work. That means this order by whatever we are having need not be a part of select statement. This need not be a part of select. This can be demonstrated through this example. I hope this is clear. Okay. Now along with that, if we want to have years of experience also, we can do student F name, comma, years of experience. So this is how we can do it. Similarly, we can like sort it based on enrollment date, like based on whenever they have enrolled and things like that. Now, what if I want the person with highest experience at the top, right? That means Carl should be at the top and Virat should be at the bottom. Then what should I do? Same query, it's just that I say order by years of experience DESC, means descending order. Right now, by default, it is ascending order. But if we want to sort it based on descending order, we can give this keyword DESC. And we can see this will work fine. Also, a variation to this, when I say order by, I can even mention the column name. For example, this is 1 and second one is 2. I want to sort it based on years of experience. That means I want to sort it based on the second column, order by 2. This will also work the same way. And if I say order by 1, it will sort it based on student first name. You can see this. I hope this is clear. Now, let's consider that I want to, let's say, for example, I will write a query. You tell me what kind of result you should expect from that. Let me copy it in my notepad. So select student F name, comma, years of experience from students, order by years of experience, comma, student F name. What kind of result or what result will you expect from this? What will this query do? So basically what this will do is, first it will order by, where is this keyword by, order by. First it will order by years of experience. That means people who have the lowest experience will come at the top, right? For example, someone with 3 years of experience, another person with 3 years, then 4 years, 5 years, 6 years, 8 years, right? Another person with 8 years, like that it will sort. Now, for the people who have the same experience, like 3 years, it will then do a second level sorting based on their first name. That means Brian might come at first, Brian, and then Carl, right? Like that, things like that. So it's a two level sorting. Second level sorting will work when there is a clash. That means whenever we have the same thing for the first column. Quite easy to understand, and you can just try that out. Since we do not have data that way, that we have duplicates in years of experience, we won't see it as of now. Okay, so with this we are kind of, we understood like how order by works. Now let's try to understand limit. How does limit work? So what if I say select star from students and I just want to get 3 records. Then I can say limit 3. First, let me clear the screen so that it's properly coming up. Select star from students, limit 3. This student, okay, this is students. Now this is giving me 3 records. I mean, do not worry about this view because we have a lot of columns, so it's the view is messed up, but that's fine. This gives us 3 records, but in which order it gives, right? So select star from students limit 3 does not give us any relevant data as such. What 3 records are we looking at? If you just want to check whether some data is there or not, then it's fine. But otherwise, it's not logical to do select star from students limit 3. I mean, you might be specifically looking for some particular 3 records. Limit does not guarantee this way that you get certain kind of ordering or something in place. So limit has to be used along with order by in order to get the proper results. We will see that now, right? And what I'm saying, I want to get or sort the students based on years of experience in ascending order, right? Now I want to say that I want to get 3 candidates who have the lowest experience. So get 3 candidates with least experience. If this is a problem statement, then the same query you can take and then apply limit 3. Limit 3. This will definitely give us the results that we are looking at. Because already before doing the limit, data is sorted in ascending order. It will give us the first 3 records. Let's see. We can see this. We have got the 3 students with the least experience. This person has 3 years of experience, this person has 6 years, this person has 8 years. I hope this is clear. That means if you're using limit, alone limit won't make sense. If you use it with order by, then that's more logical. Now, what if I want to get 3 people with highest experience? Then I can say order by years of experience, DESC, descending order, limit 3. Let me try running it. So we can see Carl, Brian, and Kapil are the people who have the highest experience, 20 years, 18 years, and 15 years. Right? So that's how this should be. Now, what if I want to, let's say, let me take a scenario. For example, I want to get source of joining for the students, right? And basically, what I want is for the last 5 people who have joined my course, I want to see from which sources they have joined. How do I write a query for that? So first of all, problem statement is want to know that from which sources last 5 candidates have enrolled. That means last 5 candidates who have enrolled for my training, I just want to see how did they get to know about me. Is it through LinkedIn, YouTube, and all? Then how do I write a query? Select source of joining, source of joining, source of joining from from students, from students, order by enrollment date, DESC. That means we want to do it in descending order. That means people who have enrolled very late, right? I mean now only will be at the top, right? And from that we want to get source of joining. Okay, and I want to limit it by what? Limit it by, let's say, 3 or 5, whatever. Last 5 people who have joined me, I just will get the source of those. So Google, YouTube, Friend, YouTube, LinkedIn. Right? These are the sources of those 5 people. What if I want to remove redundancy from this? I am trying to get a holistic view that from which all places people get to know. I do not want YouTube to come 2 times. How do we do that? We can use distinct. Select distinct. Okay. Select distinct source of joining from students order by enrollment date DESC limit 5. But this won't work. This won't work. This is giving me an error. Now, the next session that we will do, in that I will explain that why are we getting this error. I will talk about lot of internals in the next session, right? Because I do not want to spend time in showcasing that here. That's alone a 20 minutes topic to discuss. So why are we getting this error? I will discuss in my next session. So let's continue. So I'm saying this query won't work. This query won't work. And that will be a discussion for later topic. Now, let's say I want to get the candidate who, the candidate who is the last one who has joined. The last candidate who has joined me, let's say. Then what should I do? I can take this query, order by, it should be enrollment date, DESC limit 1. That means this will give me the candidate who has joined at the very last. Let me try running it. And this candidate is Saurabh, who has enrolled, after everyone else has enrolled. Okay. Now, there are other things. For example, I will just write a query and then explain. Select star from students, order by, enrollment date, limit 0, 3. Now you might be surprised what syntax I have written. 0, 3. What will it do? If we write limit this way, where we are giving 2 parameters here, kind of. So basically, this 0 says that we want to start from 0th row. 0 means first row, right? It starts that way. That means first row is called as 0th row, right? And then we are saying, give me 3 records from there. So basically, this is something like equivalent to limit 3 itself. It gives you the first 3 records. It gives me the first 3 records. So in this case, if I run this, I will get an output of students who, or the last 3 students who have enrolled. Last 3 or first 3? First 3 in this case. If I give order by enrollment date DESC, it will be the last 3 candidates who have enrolled. Now let me make a small tweak to this. So let me remove this DESC. This basically, you understand that the query that you see here would give you the first 3 candidates who have enrolled with you. Now, what if we write something like this? What this query will give us? This one. This says that we want from 4th record onwards, because 0 means 1, 3 means 4. So from 4th record onwards, we want 2 records. That means 4th and 5th record will be given as output. So these are the candidates, who have joined at 4th and 5th place, right? 4th candidate who joined or enrolled in your program and 5th candidate who is enrolled in your program. This will give us that. So I hope you get some idea, but these queries are not that popular. Generally, we write queries something like limit 3, limit 5, things like that. And mostly it's used in combination with order by, so that we get logically correct outputs. So this is fine. Now let me talk about Now, you know that we use where clause where student name equal to something and all. There it does the exact match. But what if you do not want to do exact match? It's like to some extent you want to do a fuzzy match kind of. For example, give me all the students whose name starts with RA. That can be a fuzzy match, right? It's not exact match as such. So how do you write such things? That's where you use like operator. So let me just copy this. Okay. Now I want to get all the student names, right? Or all the students whose name starts with RA. So then I will remove this order by and all, not coming into picture from students where student F name like like and then I have to give here I'll explain this percentage RA percentage. So this is how we give it with respect to the where clause where student F name instead of saying equal to something we say like. So equal to is replaced with like and this is how we write it. Percentage means that it can match 0 or more than any number of characters basically. That means basically what I'm trying to say is it matches either 0 characters or more. Anything should can be there. After that RA should be there and then anything can be there. So if we are doing this, that means their name contains RA at any place. So even if it's something like, so let me run it and show. Any at any place if RA is contained in the name, it will show. So we can see this Virat, Rahul, Saurabh. Here also RA is there, RA. Rahul starting itself is RA and here Saurabh also RA is there. So it does not matter wherever it is, but before RA there can be anything, after RA there can be anything. That is what is the meaning of percentage, right? It's called as a wildcard character. So percentage is a wild card character indicating that it can be anything. Now, what if my problem statement is I want to get all the student names whose names start with RA, right? Whose names start with RA. Then in that case, what I will do, I will remove this percentage. Then only I am saying, okay, RA it has to start with, and then it can be anything no matter what. So let me try running this. Only we have Rahul. There is no other student whose name starts with RA. Okay. Now, let me say that I want all the student names whose name end with AT. Whose name ends with AT. Okay. So what I have to do here, at the end it will be 80 and before it, it can be anything, percentage. As simple as that. So Virat is the only one whose name ends with AT. Okay. I hope this would have given you a clear-cut clarity. Now, what if I want to get all names who have 5 characters in their first name? Who have only 5 characters in their first name? What I can do is where student F name like, in such cases we can say underscore, 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 underscore. I have given 5 times underscore. Underscore is the next wildcard character which says exactly one character, it can be anything. So when I've given 5 underscores, what I'm trying to say is that it should be exactly 5 characters, but those characters can be anything, no matter what. So this should give me all the student names who have 5 characters in their first name. Let me see this. Okay, Rohit has 5 characters, Virat has 5, Rahul has 5, Kapil has 5, Brian has 5. Let me check for 4. Let me remove one underscore. I'm not sure if anyone will be there, but let's check. Okay, Carl is there. So this will give you an idea that how exactly this wildcard characters operate. So percentage is a wildcard character, even underscore is a wildcard character. This means either zero or more characters. Underscore means exactly one. Exactly one character. Okay. Now, what if you want to, let's say, on an extreme scenario, that your data itself has percentage? Let's say you are doing something and uh, the name itself is, let's say, Rohit percentage or Rohi percentage T. This is the name. See, this does not make sense, but let's say we are using something where this kind of names are there. Then when you have to use this like operator and this percentage we have to do, then how do we know whether this percentage of data, is it this percentage that you are giving or is it from data? So such things we can avoid using the escape character underscore, sorry, escape character backslash, right? We can escape it using this. I hope you get it. So for example, let's say I want to get someone whose name ends with percentage 80, then I can say backslash percentage 80, because when I am giving this backslash, this percentage is treated like a data point like a or t. So this says that I want all students name whose name ends with percentage 80. Similarly, we can give underscore also, all names whose name ends with underscore 80, things like that. So backslash is the escape character. You give it in order we can tell the system that do not consider it like a wildcard character. It's not a wildcard character. So this should be fine. So what all have we learned in this session? We have learned distinct, so that we remove the duplicates, right? So that all duplicates are shown only once. We saw order by, so as to order the data either in ascending order or descending order. We saw limit. Limit alone does not make sense. We use it with order by to get the top three, bottom three, things like that. And we saw like to do a match which is not exact, which is like to some extent we are saying, okay, give me things which look like this, something like that. So this is quite an important session and will be helpful in industry. Definitely these things are used a lot. So just make sure you practice this and I think we should be good. So with this, let me stop the recording and I hope you like the session. Thanks a lot. Hello friends, welcome again. This is session 7 in the free SQL playlist. And in the last session, we encountered a issue where this query which you see on the screen was failing. Right? This query was failing and we said we will cover the reason in the next session. And that's why I have created this session for you so that you can understand the internals that what exactly is going on. Now, select distinct source of joining from students, order by enrollment date DESC. That means we are doing distinct. So both distinct and order by are in the same place or in the same query. Why won't this work? Let us see. Let me take it from the very basics of it. Let's say I write a query select source of joining from students. Let me name this in small, source of joining. Let me copy this. Okay, select source of joining from students. If I run this query, how exactly this work? work, what will happen first? So always remember that from is executed first. So the order of execution of the above query is first we will or first from will execute and then select will execute. That means when we say from table, that means it's like loading the table kind of. So think like loading the table. Loading the table. Like select star from students. We get that. The complete table is loaded. After that, when we are doing select, this one, we are doing a projection. Projection means what all columns we want to show. Whether we want to show all columns or one column or two columns, what are those? So now when we say select source of joining, so we are projecting only one column, which is source of joining. I hope this is clear. So this is how this query works. Now what if I add, let's say, something like select source of joining, comma, let's say enrollment date. Okay, from students. Then how exactly this order of execution would be? It would be almost the same. That means first it will load the table, right, students, and then next it will do a projection on these two columns. So projecting these two. Fair enough. Now what if I use order by clause? I use a order by clause. Okay, I say select source of joining, comma, enrollment date from students, order by, and then I give some sorting field, whatever. Let's say enrollment date. Now in this case, what will be the order of execution? We have added order by also. So let me just take this one. Right, so of course the very first thing that happens is from and then select. You can see here, so selecting will be again these two, and then order by will be the last thing here. Order by. Now this will order by based on enrollment date. So based on enrollment date, it will order by. So basically when we are saying loading the table, it's like select star from students. Now you have lot of fields or columns. When we do a projection, we get a limited columns only. That means we discard all the other columns and say that we just want these two. So select from students, right? And then now in this step 2, the data is still unordered. That's why in the third step, it will be ordered based on enrollment date. So it will be, the order by. So select this one, order by enrollment date. I hope this is fine. And if I run this query, for example, this one, this will work. Let me just show that. I am in my IDE. So we can see that this is working. Now, interesting thing is that what happens when we slightly tweak this query. Let's say I do not want this enrollment date here, but I still want ordering on enrollment date. What will happen? Now, what you might think is, based on the previous approach I have showcased, let me just copy this and then I will tweak this slightly. So what should be the order of execution for the query I am showing? It would be, first of all, from, that means loading the table, select star from students, fine. Then projecting of columns. Which column are we projecting? Source of joining. This is what you might feel at this moment, right? And then order by. Order by is based on enrollment date. And you might feel, oh, enrollment date is not there. Because right now it is something like this. Like this. Now, if we have to do a order by on this, then how do we do it? Because that column we have discarded only. This is what you might feel. That is why system is intelligent here, and what it do, even though we have not said that we want enrollment date in select, but system knows that later we are doing order by, and that is why I should still have this enrollment date so that order by can be done. We should not discard this field. That is why the system will still project enrollment date here, even though you have not explicitly requested, but this has a dependency later on. That is why enrollment date is not discarded and still keeps as part of projection, because system is intelligent, right? So select source of joining, comma, enrollment date from students, even though we have not requested. Now later, order by will work based on enrollment date, right? So it will order it. After that, what it will do is, since we have not asked for enrollment date, it will discard it later. It won't show this. It will sort it based on enrollment date, but while showing us the output, it won't show because we have not requested. Why system still has to keep it in the step 2 so that order by can be performed later. I hope this is clear. Now, I will run this query and show that this will work. You can see this. Select source of joining from students, order by enrollment date. Even though enrollment date is not here, we are still able to do order by. I hope this is clear. Okay, let's continue. Now, what happens if I add distinct here? What will happen if I add distinct here? Let's see. Select distinct source of joining from students, order by enrollment date. Okay, so what will happen in this case? First of all, I will try to run this and show you. This won't work. Now the whole point comes that why is this not working? Let's see. Now what will be the source of execution? Let me copy the previous one and I will modify that accordingly. Okay. The very first thing will be from, the table will be loaded. Students table is loaded. Okay. Second thing that will happen is select. And then right now we are saying source of joining is the only thing that we want to select. But system knows that we want to order by enrollment date. So system will still keep enrollment date also as part of projection or the select. So projecting source of joining, which we have already mentioned, enrollment date is given by system. And this will be something like this. Now after select, distinct comes in the list. So the order of execution is from, select, distinct and order by. Now when we do a distinct, what will happen? It will be something like select distinct source of joining, comma, enrollment date from students. Now problem comes here. Earlier, what actually we want to do a distinct on is only on source of joining. But now what, just because system has to take one more column, enrollment date, in the end distinct will happen on both the columns, which is logically wrong. I mean, if I run this query, this will work, but logically it's not the output that we are looking at. I will show you that. What we wanted is, we wanted select distinct, let me copy this. Ideally we wanted this, but now due to how the situation was, the query that is fired is this. Let me show you the output of this first. Okay, how many rows we are getting? 5 rows. Now what if I run this second one? You can see we are getting 6 rows. That means the results are not the same. Results have changed because now distinct is happening on a combination of these two things rather than one. So logically what we were trying to achieve has gone wrong, right? So in the end, if we see a output and if we see a wrong output, is that right? No. Rather than that, system should throw an error saying this won't work. And that is what SQL is doing. So the semantics have gone so wrong that this won't work that way. And that is why SQL gives an error actually. So I hope you understood what is the, I mean, uh, source of error here. Why system gives an error? Because logically things have gone wrong. So with this probably you will understand that why this query does not work, right? Why this query does not work? Because in the end, if system would have given us some answer, it would be the wrong answer, not the correct one. And that's why rather than showing wrong answer, it says that no, this is not correct. You have to recreate the query. So with this probably we understood that, like, the internals of it, the order of execution from select, distinct and order by. And only thing or the whole point is in select. That means the columns that we are saying are always projected. Apart from that, if we are doing order by, which is not projected by us, system will project it, so that we cannot discard that column because it's used later for the ordering or sorting, right? So I hope this should be clear, and with this we can wind up the session. I hope you liked it. Thanks a lot. Hello friends, welcome again. This is the session 8 in the SQL playlist. In the previous session, we talked about like why distinct and order by do not work together, right? And we understood the internals of it, the flow of execution and things like that. In this session, we will talk about aggregate functions. We'll talk about aggregate functions. As the name suggests, aggregate means clubbing few things and getting the output. Like when we sum few numbers, that's like doing aggregation. Or when we do a average of things, that's doing aggregation. Or when we do a max, like among a group of numbers, it's like again aggregation, like that. That means we talk about group of things and then we get one final output, right? Group of 100 things and finally the answer would be just one, right? So the input can be n number of rows, the output has to be one row. Okay, so let's try to understand this. So for example, let's say, what if I have to count the number of rows in a table? I have a student's table, I want to count the number of rows. Is this an aggregation function or not? Input is all the lines, output is one line or one single thing. So we can say select count star from students. If we do this, it will tell us how many rows are there in this table. Let us see. 8 rows. This table has 8 rows as of now. Okay. Now let me try running something else. What if I want to find that from which all companies or how many companies students are joining in my course? I run a big data course at Trendy Tech. I want to see that from how many different companies people are joining my course, right? Might be if 10 people are joining from Amazon, I just want to count it as one because it's one unique company. If 5 people are joining from Walmart, again that will be one more count, like that. So how I have to write this? Select count student company from students. What will this give me? This will actually give me count of all the companies, but duplicates will also be there, right? Let me just run this. It says 7. Let me do a select star, not star, select student company to see what all is there. So we can see these are the companies 1, 2, 3, 4, 5, 6, 7. Null is of course not counted. So totally 7 companies, but some of these are repeating, like Wipro is repeating 2 times, Walmart is repeating. What if I just want to find the count of unique instances, right? So what I can do is I can say count distinct student company, distinct, and it gives me the answer as 5 because there are 5 unique companies. And let's say I want to show on my website that I have people who join from 5 different companies, and these are those companies, right? On my website, if I want to show. Now you can see the column name is coming like this. You can give a alias. You can say as a number of companies, num companies, any name, whatever you want to give. This is how this will work. Now, what if you want to see that from which all locations or how many different locations people are joining? Then in that case, we can slightly tweak this query only. Instead of company name, we can say location. Select count distinct location from students. That means students are joining from 4 different locations. I hope this is clear. Now, what if I just want to understand that from how many different sources people are joining my course? LinkedIn, YouTube, Quora, many are there, but I want to see that how many different sources of, knowing me are there so that people get to know about me. So, what I have to do is select count distinct source of joining. That means people get to know through 5 different sources. It can be Quora, YouTube, LinkedIn, Google, and number of things, right? Okay. Now, what if I want to find people or students who have enrolled for Feb batch? There can be 2 batches running in Feb, right? But I want to see all people who have registered for any of the Feb batch, the batch which is starting in Feb. So let me first see, select batch dates. How are the batch dates organized? Batch date from students, right? So when we see that, okay, almost everyone is from Feb batch. So let's say if there is something 03 also here, can be the case, right? People would have registered for Jan batch, Feb batch, March batch. As of now, data shows only for Feb, but still, let's say assuming that we have lot of data, people would have registered for different batches. What if we want to find only people who have registered for Feb batch? We can use a pattern here. What we can do is we can use this regular expression kind of thing, like percentage, the wildcard character, I would say, right? Percentage and underscore we have seen earlier, right? So let's see how to do that. We can do select count star That means I want to know total count of people from students where batch date like, because it's not exact match, like, and then I can say percentage. That means whatever initially is there, it's fine. After that there is a hyphen. Okay, then there is a 02, then there is a hyphen, and then again anything can be there. That means the actual date can be anything, the year can be anything, but the month should be 02. I hope this is clear. In our case, since everything is for 02, it will give you the answer. How many people have registered for batch starting on 19th, let's say, if we have to do that? How many people have registered for the batch starting on 19th? I can say 19 and then hyphen and percentage. Anything can be there, does not matter. Only 4 people have registered for batch starting on 19th. So count is an aggregate function because it's giving you an aggregated answer that how many records are there, how many, right? Okay, so with this we have understood count. Now let us understand group by. Very, very important, super important. Group by. So basically group by says that we want to group this data based on some logic. For example, I might say that I want to group the data based on companies in which students work. That means all the people in Walmart will be grouped together. All the people in Flipkart will be grouped together. All the people work in TCS will be grouped together. This is one way of grouping. Another way of grouping can be that, okay, lead source or the source through which they have joined. All the people who have joined through LinkedIn can be grouped together. All the people who have joined through Google can be grouped together and things like that. Another group can be based on location, that all the people who have joined from Hyderabad can be grouped together. All the people who have joined from Bangalore can be grouped together, like that. And then once we do this grouping, why do we do this grouping? To do some operations later. Like for example, I mean, let me show you that. Let's not jump into that right now. Let me show you through a demonstration only. So what if I want to find that through each or source of joining, that means how many people have joined through LinkedIn, how many people have joined through Google, how many people have joined through Quora, like that. I want to see that way. What should be my query? That means I want to group based on source of joining and then do a count. So what I want is to know that how many people have joined my course or got to know about me through LinkedIn, right? I won't answer something like LinkedIn 5 candidates and Google 2 candidates get to know about me through Google. Quora, 1 candidate got to know about me through Quora. Things like that. I want this kind of answer. That means on which column I have to do a group by? I have to do group by on source of joining. Source of joining. Let me show you what is the source of joining here. Select source of joining from students. These are the source of joining. We want to group all the data from LinkedIn together, all the data from Google together and things like that. Okay, so let's write a query. Select, okay, now I will say dash dash right now, from students, because I will be filling in these details later. Select something from students, okay, from students, group by source of joining. Okay, now what I want as answer is LinkedIn comma 5. So that means source of joining should come here. source of joining should be a projection column, comma, what do I want? A count. I can say count star. This will count only for individual groups. It's earlier what we saw is complete count, right? Total. Earlier the table itself was one group, one big group. But now we have multiple groups, one group for LinkedIn, Google, Quora, and like that. If I run this, let's see. It says, okay, one friend or one person who has joined me got to know about me through his friend. Two people who have joined my course got to know about me through Google and things like that. I hope this is clear. So one important thing that if you are having something as part of your grouping column, right? If you're grouping on something, that should always be there in your select, because otherwise it does not make sense. It's logically incorrect and even system won't accept. So if source of joining is here, it should be here also in select. If you do not do that, then system will give an error. Okay. Now let me have another scenario. What if I want to know how many people have joined from Hyderabad, how many people have joined from Bangalore? Like that, location wise, I want to know from each location how many students have joined. Then I can say select location, comma count star from students group by location. Very simple. Two people have joined me from Bangalore, two from Chennai, one from Hyderabad, three from Pune. Okay. Now, what if, let's say, I slightly tweak this query to something like, uh, let's say, select location, count star from students, group by source of joining. What if I run this? Just think of it. What if I run this? As expected, it will give you an error. Select list is not in group by clause and contains non-aggregated column. So this does not work. If you are having something here, it should be a part of your select column also. Just make a note of this. Because logically, it does not make sense to run such queries. So I will say this do not work or this will not work. Okay. Now, what if I want to find that, okay, from Bangalore, people who got to know me from LinkedIn, Bangalore, LinkedIn, these many people have joined, right? Let's say four people who have joined my course from Bangalore got to know about me through LinkedIn. Three people who have joined from Bangalore got to know about me through Google. That means I want to do a grouping based on two columns, location and source of joining. Location and source of joining. First, I do a select star on these two. Select location, comma, source of joining from students. Just to show you what data we have, like this. Now, what I want to say that, okay, from Bangalore location and people who got to know about me through LinkedIn, these many candidates. From Bangalore location, people who got to know about me through Google, these many candidates, like that. So it's a grouping on combination of location and source of joining. Okay, so how to run this, write this query? Select location, comma, source of joining, and same thing would be in group by from, I will have to fill something here, the aggregate one, because grouping alone does not make sense. This is a grouping column, but after that we have to give some aggregate, that on what basis, what we have to find, count, sum, max, like that. From students, group by this. And what we have to do, we have to find a count star. Count star. Let's see. Okay, people from Bangalore who got to know through about me through Google, one candidate. All is one. Apart from that, Pune. There are two candidates from Pune who got to know about me through YouTube. Okay, that's interesting. Fine. Now, what if I want to, let's say, find for each course how many people are enrolled? How many people are enrolled for each course? It's very easy. Select course or selected course from students. Let's see the data first. Selected course. Okay. We have course ID 1, 2, and 3 like that. So we have to do a group by on selected course. How to do? Select selected course, comma, what aggregate function count star from students group by selected course. That means for course ID 1, 6 people have enrolled. For course ID 2, 1 person has enrolled. For course ID 3, 1 person has enrolled. The course ID 1 is for big data and 6 people have enrolled for that. Fine. Now let's think of another use case, something like what if I want to see that for each batch, multiple batches start. Some batch starts on 5th Feb, some batch starts on 19th Feb, like that. For each batch, like how many courses are sold for each category? Something like, let me just show. Batch date. So what I want to know is, as of now, the data that we see on screen is 5th Feb batch, someone enrolled for course ID 2. 5th Feb batch, someone enrolled for course ID 1. All what I want to find is that for 5th Feb batch, how many course ID 1s are sold? That means big data courses are sold. How many DevOps courses are sold? Like that. Then that means we have to again do aggregation on two columns, batch date and selected course. And then third column would be the aggregate function, that is count star from students group by, pretty straightforward, group by batch date comma selected course. So we can see this, that okay, batch date this one and course big data, total 3 copies are sold. That means 3 people have enrolled. Batch date 19th Feb, and this is, let's say, a DevOps course, 1 copy is sold, like that. So with this, probably you understood how group by works. Basically, it's creating a group, and what's the whole intention to create this group? To do a aggregation function, like sum, count, max, min, things like that. Max, min, we will be seeing now. So we have understood count star. Now we have to talk about min and max. Okay. Now, what if I want to find someone with minimum experience? That means I want to know what is the minimum experience among my students who have joined. What I can do is select min years of experience, because that's the column name, years of experience from students. This will, like, if we are not doing a group by, that means the entire thing is one big group, single group, right? And among that we want to find the minimum experience. It will also give us one row. The minimum experience among the candidates is 3. What if I have to find the max experience? I can say max. Maximum is 20. Quite huge, right? Okay. Now, what if I want to get someone, or let's say if I say min years of experience, comma, student name, what will happen? You might think, okay, this will give us first of all 3 and the student who has minimum experience, the name of that. No, it is not the way it works. Let me show you, right? Why you are getting error? Because this query is not correct. Why? Because you can see that this is independent, min years of experience 3 years. How do we know that we are asking for that person? Both the things are unrelated. System does not know that, and if system gives some name, it won't be logically correct. So system does not know that we are asking for the name where we are looking for minimum experience of that person. If rather you have to do this, that you want to get the name of the person with minimum experience, what you can do is select, sorry, his name is not there, F name is there, right? You can see this. So it's giving error. Now, if you actually have to do this, so this won't work, I am saying. This won't work. If you have to achieve the same result, get the person with minimum experience, you say select student F name from students, order by years of experience, and then when you do order by, everything will be sorted based on years of experience. You get only the first row, so you can say limit 1. So this will give you the result that you were looking at earlier. Virat. So Virat is the one who is having 3 years of experience. I hope this is clear. Okay. Now, let's say I want to know that, okay, if people are joining through LinkedIn, what's the maximum experience among that? If people are joining through Google, what's the maximum experience of those candidates? So I want to group by based on source of joining, and then I want to get the max experience. So how I have to write the query? So I'm saying for each source of joining, I want to get maximum experience. Okay. So how I have to run this? Select. So let me first show you these columns. Select uh, source of joining, comma, years of experience from students. You can see that from LinkedIn, someone joined with 6 years of experience. From LinkedIn, someone joined with 3 years of experience. So I want LinkedIn 6. That means from LinkedIn, the maximum experience was 6 years. From Google, someone joined with 12 years. From Google, someone joined with 14. I want Google 14, like that. So I want to group by based on source of joining, and then I want to get a max of years of experience. So let's see. Select source of joining. Okay. And then I will just say dash. I will be filling it from students, group by source of joining. Now what I have to fill here? Do I have to fill count star, max, min, sum? What I have to fill? I have to say max, because that's the aggregate function we want to use, max. And what column? On which column we want to do this max? Years of experience. Now let me try running this. Okay, the persons who joined, or the candidates who have joined my course through their friends, among them the highest experience is 15 years. Through LinkedIn, if someone has joined, the maximum experience is 6 years, and so on. With YouTube, someone joined with maximum experience of 20 years even. So I think these are good insights. So I hope this is clear. So this is how max and min works. Quite easy. I mean, we do not have to really worry about. Now, similarly, another aggregate function. So we have seen count, we have seen min, we have seen max. Now let's see sum. Sum is also very similar. In our case, I don't think we have any requirement of doing the sum based on the data set that we have actually, right? But what if I want to, it does not make logical sense, but what if I want to find the sum of total experience of candidates who joined me through LinkedIn, of candidates who joined me through Google, and so on. That means I want to group by source of joining and do a sum. Logically, it's not making sense, but to demonstrate, I can show you. Select source of joining, comma, some years of experience from students, group by source of joining. Okay. All the people who have joined me through YouTube, their combined experience is 38 years, right? All the people who have joined me through Google, their combined experience is 26 years, like that. So, fine, you can have a better use case for this, but with the data that we have in hand, we do not have any use case. So, that's fine for now, but you understood. Now, let's talk about average. Now, in the use case that we have seen earlier, this average will make total sense. Average is like, okay, from LinkedIn, people, lot of people do join my training, but what's the average experience from that? Let's say someone has 5 years and another person has 10 years, total 15. That means when you divide 15 by 2, it will be 7.5 experience, right? Like that. So, how to do same thing? Instead of sum, you say average. AVG, average. And this will be making much more sense. That means if people are joining my course through various places, I will get to know from which place I am getting the highest experience, like that. Okay. From LinkedIn, people who are joining roughly on an average has 4.5 years of experience. Same thing I can do for locations also. Like from Bangalore, whoever enrolled for my course on an average has this much experience, like that. So instead of source of joining, just a second. Instead of source of joining, I would say location, and then this also will become location. Okay. The people who join from Bangalore have on an average 9 years of experience, industry experience. People who join from Pune have a lot of experience, like 17.6, quite huge, like that. So this is how this average works. Now, same thing we can even do for company. That means people to join me from Amazon, Walmart, TCS, Wipro. I want to see that, okay, if someone is joining me from Amazon, on an average, how much experience they have. Then I can just change it with company here or student company. Yeah, student company. And same thing I can put here. Student company. So this is what the results are. So from TCS, people have 18 years of experience almost on an average who are joining my course. Okay, so with this, we have talked about quite a lot of things. We talked about group by. Group by is like grouping things together as per a logic, right? Based on a category. Why we are grouping it? To do something later. What is that something? That is doing aggregate functions or applying aggregate functions like count, average, sum, min, max, and all. Because if we do not do group by, it acts that the table is one big group and on that it happens. So quite easy. It's not, I mean, that difficult. Some people might feel, oh, group by is very difficult. No, nothing like that, right? If you understand it neatly, if you practice it, I don't think it's hard, but it is very important. So with this, let's wind up the session and I hope you liked it. Thanks a lot. Hello friends, welcome again. This is the ninth session in the SQL playlist and I believe this session would be a little small. So let's start. So basically in the previous sessions we have created two tables. One is a students table and other one is a courses table. Now in the courses table we would try to add a few more things based on our requirement. So let us see what exactly do we have in the courses table till now. Select star from courses. This is the data we see in the courses table. Okay. Let me even describe the table structure. DESC courses. And this is a table structure. We have four columns: integer, varchar, integer, and integer. Now my requirement is the course duration, which is right now 6 months, 3 months, 6 months. I want to have it in decimals. That means I can even have a course which is 3.5 months. Right now we have integer data type which will not support decimal types, right? So if we try inserting something, it won't accept that way. For example, let me show you. I will say insert into courses values and let's say I say course ID 4 and course name, let's say uh, data structures, might be spelling is wrong but that's fine, and then course duration, let's say I will say 3.5 months and course fee 20,000. Will this accept? It has accepted, but let's see what issue we will face when we say select star from values. Sorry, select star from courses. Then you see this. It has truncated the decimal point here. It has truncated the decimal point. Not truncated basically, it has rounded off, if you can see. Course duration months. So this is not the ideal way of doing it, right? So ideally I'm showing you a wrong scenario. I do not know what exactly will happen if we enter a decimal point in integer. I was thinking it will truncate, but it has rounded off, if you can see here, to the nearest integer. So that we should not even try actually. So we should go with the correct way, and here we should be having a new data type which is decimal, which will hold decimal places. So let's see. So this is the table structure for courses. If you can see, this was it, right? Create table courses and course ID int, course name varchar, course duration int, and course fee int. This was the way we created the table earlier. Now, and these were the insert statements we had. So let me take it to my actual notepad and let's try making changes. So I could update this table also, right? Or alter this table also, but I should not be, or I am not doing. I will be creating a new table now. So I will say courses new. That will be my table that I am going to create. And course duration months, instead of int, I will make it decimal. Decimal. And I have to give two parameters here. For example, if I am giving 3 comma 3 comma let's say 1, what does it mean? That means whatever number I write here can totally have 3 digits, and one of the digit can be after decimal. For example, I write here 12.5. Will this be supported in this? So totally three digits, 1, 2 and 3. Three digits, and one of them is after decimal. So this will be fine. Decimal is this. How about 3.5? Yes, this is also fine because totally a maximum of three digits can be there. Right now it's two only. That is fine. And one of them is after the decimal. But the moment you say 3.52, this won't be supported. Totally three digits, that is fine. But one of them after the decimal, or at max one after the decimal. Here we have two after the decimals. So this won't be supported. So I hope you understood what I am trying to convey. Okay, so let me remove this and try running this. We have created this table. We can say DESC courses new. We can see this is decimal type which will hold decimals. Let's try to insert some records. So instead of 6, I will make it 6.5 months. Instead of 3 months, I'll make it 3.5. Like that I'll do. Okay. So now let me just take all of these and try running. Okay. Let me say select star from courses new. We can see whatever decimals we have given it's there, and for whatever it was not given, it is giving 0.0. So with this, we can handle the requirement of decimal places rather than just supporting integers. And if in integers you try holding decimals, then it will be truncated or it will be rounded off, whatever is the behavior, you can see that, but you would not do that. So this is okay. Now let's say I just updated, or I want to change the fee of a course. The course fee is increased, let's say. Then we can run an update command. So let's say I want to update the course fee. So what I can do, uh, update courses new, set course fee equal to 40,000. Right now, what's the fee it shows? So let's say this one I want to make 40,000 web development. Course fee equal to 40,000 where course ID equal to course ID equal to 2. Okay, now I will say select star from courses new. We have made it 40,000 for web development. But I do not see a way that I can track what time the record was inserted, what time the record was changed. What if I want to do that? Right now, I want to maintain an audit history kind of, that whenever we make changes or whenever we insert about a new course, we should know when exactly that has been done in this table, right? So how to do that? In this case, you should be using a timestamp data type. Let me show you what you need to do. I'll copy this. Okay. Before all of this, let me drop this table. Drop table courses new. Okay, I have dropped it. Now, whatever you see on screen, we have taken care of the decimal places for the course duration. That is fine. But I want to have one more column in the table which tells me when this record is inserted or when this record is updated, like a audit kind of thing, audit trail. So what I can do in this case, I can add one more column, changed at. Changed at is a column name I'm giving. I can give any name, whatever it is. The data type would be timestamp, and we are saying we do not expect that we will be giving the timestamp. You default it to now. That means if I am inserting a record or updating a record, it should be present one. So I will say default I'm giving a default value for it now. Okay, the current time and date, and I will give a comma here. So let me try running this. It ran successfully. Okay, now let me try inserting a few records. I will copy this here, but since change that this I am not giving or entering manually, that's why I need to give the list of columns. Otherwise, if I run here this thing, it will say number of columns do not match or something, because we are giving the details for these four, but in that case we should be highlighting list of columns here. Let me show you. If I run this will say column count doesn't match. So what we need to do here, we need to give a list of columns. How? We can say course ID, course name, course duration, months, and course fee. Okay, and same thing I would do in the other inserts. And I would take it and run this. Now we have inserted. So what timestamp would be going, or what time it will show? Let's see. So I will clear the screen and say select star. I'm just pressing the up arrow just to let you know. Up arrow gives me the previous commands which we have run. So when I'm saying select star from courses new, you can check we have course ID, course name, course duration, course fee, and changed at. Now this will be the UTC time, 5:19 a.m. You can see, and here it's almost the same. That means it's considering the UTC time. And this has inserted one record for the same. I hope this is clear. So we have big data, web development, data science. Now let me insert one more record. Let's say I will insert one more for DevOps. For DevOps, and then I will say let's say 10.5 and 10,000 rupees. Okay, and I will say select star. So you can see the time will be the current time now again. It's different, right? Why I inserted the fourth record? Because for the previous three we inserted almost at the same time. That's why the timestamp looks to be the same. But in this case, you will see a difference. Now, what if I tend to change the fee of big data course? I want to make it, let's say, or let's say web development course. I want to make it 30,000. I will first clear the screen. I think it quitted my SQL-CTL CLI. Yes, so just give me a second. Okay, use trendy tech because I just entered into this, right? This is how it is. Now I want to update the course fee for web development. Let me try doing that and see whether this date will be updated date, or whether this date will be updated or not. Because I am doing the update now. So what I will do, update courses new, set course fee equal to what was it? Set course fee equal to 40,000, where course ID equal to 2. I have done that. It changed it. You can see it changed one. Now let me say select star. It is showing 40,000, but you can see the timestamp has not changed. I was expecting that I should be getting the updated timestamp also. Even if I insert, it should take the current timestamp. Whenever I update, that time also, the that time timestamp should be entered or it should be updated. But right now it's not happening. So what to do? What changes we can do? We actually have to make a small change in the table definition. We have to make a small change in the table definition. We have said change at timestamp and default is now. That means while inserting it will take care, but we have also, or we should be also telling about update, right? So what we have to say on update, what we want to do, we want to again say now. That means this is for inserting and this is for updating. Now means current timestamp. So this now you can even replace with current timestamp. Just to let you know, it works the same way. Current timestamp, current timestamp. There is no difference between these two. Either you can use now or current timestamp. This is how it is. What I would do now again is let me drop this table. Drop table courses new. Okay. Now let me just copy this. Done. And let me insert, let's say, these 4 records. I have done that. Let me do a select star. Select star from courses new. Okay. All this is fine. Let me now try updating a record, which we have done last time. Where is my update statement? Have I written here? No, probably I just did it there. So let me again try doing that. I'm pressing the up arrow so that I get to know. Just a second. Okay, looks like a little messed up. Let me try doing it now. Okay, leave it. I will type it myself. Some glitch is there with the terminal itself. So I will say update courses new, set course fee equal to 40,000, where course ID equal to 2. Done. Now I will say select star from courses new. Now you can see when I have updated, this also will be updated in this case. This is what I wanted to show, that I have made that changes, that when I am inserting, it will take the current timestamp. When I'm updating, then also it will update the timestamp based on the update. So this is what I wanted to show in this. So we have learned 2 things. One is a decimal data type. So what we have learned, a decimal data type. For example, if we say decimal 5 comma 3, what does this mean? Totally 5 digits can be there and 3 of them can be after the decimal. And then we have learnt about timestamp. In timestamp, current timestamp is the something which is very majorly used just to make sure we are entering the current time, date and time, right? And moreover, we have seen that whenever we do a insert or update, how exactly the timestamp gets modified or inserted. So quite important from a industry use case perspective, very, very important. So with this, we can end up this session and I hope you liked it. In the next session, we will come up with more interesting things. Thank you. Hello friends, welcome again. In the previous session, we talked about the timestamp data type and decimal data type. Now in this session, we'll talk about the logical operators which are very important again from an industry perspective, and we will see some scenarios which we will handle. So let's say we have a students table. You would know that which we have created. Let me show you quickly. Just give me a second. So we have a students table. Let me say DESC students. So you can see what all column names and data types are there. So one of them is location as well. That means a person is from Bangalore, Hyderabad, or which place. So what I want to do, I want to find people who are from Bangalore. You know the query is very simple. Select star from students where location equal to Bangalore. This is as simple as that. Now, why we are getting this way? Because there are a lot of columns and things look little messed up, but that's fine. These are the column names and these are the results. And I'm getting one record, one or two records, Rohit Sharma, Shikhar Dhawan, who are from Bangalore, let's say. Now, so you can see this Rohit Sharma and Shikhar Dhawan. So results are little distorted because number of columns are more, which cannot fit on one screen. That's how it is. Now, what if I want to people? I want to know people who are not from Bangalore, all other places, but not from Bangalore. So, I mean, if we want to check it for Bangalore, select star from students, where location equal to Bangalore, which we have seen just now. Now, what if we want people who are not from Bangalore? What we need to do is we need to say not equal to. How to do it? We will say like this: exclamation mark and equal to. This is equivalent to not equal to. So let me try running it now, and this will give me all other records other than Bangalore. Sorry. Uh, sorry, it is students. Students and then semicolon. We can see all other people who are not from Bangalore. Chennai, Pune, Chennai, Hyderabad, all of that. So this gives us that. I think most of you would be aware, but still I have highlighted this. So to get people who are not from Bangalore. Fine. Now, what if I want to uh, know courses which have data in them? I will explain you. For example, I will do select star from courses. Now there are 3 or 4 courses totally, and 3 of them have data. The word data, and data. What if I want all the courses which have the keyword data inside it? How do I search? I can say, so get all courses which has the word data. We can write a query, select star from courses, select star from courses where course name, because this is course name, right? Course name like percentage data percentage. You remember we have talked about this in our previous sessions. Since we are not doing an exact match, we have to use the keyword like. And percentage means whatever is there before data, right? Whatever is there before data and whatever is there after data, we do not worry, even if something is there or not there. But this keyword data should be there somewhere. And if I run it, we will get all the 3 courses which have this keyword. We can see this. Now, what if we want to get all the courses which do not have the keyword data? So, get all courses which do not have the word data. Then what to do? I'll just copy this, and what I will say, select star from courses where course name not like, right? And this will give me the one other course, web development. I hope this is quite easy to understand. Okay, let's proceed. Now, what if I want to get a list of students who have less than 8 years of experience and source of joining is through LinkedIn and they are from Bangalore? All of this I want. So, all students from Bangalore, uh, source of from Bangalore who joined through LinkedIn and have less than 8 years of experience. If I want all of these things, then how should I go about it? Let me write a query. Select star from students. That means I'm selecting all columns. That is fine. Where now the main thing will come, that how do I write this where clause? Number one, years of experience less than 8. That is one thing, right? Now it should satisfy some other conditions also. Whenever we have a clause like it should satisfy multiple conditions, then we have to give this word and. And it means the other condition should also be satisfied, then only the record will be displayed. Source of joining equal to LinkedIn, okay, and location equal to Bangalore. This is what we have to write. Now, in this case, the first condition is years of experience less than 8. Second condition is source of joining equal to LinkedIn. And third condition is location equal to Bangalore. And all these three conditions are combined using AND. That means if all these three are true, then only the record will be shown. Otherwise, it will be discarded. Okay, let me just run it and show it to you. And we see Rohit Sharma is the only one who qualifies for it because he satisfies all the three conditions. He's from Bangalore. He got to know about the course through LinkedIn, and moreover, he has less than 8 years of experience, which is 6 years only. Okay. So this is the way we write this query. Now, what if I want to know students who are having less than 8 years of experience or more than 12? I do not want people basically between 8 and 12 years of experience. So my requirement is I want all people who do not fall between 8 to 12 years of experience. That means what I want is less than 8, also more than 12. All those list I want. But if someone has experience between this 9 years, no, I do not want. 10 years, I do not want. 11 years, I do not want. 12 years, I do not want. 8 years also, I do not want. Less than 8 is fine to me. More than 12 is okay for me. All of that I want. Then how do I write this query? Let's see. Can we say select star from students where I'm not saying I'm writing a correct query. I'm writing a query and I'll ask you whether it's correct or not. Select star from students where years of experience, because in students we have a years of experience column, less than 8 and years of experience greater than 12. Will this query work or not? What are we trying to say? Any record which satisfies both these conditions, years of experience less than 8 and years of experience greater than 12. Of course, there cannot be any record which satisfies this condition, because if years of experience less than 8, then how can the years of experience be greater than 12 for the same person? So in this case, nothing will be displayed for sure, 100%, because this will never be true. We are saying, okay, we are tossing a coin and we want a toss or coin toss in which head has also come and tail has also come in one single coin toss. How can that happen? Right? So this is totally impossible. That is where we should be using or here. Or is like any of this condition is satisfied, it will give the results. It will give the people who are having less than 8 years of experience. Also, it will give the people who are having greater than 12 years of experience. So now let me try running this, and you can see lot of results are displayed. So basically it says any of this condition, if it is satisfied, we will be considering the record. So you can see 6, 3, 15, 18, 20, 14. These are the experiences, and you cannot see anyone having experience between 8 to 12 years. I hope this is clear. Now, is there a easier way or other way of doing the same? Yes, we can use between operator. We could have said select star from students where years of experience between 8 and 12, or where years of experience between 8 and 12. If we do that, we get all the records which we do not want actually, right? These are the people whom we have not wished to get. Shikhar Dhawan and Rahul Dravid. This person has 12 years of experience, this person has 8 years of experience. I want all the records beyond this or apart from this. So what we should do? We should say not between, as simple as it. Select stars from students where years of experience not between 8 and 12. This will give me the results which we have got here. Same results. And we can see the results are exactly the same which we have got earlier. So this is one easier way of doing the same thing. Between and not between. Okay. So let's see a few more scenarios. Consider we want to get a list of students who are either working for Flipkart, Walmart, or Microsoft. I want to get list of students who are working for any of these companies. How to do? So get list of students who are working for Flipkart, Walmart, or Microsoft. One of these, any of this basically, right? So how to write? Select star from students. Select star from students where student company, that was the column name actually, student company. Now select star from students where student company equal to Flipkart, or because in this case, of course, we are saying any of this condition is satisfied, whether they are working for Flipkart, Walmart, or Microsoft, we should get the results. Student company equal to Walmart, or student company equal to Microsoft. This is what we can write. Let's see whether this gives us the results or not. Yes, it is giving Walmart, Flipkart, Walmart, Microsoft. Fine. And we were aware of this, nothing new. But is there an easier way of doing it? Yes, we could have done it in a simpler way. We could have used the in operator. How to do that? We could have said select star from students where student company in, and then we could give this list: Flipkart, Walmart, and Microsoft. This is a cleaner way of achieving the same thing which we have done earlier. That means if student company is in any of these, it will give you the result. And the answer would be exactly the same. I hope this is clear. What if I want to get a list of students who are not working for any of these three companies but other companies only? Then I can say not in, as simple as that. I want people who are not working for any of these companies, then I can say not in. And then let's try executing. So it's say giving people who are working for TCS, Wipro. So I hope we are good with this. Let's talk about one more scenario now. Now, some people are working for product based companies, some people are working for service based company, or you can even see that. Let's see the courses table, select star from courses. Okay, now based on the course duration, let's say if the course duration is more than 4 months, then I want to say it as a master's program. Just an example. Ideally, more than 4 months does not mean it's a master's program. And consider lesser than that is a diploma. So if a course is more than 4 months, we categorize it as master's program, else it is a diploma. Let's say this is our business rule. What if I want to categorize all of this here, right, based on course duration? Then in such cases, we can use case statements. I will show you what I am trying to say. So we can say select course ID, comma, course name, comma, and course duration I do not want, because I want to, instead of this, I want another column which should say masters or diploma. So I will say course fee, comma, and the fourth column will be the one which I want to create. I have removed this and I want to create one more column. So comma, and the fourth column which I create will be based on certain condition. So these three columns were straightforward. Fourth column will be based on some condition. So we go here and say case, comma, case. So I'm just showcasing you indentation. Later I will remove probably. So case, and each case statement has a end, right? So towards the end we will have this end. Ideally better to have it in uppercase. Okay. We will be writing some logic here. So case end. Now I'm saying when course duration months, this is the column name, if you can see, course duration months is greater than 4, that means it's more than 4 months, then what do we want to say? Then we want to call it as masters. Okay, else what do we want to say? Else diploma. Okay, and then towards the end we are ending. So basically what we are saying, three columns are directly from table. Fourth column is what we want to derive based on certain logic. That is where we started a case statement and ended it. And the condition is when course duration is greater than 4 months, then masters, else diploma. And now this column we have to give some name, right? We can say as and some course name. We can say not course name, column name, which is course type. So we are saying whatever new derived column is there, the name of that column would be course type. And towards the end, from which table? Courses. This is what we want to run. Okay. Now let's try running this. So just a second. So I have formatted it this way to showcase you, but let's see how to make it now. Just I am seeing that with this indentation, will it work in this IDE or not? You can see it here now. So big data program is a master's program, web development is diploma, data science is master's, data structures is diploma. And this is based on the logic that we have put in, that if a course duration is, so what I mean, if you see select star from courses, you can see this one is definitely greater than 4 months, so masters. This one is less than 4 months, so diploma. This one is greater than 4 months, so masters. And this one is not greater than 4 months, right? It is equivalent to 4 months, so it's a diploma. So this is how we have put in a logic. Now, what if again on same lines, let's say people who are working for Flipkart, Walmart, or Microsoft, I want to say they are working in product based, and all others are service based. So our requirement is people working for Walmart, Flipkart, and Microsoft. We want to say product based and all others service based. This is what we want. Then how do we go about this? So what we can do is select, I'm talking about students table. So select student ID. We'll select some columns. And I think the name was student F name for first name, right? And then student L name for last name. Okay, and student company. Let's say these columns I want from the table directly. The other column I want to derive. I am saying case, and towards the end it will be end. And I have to write my business logic here. I have to say when. What's the condition now? Student company in, you remember this in operator, right? In Flipkart, Walmart, and Microsoft. Then what we want to say? Then we want to say it as product based. Else what we want to say? Service based. And this column we would give some name. We will say as company type. Company type. Let's say we are saying this. And what we have to say now? From students. From which table? Students table, right? This is what we have to run. I will just correct this so that it will execute without issues. So we can see this. Walmart means product based, Flipkart product based. There was no company, so of course service based. Uh, why? Because our condition is that way, that if it is anything other than this, then service based. So null will be other than this, right? Walmart again product based, Microsoft product based, TCS service based, Wipro service based, and so on. So this is how we can use the case statements to have a logic inside it. And this can be multiple levels. For example, when then again you can have some one more condition, when then again you can have one more. So there can be multiple conditions. Right now I have just shown one, you can try multiple, right? So you can just see. For example, you could have even said when student company uh, is, let's say, null, then not defined or invalid company. You could give multiple logics to this so that it gives you the correct answer. So this is just I wanted to showcase. So in this session we have covered a lot of things. What have we covered? We have covered not equal to, we have covered not like, right? Also we have covered in, not in, between. And apart from that, we have talked about case statements. So these are the things which are very, very commonly used and form a part of basics in SQL. So with this, let's end up, and I hope you like the session. Thanks a lot. Hello friends, welcome again. So this is the session 11 in the complete SQL playlist. And in this session, we will talk about joins, which is a super important concept in SQL. Joins. So in this session, we will understand what is a join. We'll see it practically, the various kinds of joins which we can do. I won't give any definition as of now. We will see practically that what we wanted to do, and then we will take it more theoretically later. Okay. So you know that we have two tables. So I will say show tables. I have courses table and students table. I'll make a note here. So I have courses and students. These are the two tables I have. Okay. Now what I wanted to do, I wanted to find that, okay, I know there is a student named Rahul. I want to understand in which course he has enrolled. I want to understand. So my problem statement is I want to know in which course Rahul has enrolled. If I want to do this, how do I get this? In my students table, I have my student F name, first name, that is, I can get Rahul from there. And here I have selected course. Selected course. I will just show you the table. So I will say select student F name, comma, selected course from students. So we can see that, okay, Rahul has opted in for a course with course ID 1. Selected course ID is 1. That's what we understand. But we do not get what is the course name from here. course name is something which is kept in another table, which is a courses table. So let me go back to my notepad. So we have, so example of this is we get Rahul, comma 1, which is the course ID, but not the name. Now we have another table called as courses table. And in this courses table, we have something like, so I can do a select star only, select star from courses. And we can see course ID 1, big data, course ID 2, web development, and so on. Now, course ID 1 is big data course we get to know from this table. In the previous table, we were not having this mapping information that this course ID 1 mapped to which course name, right? So we have course ID, comma, course name. For example, 1, comma, that is big data. So basically, this is how the information is laid out in both these tables. Now you can clearly see that there is no way that from one single table we can get these details. We have to somehow get information from both these tables in order to tell that Rahul has enrolled for which course name, not the ID, which course name, right? I want to tell Rahul has enrolled for big data course. No single table is self-sufficient to tell that to me. So what we need to do, we could have done it in a very tedious approach. What can be that tedious approach? I can say select selected course, this one, selected course from students where student F name equal to Rahul. That means I can very well do this. In students table, I can say, okay, where name is Rahul, can you tell which course ID he is taking? Course ID is named as selected course, right? So select selected course from students where student F name equal to Rahul. So basically we are saying, can you tell me the course ID in which Rahul has enrolled? And we get the answer as 1. Now what we will do is, we will write a query on top of it, select. So that means 1 is something which we have now. Consider this will be replaced by 1, right? Now we will say select course name from courses, because here the name is course name, right? Select course name from courses where course ID equal to whatever this is. And this would nail down to 1 actually, right? So I can put this in parenthesis this way. And this will give me the answer as big data, right? So this is kind of a nested query that we have written. You can check this out. So basically this eventually will give answer as 1. First this will be executed and then it executes select course name from courses where course ID equal to 1. And this will give us the answer as big data. Let me try running this and show you the results. You can see this. Now what if we want the same thing for multiple people? Then we cannot keep on writing this query again and again, and it's a tedious approach, not a right way. Like we could do it, but what we could have easily done here is we could have joined these two tables so that we can see the complete view together for all the students, that this student is enrolled for big data course, this student is enrolled for web development course, and so on, right? So let us see how we can join two tables based on one common column. There should be a way based on which we have to join, and we join two tables based on one common column. Now if you see this case, what is a common column? Selected course and course ID. Need not be that the column names have to be same. It's not the case. The names can be different, but you logically understand that I can join these two tables on these two columns. So in students table, we have selected course, and in courses table, we have course ID. So the join will be happening on course ID and selected course column. So let us see how do we do it. Okay. So let me try writing a join query. What I can say, select, I can say student F name, comma, student last name, L name, comma, let's say I will say course name. All these three columns I am getting from all these. So the first two columns I am getting from the first table, and this course name I am getting from second table. Now I will say from students. So I am saying these two table columns are coming from table 1. This column is coming from table 2. When is this possible? Whenever we do a join. So definitely I have to give two tables name here, two table names here. From student, join, what is the other table name? Courses. That means we are saying we want to join two tables. One table is student, another table is courses. Actually students table. Now on basis of what column you want to join these two? On students dot selected course. You can see this. In students, we have selected course. So we are saying students dot selected course equal to courses dot course ID. Courses dot course ID. I hope this is clear. And just, in our case, these two columns are very well defined in table 1, and this column is defined in table 2. Just to make it even better in terms of readability, visibility, and even to avoid any confusions, we can just say students dot, because we know this particular column is coming from students table. Even this column is coming from students table. This column is coming from courses table, like this. So select students.student first name, students.student last name, courses.course name. From students, join courses. These two table we are joining. On, then we have to give the condition students.selected course. That means selected course column is there in students table and course ID column is there in courses table. Based on these two, we are joining. Now let me just pick this and try running. And we can see this, that we are able to get the result. With this we know, oh, Rohit has enrolled for web development course, Virat has enrolled for big data course, Shikhar has enrolled for data science, and so on. I hope this should give you a clear idea. Now whatever join we have performed, we have not mentioned what kind of join we are performing. By default it is a inner join. By default it is a inner join. What is inner join? Basically, in such a join, only the matching records fetches results. The non-matching records will not be considered or will be ignored. What I mean to say is, I will tell you what I mean to say. I will say select student F name, comma selected course from students. Select uh, select course ID from courses. Now we can see in courses table we have 4 courses, 1, 2, 3, 4, and here we have 1, 2 and 3. That means we know that only a match is possible for the 3, but fourth one there is no match, because no one has taken up the course 4 or no one has enrolled for course ID 4. What was course ID 4, by the way? Let me say select star from courses, data structures. So you will not see data structures anywhere here. You can see it's totally eliminated. So you will not see data structures anywhere. Let me just show you. If you just a second, where is that? Let me pick this query and run this. And you will not see data structures anywhere because only the matching records are taken. The non-matching records are eliminated. So this is what a inner join is. You can make a note of it. Only the matching records are considered. Non-matching records are discarded or does not come up in the results. I hope this is clear. Now, let us try few more things. Let's talk about, uh, let's say, left outer join. I will explain you what is a left outer join. We have already understood our inner join. In inner join, only the matching records or the records which are available in both the things will be considered. Rest will be discarded. In a left outer join, all the matching records are considered. That means when in left table and right table there is a match, all those are considered. Plus, apart from this, we have all the records or all the non-matching records in the left table which does not have the match in the right. That means a record which is there in the left table but not there in right. Right? Because these two are not matching then. Matching records are coming, but apart from that, whatever is there in left table which is not there in right will also be coming to us. So let me show it in a different way now. If I have to do this, we should have some extra records in the left table. That means someone who has taken a course where course ID is 5, for example. Right? That's what it means. Right now, if you see this, a person has opted for 1, 2, and 3 courses only. Course ID 1, 2, and 3. Now, all of this is there in the right table because we know in the right table, courses table, we have course ID 1, 2, 3, and 4. Now, we need to add one more record where we say probably course ID 5. That is one way. Or from courses table, let us try to remove something where course ID is 2. That means, let's say we are discarding a course where course ID is 2. We are removing that from our curriculum altogether or from our institute altogether. I do not want to conduct the course with course ID 2. How do I delete this record from courses? I have lot of records in courses, right? I have 4 records in courses. Course ID 2 is web development. My web development trainer has left, right? And I am discarding that course. I want to remove it from here. How to do? I will say delete from courses where course ID equal to 2. Now the moment I hit enter, it will give me an error. Why? Because we have a foreign key constraint which we have put, Because if we remove this particular record, then of course the record which is there in students table who has taken this course will get, I mean, obsolete kind of. So that is why we are getting an error as we have set foreign key constraint. I mean, if we would not have set foreign key constraint, we could have deleted it. So let me recreate both the tables, students and courses, without these constraints so that I can play around. How do I quickly do it? I have a students table. How do I make a copy of it without these constraints? Quickly, I can say create table students latest. I am creating a new table with the name students latest. I do not want to give any schema or anything like that. But what I can quickly say is as select star from students. What it will do is it will create a new table with the name students latest with almost the same structure as students, and it will copy the data from students to students latest. But that foreign key constraint and all will not be there. I hope this is clear. Same way we can do it for the courses table. I am creating a table courses latest. Now we have two tables, students latest and courses latest. And I should be able to delete something from courses table now. So what I will do is select star from courses latest. I will show you the data. COUR is latest. Okay. Now I want to discard this web development course, let's say. What should I do? I have a delete query here. And instead of courses, I will say courses latest. Done. Now, what if I try to do a inner join first of all? Let me try doing an inner join. How do I do an inner join? I have this query. I will take it and then I will just change the name here, students latest, right? Students latest, courses latest, from students latest, join courses latest on students latest dot selected course, courses latest dot course ID. And this is our inner join which we have done earlier, but now we are doing it on different tables. And we can see here web development has not come in because the right table does not have a matching record. As simple as that. Okay. So now you understood that in students table there are some students which says that selected course is 2, course ID 2, web development. But we have removed that web development course from the right table, which is the courses table. So let's perform a left outer join. How do we perform a left outer join? How do we perform a left outer join? We just have to give the keyword left before the join. Just like this. Now let me try running this. And you can see here. We have got all the matching records, right? These are matching big data ones because course ID 1 is there. Similarly, course ID 3 is there, that is matching. Plus course ID 2, which is there in the left table but not there in right. Some student has enrolled for course ID 2, right? It's there in left table but not there in right. So what happens? We are getting that record. We are getting this record padded with nulls on the right. Because of course right table does not have any data related to web development course, right? Course ID 2 basically. So that's why we are getting a null. So what we have to say is, when we talk about left outer join, all the matching records from left and right table are considered, plus all non-matching records in the left table which does not have match in the right, padded with nulls. These are shown with null padding, which we have seen just now. Ideally, Rohit Sharma was there in left table and he opted for course ID 2. Course ID 2 was not there in the right table, courses table. That's why from right table, when we are doing a join, we are getting null because there is no information regarding that. Now, if you have understood this, the right outer join should also be very, very similar. Right outer join. What does right outer join says? Almost exactly the same. I will copy this definition and change it slightly. All the matching records from left and right table plus all the non-matching records which are there in the right table which does not have the match in the left, added with nulls. That means if the record is in right table but not there in left table, it will be showcased to us, where on the left side nulls will be padded. Now how do we run this? I mean, this is exactly the same way we have learned the previous join, the left outer join. How do we run this? Instead of left, we say right. Now, what are the records which are there in right but not on left? I think the course 4, which is, I think, DevOps course or data structures course. None of our students has enrolled for data structure course. So there I should see that in student details it should show me null, but course name is data structures. Let us see. So we can see this. All these are matching records in both the tables. This one non-matching record, you can see this. Data structures is coming from the right table and null is coming from the left table because left table does not have a matching record. I hope this is clear. So this is how we can try understanding that how this works. Now talking about full outer join. Full outer join. I mean, very, very easy to understand. It's something like a combination of left outer and right outer. In this, all the matching records are shown. All the matching records plus non-matching records from left plus non-matching records from right. I mean, it's equivalent to a combination of left outer plus right outer, basically. Now, just to let you know, in MySQL, we do not have a keyword like full outer join. In lot of other databases, it would be there, but here we do not have it. How to simulate that? We can do a union on left outer join and right outer join. That means if we take this query, the left outer join query, and then we say, if we take this query and we say union, and then we take this query, the right outer join, then we should be able to get the results. That means we are saying, can you please give us the combination of both, right? Union is basically when like we, so whatever results we get from this, think it, let's say we get some 8 records, and from this let's say we get again some 10 records. It will remove the duplicates, but it will give us all the distinct records one time. So it will like combine these two together in a single result and give it to us. So we can see this here. So these are all the matching records which we would have got anyways as part of inner join, and as part of the left outer join we are getting this Rohit Sharma null, because Rohit Sharma has enrolled for course ID 2, right? But course ID 2 is not there in the right table, that's why we are getting this. Similarly, in the right table we have data structures, but no one has enrolled for it, that's why we are getting it as part of this. So all this is as part of inner join. This particular record is just because of left outer join, and this particular record is because of right outer join. And we have got all of this together. So this is the result of a full outer join. I hope this is clear. So what we have learnt in this session, we have learnt inner join, we have learnt left outer join, we have learnt right outer join, right outer, okay, and we have learnt full outer join. Remember, for full outer there is no keyword as such in MySQL. There many databases directly support full outer join and then we can get it, but here we used a trick of union so that we can combine the results of left outer and right outer and show it. So this is what we have learned. I hope this is fine. And there is something called as cross join, which is not much useful, but I will show you. Cross join is, let's say, in your left table you have 4 records, in your right table you have 7 records. Then it will try to combine each record on the left table with every record on the right. So that means the number of records will be 4 into 7 equal to 28, which might not make sense. But if we are using it with some conditional thing later, then we can use it. But cross join works. It's a very costly join because each record on the left table will be combined with all records on the right table. So for example, I will show you how to do that. What I can do is select, uh, select, let's say count star. I will show you how many records we will get from students, comma courses. 32. Now I will do a count star on students, that how many records were there in students. Select star from students. Oops. I will do a count star. Actually 8 records are there I think, but let's see. 8 records. So students has 8 records, courses has, it will have 4, definitely 4, and that's why when we are using this cross join we are getting 32 records. How to do a cross join? Simple. We can say select star from students, comma courses. Right, 32. Or we can even say select star from students join courses. 32. That means we are using the join clause, but we are not giving the where condition saying, okay, this column we want to match and all. Last time what we did, we said this table we want to join with this table on, and then we were giving a where clause that, okay, students dot selected course equal to courses dot course ID. We are not giving that clause now. We do not have any clause, so everything will match with everything, kind of. Not much useful, but still good to know. So what we have learned in this session, inner join, that means only the matching records are shown. Left outer join means matching records plus non-matching records from the left table. And how it will be showing? They will be padded with nulls on the right side. Right outer join is matching records plus non-matching records from the right table. Full outer join means a union of left outer and right outer. That means a combination of results which is of left outer join and right outer join. Cross join is each record in the left table will be mapped with every record on the right table. Quite important. Joins are super important, and I think this would have given you some idea on what I am trying to convey. So with this, let's stop the recording and I hope you like the session. Thanks a lot. Hello friends, welcome again. This is the session 12 in the SQL series, and in this session we will talk about what is the difference between where and having clause in SQL. A very important question even from an interview point of view. So let us start. Before talking theoretically, I will demonstrate and then we will go with the theoretical definition later. So let me quickly go to my IDE where I have some tables. Let's see what tables I have. Uh, I can say show tables. Okay, so basically we have courses and students table. Let us play with the students table. So we will take the students table into consideration. So what we will do is, first I will say select star from students just to see whether the data is there or not. Around 8 records are there. Good enough to get a fair understanding. Okay. So now what if my problem statement is something like I want to uh, get I want to get the total number of students who have joined from each source. The sources are like LinkedIn, YouTube, right? Students are getting to know from about me from these platforms, right? Now what if I want to get to know that, okay, from LinkedIn how many candidates have registered, from YouTube how many candidates have registered, and so on. Then the query is simple. So basically the query will be select source of joining, because that's a column name where we have data like LinkedIn, YouTube, Google, things like that, comma, I can do a count star for the aggregation because I have to aggregate the data based on source of joining. So definitely in this case, I have to do grouping on source of joining. So I will say select source of joining, comma count star from students, group by source of joining. You might be wondering what's so special, we have covered this. That's fine. Let's talk more about it. And I am giving a alias name. The name of alias is total. Let me just run it, go back to my IDE and see. So this says through friends, one person has joined. Through Google, two people have registered for my classes. Through LinkedIn, two people. Through Quora, one. And through YouTube, two. That's how we get to know. Now, what if I want to, let's say, for example, say that I want only, or I want to display only the rows where total is greater than 1. That means I only want Google, LinkedIn, and YouTube because total is greater than 1. I mean, more than one person has joined through whatever platforms I want to see that. What can I do in that case? So I will write here what my problem statement is. I want to know the lead sources to which more than one person has registered. In such case, the answer should be Google to, LinkedIn to, and YouTube to. What to do in order to get this? What should I do in order to get this? Right now, this is our query, as you know. Now, you might be wondering, oh, we can say where and then where total greater than 1. I hope you might be feeling that this can be done because already we have got these results. I'm not sure whether I can copy these results. Let's see. Oh, okay. Yeah. So now this is our data. Now you might feel that we can do a filter based on total and we can use the where clause like this. But this will not work. I will show you that. If I take this and try running, this will not work. Why? I'll tell you. The reason is this where clause, whatever we have, this can be used before group by. That means where clause is good to filter individual records before any grouping has happened. So I will write it here. Where clause is used to do or to filter the individual records before aggregation, right? In the previous case, what we were doing is first we were doing a aggregation using group by, and then we were thinking to filter the aggregated records using where. It won't work. Where says I do not know how to deal with grouping. I can only deal with individual records. I hope this is clear. So that is why it has failed. Now, what could be the solution to this? We could have very well said instead of where we could have used having. So let me just copy this, and instead of where we can say having. So having is used after group by, and it is mainly used to filter the records after the grouping has happened. I hope this is clear. Let me just run it and show you the results. And we can see the results as we expected. So where clause has not worked, having has worked. Reason being, or what's the difference? Where is used before the aggregation on individual records to filter out individual records. Having is used after the aggregation to filter out aggregated records. Right? I believe this should be pretty much clear to you. Now, one more thing. I'll write a query and then you tell me what will happen. What if I want to get the count only for LinkedIn? That from LinkedIn, how many total people have registered? Right? I want to know from LinkedIn how many total people have registered. What can be the query? Let me just copy it and modify. So I will write my problem statement. I want to know the people who registered through LinkedIn. Total number of people. I want to know the count of people who registered through LinkedIn. Now the query can be select source of joining. Let's say I want source of joining also. That's fine. Comma count star as total from students grouped by source of joining. So till now it is as usual because we will get aggregations of all, and we could very well say having source of joining equal to LinkedIn, because you know that after the group by where won't work. Having is the only choice that we have. So this should give us the total number of people who have joined through LinkedIn. Let me just try running, and we can see through LinkedIn, two people have joined. If we try replacing having with where clause here, it will give us an error. You can see this. So basically, having is what we have to use. But now you might be wondering that this is not a good way, because in this case, what we are doing first, we are trying to find the results for all lead sources, even LinkedIn, Google, YouTube. We are doing complex aggregations. After that, we are just filtering for LinkedIn. That means when we want it for LinkedIn only, why are we not filtering early? We should do filters as early as possible in the game, right? because kind of we are doing our complex activities on 10 lead sources. After that, we are just filtering for one after doing all the complicated work. How does that make sense? So we could have applied this filtration before the group by clause. So instead of this, I would prefer the perfect or better query could be select this having clause I will remove, and I can say select source of joining comma count star as total from students where source of joining equal to LinkedIn. That means I am writing where clause before group by, which is totally okay. That means I am filtering the individual records before even doing the aggregation, so that I only aggregate the LinkedIn set of data. I will not have to aggregate Google, YouTube, and all of that. So this will save a lot of effort and will be more performant. Even though the output is same, but as I said, we are learning SQL the right way. Our aim is not just to get the output and be happy, but the query should be performant. Let me try running it and show you the results. Same results, but more performant, because we are not doing all of the hard work. We are saying, okay, first I want to get only the individual records which I have to aggregate, and doing the aggregation. I believe this should be fine. Now, are there cases where both we can use where clause and having? Can we use where and having at same place, or in same query? Yes, we can very well use. Where will be used to filter the records before group by. When we are very sure that okay, I want to only go ahead with this kind of data, with this kind of individual records. For example, let's have a scenario. What I want is, I want to know the locations, the location from which more than two, or from which more than one student has joined. You know that locations are there in our table: Bangalore, Hyderabad. I want to know such locations from which more than one student have joined, right? But also I want to make sure that I am checking only for people with more than 10 years of experience, and the students experience is more than 10 years, right? So basically I just want to consider students with more than 10 years of experience. That's the first thing. Second thing is, I want only the locations from where more than one student has joined. These are the two clauses I have. In such case, what we can do is, we can say select location comma count star from students group by, from students group by, what would be the grouping criteria? It will be location, location, right? Now, experience more than 10 years, that we can easily do before group by. This does not require grouping to find it, right? So before this group by, so first of all, count star I will name as, let's say, total from students where years of experience equal to or greater than 10, sorry. So you can see this filtration I am doing before my group by, right? Let me just see if recording is happening. Yeah. So this filtering I am doing before my group by, because why do I have to first do grouping and check that? I can eliminate the records as early as possible, so that I do not have to do more of grouping later. So group by location having total greater than 1, as simple as that. Because this thing, whatever we are writing in having, can only be checked after aggregation has happened. Because until we do the aggregation, how do we know what's the count? As simple as that. But anything which could have been done before, I am trying to do before. So the thought process should be do filtering as early as possible so that we do not do heavy crunching and then later filtering it out. That should be the thought process. So let me just see. And we can see Pune is such location from which three people have joined, and then all of the candidates are more than 10 years of experience. Now let me try to reduce the number of years of experience to see if the results changes. 5 years. Then of course from Bangalore we have two people, Chennai we have two people, Pune we have two people. So with this kind of, we have got clarity that what is the difference between group where and having. Where is used before group by, having is used after group by. Where is used for individual, so I will write it. Where is used before group by and do filtering on individual records. Having is used after group by and do filtering on aggregated records, right? And I would say we can use where and having in the same query also. Also, I want to say that where is more performant than having, but it's that not everything you can do through where, because sometimes you require to aggregate the data and then filter based on that aggregated data. There having is the only choice, but whenever you want to filter individual records, then you should go for where, not having. Because if you go with a having clause there, then you are doing a lot of hard work and then I mean doing filtering later, which is not a good scenario. So whenever you can do or apply where, you should be doing that. And when the need comes, definitely you have to go with having also. So with this, you should have got a clear clarity. And why I emphasized on these points repeatedly is because this is a very important interview question, right? A lot of chances are there when you go for SQL interview, definitely this thing will be asked. And as I continuously say, the aim is not just to get the results. Results anyone can get. All what you have to focus is, are you getting the results quickly? And you can get the results quickly when you know the internals, when you know what to use where. So with this, let's wind up the session and I hope you liked it. Thanks a lot. Hello friends, welcome again. This is the 13th session in the SQL playlist and a very important session. In this, I will talk about over and partition by clause. Right now, you might not understand this, but let me take an example and then let's build the knowledge on that. So I first of all will create a table with the name employee. There are few columns: first name, last name, age, salary, location, all of this. Very basic table and some insert commands. And names I have kept mostly, cricket player's name. So for example, Shane Warne, 30 years old, 20,000 is the salary, lives in Bangalore. Just a random example. So we will try to create this table, run this insert statements, and then have this data. In the previous sessions, I have shown you GURM ID where we have done all of our work. But in this session, we won't be using it. The reason being, whatever I want to demonstrate will not work there, because the functionality that I'll be showing works on newer versions of MySQL but not on the old ones. That IDE was using the older version. So what I will use is, I will use one compiler, which is again an online one, and you can just take this link and paste it in the browser. For example, you can see this, right? And you can say one compiler dot mysql, and directly it will show all of this. You can remove this because you want to start from scratch. Okay, let me see if it is recording just to see. Yeah, all good. Now let me take the inserts and the create table command and run this. Okay, and I will say run. So you can see that it has run successfully, and we are even seeing your program did not output anything because we have no select statement. That's fine, totally fine. Now the setup is all done, and let's say our problem statement is that I want to find out that how many employees work in Bangalore and what is their average salary. So I want to find out how many people are from each location. That means from Bangalore, how many people? From Hyderabad, how many people? From Pune, how many people? So on. And average salary at each location. This is what I want. That means the result I want is something like Bangalore, and the number of people that work are, let's say, 3, because if you see this data, 3 people work for in Bangalore, and the average salary is, let's say, 16,666. How I'm saying? Because 10,000 is of this employee, 20,000 plus again 20,000. 3 employees are there, total salary is 50,000. 50,000 divided by 3 is 16,666. Similarly, I want for Hyderabad and Pune. This is what I want. So there will be 3 output rows. One is for Pune, one is for Bangalore, and another one is for Hyderabad. I hope this should be clear. I want these results. You will say, okay, there is no big deal about it. I can write a query something like, you can write something like select location comma count of location comma average salary from employee group by location, because you want to group by location and do this aggregation of count in each location and average of salary in each location, and this would work perfectly fine. Let us see. So I would place it here and run this. It says in Bangalore, the let me copy this actually, because the output terminal is not that great here. So let me copy, and this is the output it shows. I'll put a tab. This is how it is showing us the results, right? Which totally makes sense, and this is what we wanted. We could have given some alias names to this, but that's fine for now. So we can give anyways. So what we can say, count location as total and average salary as average. Let's see. If we do this, it will give alias names, and that will even look better. So good, this is fine, and you will say no big deal about it. I was already aware of it. Fine. Now, what if problem statement slightly changes? And what we want is, we want to have the first name, last name before it. That means what we are looking something like is, I'll just show. Do not worry what I'm doing, but I want to show the results I want from employee. Okay, I'll tell you what results I'm looking at. So I will want something like, so first of all, let me remove this. So I mean to say I want few aggregated columns which are that the count and the average, and few non-aggregated columns like first name and last name. This is what I am looking at. I want this results, and when we take for this Hyderabad, it will be something like this. Why I am doing this hard work is to give you clarity that okay, what exactly is the result I am looking at. And then we have towards the end Pune. So let's remove this. This is the result I want. How do I get it? You might say, okay, I can use the same group by. Okay, let us try doing that. Let me take my previous query. And if I try just adding first name, comma, last name, like this, will it work? No, it won't. Because you remember that we are trying to use first name and last name, but it's not a part of aggregation. If it is there in, I mean, group by, it would have taken, otherwise it won't take. You know that already. So we cannot combine it like this. It will definitely throw an error. So we can try running and it will say it won't work. Select list is not in group by clause and contains non-aggregated column. You can check that out. So that means it's not going to work out for sure. Then what is the solution to this problem? How to rectify this? What can we do? So what we can do is we could try achieving it. We can try achieving it using a join, which is not the best approach, but let me show you how you can get it using a join. Let us see what you can say. So you have this, right? Where is that? This one. Okay, let me take it directly, and this will become my subquery, right? And whatever result comes from this, let me store into a table, a temporary table, let's say, and the name that I will give is, let's say I will say temp table. Temp table. What I finally want, let's see, I want first name, last name, location, and then total count, comma, average salary. This is what I want, right? Okay. From which table you want? From employee. From employee, we will definitely get first name, last name, and location. But the total count and average salary we will get from the temporary table, the table that we will have. So we need to join this employee with temp table. Join temp table, right? So instead of doing this, we can just copy this entire thing and put it here. We are joining employee table with this temporary table which has this aggregated columns. What condition do we have to place for join? On what condition? Employee dot location equal to temp table dot location, because the location column is the one which is common among the two. Now if I try running this, will this work? First of all, we need to give alias name as total count, and then we have to say as average salary, like this. Now if I run this, will it work? Actually everything is fine apart from one thing, that is this location column which we are selecting, it belongs to employee table also, and it is a part of temporary table also. You can see this. So system will get confused that from which table I should be picking this, and this becomes ambiguity. So here we have to manually resolve this ambiguity, but let me show you that this will say there is an ambiguity here. I'm just writing it here and then running this. And it says column location in the field list is ambiguous. You can see this. So you got to know that everything is fine, but there is just one issue. How do we resolve? We can give a table name explicitly saying employee dot last name. Sorry, employee dot location. Okay, I'm just giving space so that it's better readable. I hope this is clear. Now let me try running this. This will work 100% without any doubts. And you can see the result whatever we wanted. We said we need the first name, last name, and then location. Of course, the indentation here is not good. Do not worry. This is a not the ID we will use forever, right? But just to understand this example. So first name, last name, location, and how many people are there at that location, and the average salary of people at that location. So basically, whatever we wished, we are getting here. I mean, let me copy the result and show you, is it the same what we wanted or not? We wanted this, and we what we got is this. Is it the same or not? Yes, this is the same. We can check it out. So we have achieved it using the join, but is there any other easier way to do that? Yes, there is a way using the over and partition by clause. We can use over partition by, right, partition by to achieve this easily without much efforts. Joins and all look complicated and it's not that efficient. So the easier way to do it is using this partition by and over clause. This works like a syntactic sugar. That means you are able to achieve it easily with minimum syntax. How do we do it? So what we can say is, we can say select first name, comma, last name, comma, location. I have given all the non-aggregated columns till now. Okay. Now I have to give the aggregations. What I want, count on location. We have to give over keyword over. And then just like we were doing group by, on what kind of thing we have to do grouping, or on which column we have to do grouping? On location, right? So instead of group by, we have to say partition by location. Now the benefit of using partition by is that you are able to use the non-aggregated columns also like this. But with group by, were you able to use? No, you were not. So you can say count of location over partition by location. So how it internally works is, first it partitions the data based on location. Let's say Bangalore's data is partitioned, Hyderabad is in one partition, and Pune is in one partition. After that, it will count for it. Now, after that, if we want one more aggregation, we can say average of salary over, and then again same way, partition by location. Quite easy, quite logical, and very intuitive. And we give it, let's say, some alias name as I would say total, as average, any name, that whatever we want. And then from employee. Now you tell me whether this looks good or this looks good. Of course, the second part. And it looks very logical, very intuitive, and a very good syntactic sugar to get the same results achieved easily. Let me try running it and showing you. So this ID is a bit clumsy, of course, to use, but that's fine. I have used this and let me try running. And you can see I get exactly the same results. You can check it out. But which one is a better way of doing? Joins or this one? Of course, this one, because if I show this query to someone, it becomes easy for them to relate what's happening. But if I give this, then of course they have to try understanding what's happening. So this is how we can use a combination of over and partition by to club the non-aggregated columns, which are these three, along with the aggregated columns, which are these two, easily, because directly group by does not work. This is a very important thing even from a SQL interview perspective. Make sure you understand this well. And I believe this session would have given you fair enough idea on this. In the next sessions, we will do a continuation on this and we'll talk about things like rank, dense rank, and all of that stuff. So with this, let me end the session. Please do subscribe to my channel so that you do not miss out on upcoming videos. And also do like the video if you feel that you have understood from it and if you feel the content is good. With this, let me end the session. Thanks for listening. Hello friends, welcome again. This is session 14 in the SQL playlist, and in this session we are going to talk about a very important topic, which is row number. So row number is a function in SQL and is very well used in industry and even asked in interviews. So let's see how to use it and how do we see the results. Now, in the previous session, we have seen how to create a employee table with first name, last name, age, salary, location, and inserting some records. I will still keep the same script handy so that we are building just on top of it. Now, let me write a query. So you understand that we have a table, employee table, and we will be inserting some records. Let me write a query. Select. So let me turn on the case. Select, let's say, first name comma last name, okay, and salary, right? Select first name, last name, salary. Now let me show you how to use the row number. First of all, these three columns were directly there in this table: first name, last name, and salary. Okay, now I'm showing you how to use the row number function. What I will do is I will say row underscore number, and I have to give this starting or opening braces and closing brace. So we are giving this function over. Remember in the last session we have given an aggregation function here and then we said over clause. Same way we are doing row number over, and then we have to give the order clause. Order by salary, let's say DESC. I am saying I want to sort the salaries in descending order, and the salary which is the highest, that will come at the top. But I want to give it number 1. The salary which is second highest, I want to give it number 2, and so on. That is what I am trying to say, that first sort it or order it based on salaries in descending order, and then start assigning the row numbers from 1 onwards. This is how this works. And then we say from which table? Employee table. Let me pick all of this. Let me pick all of this and try running it. I'm still using the onecompiler.com. Okay. You can see I am creating a table, inserting some statements, and then I am printing some normal columns and then using row number over order by salary descending. Remember, this row number cannot work when you are not using order by, because what's the whole point of giving some numbering when you are not ordering it? As simple as that. So order by is mandatory when we are talking about row number. So this is how we have to use. Let me try running it and show you the results. So you can see first name, last name, salary is 30,001. So the highest salary you can see is having the row number as 1. The second highest salary is having the row number 2. The third highest salary, row number 3, and then 4, 5, 6, and 7. That's how it is. So basically it has ordered it first, and then it has assigned the row numbers starting from 1. Right? So now if I have to find, I want to find the fifth highest salary. Let's say my problem statement is I want to find the fifth highest salary. What can I do? I can even do something like this. I can say, so I will copy this. So I am just saying my problem statement is find the fifth highest salary. This can be done with many approaches. I'm not saying this would be the only approach, but I'm telling you that this can be done easily now. How to do? I'm just copying the previous query, and this row number over this, let me give it some alias name. I will say as row num, okay, from employee. Now what we can do is I can write a query on top of this saying select select star from this table. This will act like a table. We will give some temporary table name. We will say temp table. Select star from table where row num equal to 5. As simple as that. And this should give me only the record which is having the row number as 5, and that means that we are getting the fifth highest salary. Let me check that. So, okay, instead of this, let me put this. Trying to get the fifth highest salary. Let me run it, and you can see Saurabh Ganguly. And I mean, if you can see my previous, I will do a control Z to see what was my previous result. So you can see fifth one was Saurabh Ganguly, this one. So this is how you can easily get the fifth highest salary, third highest salary, or things like that. So you can see that this is really an important function to use. But remember, if I do not give order by here, it won't work. Because what's the whole point of assigning a row number when it's not ordered in any logical way? It should be first ordered based on some logical way, and then we start giving numbers, row numbers. I hope this is clear. Now I will even show you how to partition this also. So let me pick this one, and I will tell my problem statement first. The problem statement is I want to find the let's say I want to assign row numbers based on each location. So the problem statement is to assign row numbers for each for partitions based on each location. That means there will be some people who are in Bangalore. For example, you can see here Bangalore, right? Third person is from Bangalore. We want to first partition it based on location. That means Bangalore should be one partition, Hyderabad should be another, Pune should be another. And then we want to assign the row numbers within each partition, right? So let me show you what I am trying to say and how to achieve it. So I will copy this query, select first name, last name, salary, row number over. Remember, order by is something which you have to keep. You cannot remove that. But what we can also do is we can say by, partition by, and what column on is there on which I have to partition by? Location. I'm saying first partition it by location, and then order by salary within each partition, and then assign row numbers. So let me just try running it and show you the results. Okay, and you can see here I will give a location column also here. Location. Okay. Now let me try running this. So you can see this. Bangalore, we have Shane Warne, Rahul Dravid, and Sachin Sharma. Whoever Sachin Sharma is, I do not know. So, but you can see first it has clubbed it into partitions. That means Bangalore is one partition, then Hyderabad is another partition, and then Pune. And within each partition, it is doing the ordering, you can see, and then assigning row numbers. In case of ties, it will take care. We do not have to worry, right? You can see 20,000, 20,000. Of course, it's same. So it's assigned one of it as one and another of it as two. That's fine. But 10,000 is definitely three. In Hyderabad, 30,000 is 1 and 25,000 is 2. In Pune, 15,000 is 1 and 10,000 is 2. So this is why how we have added one more layer of partitioning and then doing the same, assigning the row number. I hope this is clear. Now, what if, so I will just say salary and location, right? Location also we have added. Now, what if I want to find out the highest salary getters from each location? What I want is, I want to find the highest salary getters at each location. That means in Bangalore, who is the one who is getting the highest salary? In Hyderabad, which person is getting the highest salary? And in Pune, which person is getting the highest salary? What can I do? I can take the same query which is there I have written, and I can say select. So basically, I will give or make it as inner query. So you can see here, select star from this, right? And let me give this row number some name, then only we will be able to filter based on that. So I will give some alias, let's say as row num, and then I am giving this particular thing a temporary table name, let's say temp table, right? So select star from temp table where row number equal to 1. That means in all the partitions we will have, I mean, so basically what you have seen is whenever the partition changes, the row number starts from 1 again. You can see for Bangalore, it has started from 1. For Hyderabad, again it started from 1. And for Pune, it's again started from 1. So all what we want to pick is all the rows with row number equal to 1. And then definitely we know that we will be able to find the top 3 salary getters, I mean, the top salary getters from each location, right? So I will be able to get this row, and this one. Let me try running this now to see if it works. And if there is any syntax issue, we'll solve it. So if you see, and now let me try running this. Of course, this terminal is a bit cumbersome, but it's fine. So you can see Shane Warne from Bangalore is having the highest salary, which is 20,000. Rohit Sharma from Hyderabad is having the highest salary in Hyderabad, which is 30,000. And Saurabh Ganguly from Pune is having the highest salary in Pune with the salary of 15,000, right? So this is how it becomes very easy to do all of this stuff with row number. So all what you have understood is that when we use row number, right, row number function, we should be using the order by clause. If you do not use order by, it won't work. It won't accept at all, right? The second thing is we can also use the partition by, but it is optional. It's not that it's compulsory to do. Partition by is optional, And whenever we use partition by, the number again starts from 1 for the next partition. So the row number starts from 1 for every partition. Right? This is what we have understood. And with this, you should have got a fair enough idea on what is the role of row number and how to use it, and what are the problem statements we can solve. You can totally understand one thing, that if you are not ordering it, then assigning a row number and then doing anything does not make any sense. And why I have emphasized on this row number so much is because, I mean, in your SQL interviews, this is super important. Definitely, sometimes we feel it's easy, but we are not able to answer it or know the right use case to it. Right? So make sure you learn this well, and this can be really, really handy when you go for interviews or even when you start working on your projects on real time scenarios. So, with this, I feel we can wind up the session, and I hope you liked it. Thanks a lot. Hello, friends. Welcome again. This is the session 15 in the SQL playlist. And in the session 14, that is the previous session, we talked about row number. In this session, we will talk about rank and dense rank, which are related topics when we compare it with the previous session. So, if you have not checked session 14 on row number, I would suggest that please check that and then you can visit this session. So, let me proceed. Consider we have an employee table. We have talked about it earlier. We have few columns. The column that we are interested in is the salary column, and we have some insert statements, and we are inserting the records. This again goes in line with what we have done in the previous session. So if you have not checked, please have a look. Now you remember we ran this row number query where we said select first name, last name, salary, comma row number, okay, over order by salary descending order. That means when we are using row number, we should be using the order by. Ordering is mandatory, then only the row numbers are assigned starting from 1. Right? And even if there are duplicates in this salary, still it will end up assigning a different row number in sequential order. That means it do not consider duplicates that way. Let me run this and show you just for your quick recap. So I have the create table insert statements, and I am running the select query where I'm using row number. We have seen this earlier, but let me still run this. And we can see that how exactly the results look like. You can see that Rahul Dravid has a salary of 20,000, Shane Warne has a salary of 20,000. Both of them are duplicates because the salaries are same, but still randomly it ended up assigning row number 3 and 4. Right? So this is the challenge, that ideally we should use row number when there are no duplicates. When there are duplicates, then how does it make sense that okay, Shane Warne's salary is third highest and Rahul Dravid's salary is fourth highest? Does it make sense? No. They both have same salary. Then it should have been that if I ask third highest, both of them should have been listed ideally. So that is why we have other things or other functions like rank and dense rank. Because row number do not solve this problem of duplicates. It cannot handle duplicates properly. So that is where we will see how to use rank and dense rank. So let me just move all of this down. And what I will do is I will make two copies of it. In the first, we have used row number. In the second, let me use rank. And in the third, let me use dense rank. I'm trying to use all the three, and I will show you How does the results differ? So let me just copy these two also and put it here, and now try running it. Again, remember, just like row number, when we use row number, order by is mandatory. Similarly for rank and dense rank, order by is mandatory, partition by is optional. Because until we do the ordering, then what's the point of assigning a rank or row number or dense rank, right? So it is mandatory. So let me run this now and let us see the results. So this is the result of row number, where you can see that each row is assigned a different row number. Even when there are duplicates, it's assigning a different row number. That means row number does not add much value when we have duplicates. Talking about rank, so you can see that the first row or the highest salary is assigned the rank of 1, the second highest is assigned the rank of 2, and you see 20,000 is assigned the rank of 3. But when there are duplicates, it assigned the same rank to that. You can see there are duplicates 20,000 and 20,000. The rank assigned is exactly the same. But now important thing to observe is, for the next record, it does not give 4. It kind of omits that, or it becomes like a whole. That means ideally, if we are using row number, this would have been row number 5, same result we will get. That means it will skip some of the rankings when there are duplicates. So you can see ideally this should have been 4 as per row number. Sorry, this should have been 3. This should have been 4, and of course this should have been 5. So ideally, if we would have used row number, it should have given us 5, and same result is displayed. So only when there is a duplicate, then same ranks are assigned, and it leaves holes in between. And when we talk about dense rank, as the name suggests, it won't skip anything. So for example, we get 1 for the highest salary, 2 for the second highest, 3 for third highest, and when there is a duplicate, again the behavior is same as rank. That means we are assigning the same number or same dense rank to the thing, and after that, for 15,000, it does not skip the next one, right? It assigns 4. So that means it won't skip any rankings, or there are no holes in this. The numbers are densely aligned. Think it this way if you want to remember. But in case of rank, of course, it skips some of the ranks. I hope this is clear. One thing to note, if this data set has no duplicates, then row number, rank, and dense rank lead to similar results without any change. So if there are no duplicates, then the results with row number, rank, and dense rank will be the same. I'll write it here. So if there if there are if there are no duplicates, then row number, rank, and dense rank lead to similar results. Only difference comes, only the difference comes when there are duplicates. When there are duplicates, row number of course is not recommended, because it does not handle that situation well, and we should be using rank and dense rank. When we talk about rank, uh, for duplicates, same rank is assigned, and the next entry and for the next entry it skips the ranks. That means ideally it's the same scenario as row number, what the rank it would have assigned for the Next, non-duplicate entry. I mean, theoretically it's hard to convey, but I hope with that example, it should be clear to you. Think it from example only, that when there was a duplicate, same ranks were assigned, but for the next thing, it assigned a rank which ideally it should have got when we are using row number. That means it skipped, it considered it as 4 and then it assigns it as 5, let's say. You think it this way. But when we talk about dense rank, it does not skip any number even when there are duplicates. So right, and dense rank, it does not skip any ranks in between. Right? So this is how you need to remember. Now, for example, you might think, okay, what is a scenario I should use dense rank? Right? So row number is simple, that whenever you do not have used duplicates, so whenever you do not have duplicates, use row number. Okay, but when to use dense rank, actually it depends on scenarios. Ideally, for example, I want to let's say there is a match, there is a there is some tournament, and we want to find the top three candidates who scored the highest, or instead of tournament, let me say competition, right? And top three candidates who scored the highest marks. Now, someone scored 100, another person scored 100, one person scored, let's say, 98, and another person scored 97. Okay, and then let's say, this person scored 97, and then someone scored 96. If I want three top candidates, or I want to distribute three prices, I want to distribute, or I want to find the top three positions, right? Then what should I do? Ideally, both of them should be first, right? So rank 1 will be assigned if you are using dense rank. So if you are using dense rank, then 1 will be assigned to them. This will be 2. This will be 3, right? And this will be 4 if we are using dense rank. Ideally, all of this should be, awarded if we have a competition, because both of them are first. This person is second and these two are third, right? So if we are using dense rank, then all these 5 people should be awarded if we are looking for 3 positions, right? Or top 3. That this person is first, but first are 2 people, second is 1 person, and third are 2 people. So it totally depends on your scenario, actually, right? But if you would have used a normal rank here, this would be 1, this would be again 1, this would be 3, because of course this would be 3, it will skip 1, and this would be what, 4, this would be again 4, and this would be 6, right? So this is how it would have been. So if you really want to award top 3 people, then you could have done 100, only this. If you are going with rank, you would have considered only these rows. But if you are going with dense rank, you would consider all of these 5. So it totally depends on your business requirement, ideally. I hope this is clear. So, ideally, if you can see the other things, it works exactly the same way which we have done in row number and all. For example, in this, if we want to find, let me remove it. So, for example, let me check where is the duplicate. First, second, third. Okay, fine. So, consider in this case, there is no 4. But if we want to find that who is the fourth person who came, if we are using rank, it won't show up. But if you are using dense rank, it will show up. So it depends what you are using. And same way, just like we have used this query, you can use it. I will show you. Logically, I think you are clear now. I am just showing you various these things. Uh, let's say I copy it and I say rank, where row number equal to 4. Do you feel it will result anything? It won't give any result because there is no one with this row number as 4 as it is getting skipped, right? So let me just try running it and it won't display anything. But when we use dense rank here, it will definitely result. You can check because none of the ranks are getting skipped in this case. So I hope you should be pretty clear. And of course, you can add the flavor of partitioning, which we have done earlier. There is no difference. Partition is optional, order by is mandatory. And when we use partition, for the next partition, the rank or dense rank starts with 1 again. So the similarity between the three, row number, rank, and dense rank, is order by clause is mandatory, partition by is optional, right? And for partition by, or when we use partition by, then for next partition it will start the entries from 1. In row number we should be using whenever we know there are no duplicates, and when there are no duplicates, your row number, rank, and dense rank will lead to the same results. But when we use, or when there are duplicates, we should use rank or dense rank, and rank will leave holes in between. It won't be continuous because some ranks will be skipped. In case of dense rank, none of the rank will be skipped. That's how we need to remember this, right? Now, idly in my, I think, last session, I talked, or I used the term temp table. Idly, it's not a temp table, it's a derived table, if you think logically. But we can give any name. So, for example, if I'm running this, right, just let me take it. I think one person even got confused there. So, that's why I'm reiterating. It's idly a derived table. Temp table is the name that we give to that, but does not mean it will make it as a temp table. So idly, this whatever we say, for example, this inner query, this will basically create a table which is like a derived table. So but the name we have given temp table, it's fine. Name does not convey that, oh, it will be a temp table. Temp table is a different concept which we will cover in future sessions. So it's actually a derived table, and we are using a inner query here, right? So this is how it is. This is quite important from an interview perspective because we should be aware of totally what's the difference between, uh, I will just write it here again, row number, rank, and dense rank. We should know what's the similarity, what's the difference, right? I think we have covered it in good detail. Remember one thing, if there are no duplicates, results from all these three things would be the same. If there are duplicates, then of course we should be using rank or dense rank. But how they behave is, in case of ties, both of them would give the same number. But for the next subsequent record, it would basically skip the ranking in case of rank. But in case of dense rank, it won't skip. That's the difference. And it totally depends on your business scenario, that what you want to use. Right? So with this, let's wind up, and I hope you like the session. Do subscribe to my channel if you have not done, and I'll be coming up with more interesting videos like this. Thank you all. Hello everyone, welcome again. Sumit this side from Trendy Tech. And as you know, SQL is playing a very important role these days. If you are looking for data analyst, data engineer, big data developer, or data scientist, whatever role it is, the role of SQL is very, very important. And I have promised that I'll come up with a session on order of execution in SQL. So I have come up with a session now. And in this, I'll talk about when you write a SQL query, writing style is different, but execution style is different. So I will talk about the execution style, and we will be seeing the explain plan of the query. Also, we will talk a little bit about indexes. So basically, this is to talk more about internals of SQL, and this cannot be done in one session, honestly. So I will have series of sessions where I will try to cover these concepts in extreme depth. So this would be the first session in internals of SQL. Okay, so let's have a small table orders, right? So we have two tables, orders and customers. These are the two tables which I already have. I will show you. I have this orders table. Let me see how many records are there. Select count star from orders. 6,800, 68,883. These are the number of records in orders table. I'll again do a start so that I show you what columns I have. I have order ID, order date, customer ID, and order status, right? So basically, one customer would have more than one record here, because if you are purchasing something from Amazon, it's not that you will only purchase once. You can do multiple, or you can place multiple orders. So that's where one customer can have multiple records in the orders table. And this has just four columns. Okay. Just to let you know, order ID is the primary key. And I will show you that. So if I see here, where is it? Orders, indexes, I have primary key, right? I have primary key orders, right? And let me show you the other table, which is customers. And it has more columns. And you can see here we have customer ID, customer first name, last name, username, password, address, city, state, and PIN code. Now, in our orders table also we have customer ID. In our customers table also we have customer ID. But in customers table, it is the primary key. So in orders table, what is the primary key? Order ID. And in customers table, what is the primary key? Customer ID. Now, what is the common column in both the tables? It is customer ID. Customer ID is the common column in both the tables. Right? This is how we have. I hope you are little clear about what data we have and how we have it. Okay. Now let's start looking into some details that how exactly to check the stuff. So basically, I'll show you here. Let's say I run the query select select order ID, comma customer ID from orders, where order ID equal to 5. Right? I am running this query. I want two columns, right, from orders table where order ID equal to 5. Let me try to run this query. Fine, nothing so special about it. But let me see the plan for it. Explain plan. Now you can see here, when I hover on it, it says clustered index seek, right? Clustered index seek. And you can see estimated number of rows to be read is just 1. That means looks like it's a very fast operation. Something has happened very good that it does not have to read so much of data for this, right? On what object this operation is performed, which is object means the table name here. We have the operation performed on orders table, and output list is we are retrieving order ID and customer ID. These two columns, if you can check. And seek predicate, that means seeking means fetching a record, right? So seek predicate is nothing but we are seeking something on order ID. So now I will tell you what do we mean by clustered index seek. So there are two things, seek and scan. I'll show scan also soon, but there are two things, seek and scan. Seek is generally quite faster than scan, and scan is slower generally. But I mean, you cannot take it that okay, always that's the case, but 99% that would be the case. Now, what is a seek and what is a scan? Seeking means that kind of you are quickly able to get one record. That is seek. Scan means you have to go through the entire data in order to retrieve it. For example, if let's say I have numbers from 1 to or let's say I have some numbers 1 7, okay, so 1 7 4, right? I'm trying to explain you, I mean, in a way that you can understand. Let's say we have some numbers like this randomly distributed, right? 3 like this. How many numbers are there? 4 5 6 7 8. Okay, these are 8 numbers. If I have to search 10 in this, is there a way to do it quickly? Probably not, because I have to search first this, then this, then this, and then finally I will come here. That means if there are n elements, then we have to search n elements in the worst case. Worst case. Like complexity is kind of order of n, right? That means if you have 1 lakh elements, you might have to end up scanning 1 lakh elements in order to search for something. But let's say if this is sorted, if this would have been sorted, let's say if it is something like 1 2 3 4 5, or 1 2 3 4 5 is not there, okay, 7, right, and then we have 8 9 and 10. If this would have been sorted, then in this we could have applied a binary search and it would have been much quicker, right? So basically if I have to search now, I could, I mean, quickly search for 9, because first I can come to middle and then again every time I can remove half of it, right? That means if my elements are sorted, the searching becomes faster and it would be much quicker. So that's what I wanted to tell, that in a sorted thing, it's easy to find a record compared to a unsorted thing, right? Now, what happens is whenever you create a primary key, for example, on order ID, we have created a primary key. We have created, let me see if recording is going on or not. Okay, yeah, it's fine. So consider that we are having primary key on order ID. That means by default, a, a index will be created, a clustered index. So it will be, I mean, if you see, it will say clustered unique index. I'll show you again. So if I go to tables and I go to orders, where is this orders? Orders, and I go to index, it says unique clustered index, right? That is automatically created when we create a primary key. What is there? Unique clustered. Forget about unique for now, does not matter so much, right? Unique means that there won't be any duplicates, as simple as that. So that's not the matter of talking right now. What we want to talk about is what is clustered index, and the other kind of index is Yeah. So what we want to talk about, what is clustered index and the other is non-clustered, right? So let's first talk about what is a clustered index. Clustered index is the one, for example, if I am having a orders table, and if I am, let's say, entering first record with row ID 5, there will be many other columns. So let's say order ID equal to 5, I am entering now, and there will be, let's say, another 5 or 6 or 3 columns, right? We have 3 more columns, that's fine. So totally 4 columns, order ID is 5, right? Then this record will be inserted in the table. When another record with order ID 4 comes, it will be inserted before this, right? So ID equal to 4 will come before, right? And then when ID equal to 6 comes, it will come after this. That means it will make sure that the records are physically ordered, right? So that's where whenever a new record comes, it will try to little bit shuffle the records to make sure the physical ordering of data is maintained, right? I hope this is clear. So basically in this orders table, whenever a new record comes, it will make sure the records are sorted based on the order ID. So it will make sure records are physically ordered. So clustered means records will be physically ordered in the actual table. In the actual table. So basically at storage level, we are making sure things are stored in a proper way, neat way, in an ordered way, right? So that if you really want to search for something like select star from orders where order ID equal to something, it really do not have to scan so many records. It has to scan a lot less because it is indexed on that. And when we say index, it is sorted in ascending order and it can quickly search for something without wasting much time, right? Now talking about, let's say, when I hover, what does it say? Just a second, I'll run it again and I will say explain. So sometimes the hover does not work. I mean, I do not know why in my system specific issue can be, right? Yeah. So now you can see it says clustered index seek, right? Seek means since it is quickly able to search, it will say it as seek. Now, same query, if I search it based on customer ID, what do you think what will happen? Customer ID is not a primary key, nor we have created any index on it. So what will happen now? So you can see if I say the explain plan and I hover, it says clustered index scan, right? You can say it says clustered index scan. What does that mean? That means it's not quickly able to retrieve, it has to scan all records. And you say estimated number of rows to be read is 68,883. Why is this change? Because the data is ordered based on order ID, not on customer ID. So how will it quickly search for customer ID? There is no way. It has to really read all the records from beginning till the end. In the worst case, it has to read all records and then only it will be able to tell you, right? So if we do some searching like where clause on your indexed columns, it is faster. It will be like a seek. And when we do on non-indexed thing, it will be like a scan, right? So this is on a very general note I am talking about, right? That's how it works. I hope this is clear. Now, as I said, there are two kind of index, clustered index versus non-clustered index. So clustered index versus non-clustered index. What is this clustered index and what is this non-clustered? Clustered, you know by this time. That clustered means in the actual table, like orders table, we are making sure that the data is sorted based on the index, right? So, for example, let me open this, right? And I will try to show you. For example, let's consider we have an orders table, right? So let's say this is table orders, and in this, let's say the first column is the order ID, which is the primary key. Then definitely the rows will be sorted in this order: 1, 2, 3, 4, 5, 6, 7, and let's say this is the orders table, right? So this is nothing but a clustered index where in the actual table the data is stored properly. Now let's say there is this orders table, right? Now first column is, let's say, order ID. Second is, let's say, some date. Third is, let's say, some other column. And the fourth is customer ID, right? Now, what I am trying to say here, what we can even do, let's say, if we want to search something on customer ID, then you can understand clustered index can be only on one column, right? Clustered index can be on one column. It's not that you can sort it based on order ID also, and differently you can sort it on customer ID also in the same table. No, right? You can have a composite thing, but that's different. What I'm trying to say, let's say you have orders table, you can definitely create a clustered index on composite thing like order ID, comma, customer ID. But what that means is, first it will sort it based on this, and then if there is any ties, it will sort based on this, right? If there is any clash, that means we are getting 555, and then for those things, it will sort based on customer ID. That's a different thing. It's called a composite clustered index. So whatever I'm saying is composite clustered index. But what I'm trying to say, what is not possible is that you have a clustered index on order ID column, and then you again have a clustered index on customer ID column separately, because that's not possible. You can have just one physical way of ordering in the same table. You cannot, you're not creating two copies as such, right? So only one clustered index is possible. That's what I'm trying to convey, right? Now, talking about non-clustered index. What is this non-clustered index? We need to understand that. So I will go here. Now, let's say you are feeling that sometimes you really have to search a lot on customer ID. If in this table, whatever we have right now, we are seeing on screen, we search on customer ID, it will involve a full scan, right? It will have to search a lot of things. Then in that case, what you can do is you can create a non-clustered index on top of it. What is non-clustered index? What it will do is, basically it will have a separate index created. That means what it will do is it will have a separate structure in memory, in storage basically, right? So it will have, let's say, customer ID 102, customer ID 105, 107, 109. That means it will arrange the customer IDs in ascending order. It will sort the customer IDs, and it will have a row number or the address of that row, right? Address. That means, let's say I am running a query, select star from orders where customer ID equal to 107. Then it will see it has a non-clustered index which is there for customer ID. So it will come here, right, to this lookup kind of, and then it will see that, let's say we are searching for customer ID 105. It will be quickly able to come here because it's sorted in this, and it will be having the address, right? And this address will tell you that where exactly we need to retrieve it from the main table. Let's say this address might point to this record, for example, right? It will quickly tell, okay, look at this address in the actual orders table. So basically, it's a two-step process. First, we get the address from this index that is built, a separate index, right? And then we retrieve the record from that address. So definitely there is little bit of overhead involved because there are two lookups required. One is for the index, second is for the actual table. I hope this is clear. So this is called as non-clustered index, right? And you can have any number of non-clustered index. For example, we have on customer ID, we could have on date, any number of things. But only one clustered index is possible. I hope this would have made some sense, right? So with this, we have understood what is a clustered index versus non-clustered. I'll repeat it again. Clustered index can be only one in a table. If we are creating a primary key, then also clustered index is created. If there is no primary key, then also we can create a clustered index, but only on one column, right? However, we can have composite clustered index. That means together it's creating. So together the ordering is taken care. Now, non-clustered index can be on any number of columns, right? Need not be only on one, but it creates a separate structure. So the overhead is that for non-clustered index, it will require little extra storage because it has to keep the data. And moreover, in terms of reading also little overhead is there because first it has to check from the index, which is external index that is built, and it has to get the row address, and then it refers to that row address in the actual table, right? So that's how it works. Now, what is scan and seek? Scan is when we are not retrieving the rows based on any index, right? Then it will go for a scan because it has to go row by row. Seek is when it can quickly find it out. Okay. So now when I come here, you can see it says clustered index scan. That means it's not referring to any secondary indexes or somewhere else. It's referring to the actual table. The moment you see clustered means the actual table. Index scan. That means somehow it's not able to retrieve it faster. It has to go row by row. I hope this is clear because there is no an index on customer ID. But the moment I say order ID, then things change a lot. It will go for, I will show you what it will do is it will go for clustered index seek and it will be much, much faster. I believe this would have given you a good clarity on what I am trying to convey. So let's proceed in our discussion. Now, you have understood scan versus seek, clustered index versus non-clustered index. Now, let me try writing a query. What query I will write? I'll say select. First, I will write in a notepad, then I'll copy so that you have a good view about it. Huh. I will say select. Let's say city, comma count star, city, comma count star as total from orders, join customers. Do not worry, I'll explain you this query on orders dot customer ID equal to customers dot customer ID. Okay. Now I am trying to join these two tables based on customer column because it's a common column. That's fine. Where I'm having a filter condition also. Order status, let's say not equal to pending. There are many status types actually. I am saying I do not want to have pending payment status. Pending payment. Okay. And I want to group all the results by city, right? I want to check for each city how many total orders were placed. Group by city having count star greater than 10, right? Order by total DESC. I am running a query, this one. I'll explain you now. What I'm trying to say, I want to get for each city what's the total number of orders, right? For each city, what is the total number of orders? Let me run this query first and then show you so that you can understand it better. Huh. So you can see this CAG was 19,871 orders, but which follows what all conditions? That okay, what we are trying to say, order status was not pending, right? Pending payment. And moreover, we are trying to only get all the cities where the number of orders are greater than 10, right? So if you see, you will be able to find it greater than 10. So you can check this out. Select city, comma, count star as total. We are giving this alias from orders, join customers. These are the two tables. We are joining it based on the customer ID, which is the common column among all, where order status not equal to pending payment, right? So order status is in which table? This is in our orders table, right? Group by city, right? We are grouping it based on city, having count star greater than 10. So all the cities where total orders were more than 10, we are finding it out. I hope this is clear. And then we are ascending it, we are ordering it based on descending order. That means whatever city has maximum number of orders placed will come first and the others will come later. Right? So that's how we have ordered this one. Okay, now. So what we will try doing is we will want to see the explain plan for this. Okay, syntax error near star. Just a second. Okay, sorry. I have to select and explain. I'm showing you the explain plan. Unfortunately, somehow this hover feature sometimes does not work. It's a UI issue at my end. Might not be, you won't be facing it, I believe, but I would have a different way to show you that. Do not worry. Yeah. So now, if you see here, the same query, let me take and run it in a different terminal. I have set show plan all on. Do not worry about what is that. Nothing to worry. I will run this here. Right now, do not worry what I am trying to do. I will run this. And the same thing is in the text form here, actually. Since I was not able to hover on it, right? Hovering was not giving results. So I am having these things in text format so that I can show. So the very first thing that happens is, or how you have to read this plan is, you have to read it from right to left and top to bottom. That means you read it from right side to the left side and top to bottom. So I will say read the plan right to left and from top to bottom. Now you can see first thing that's happening is we are reading the data from the tables. Now whether it's a scan or seek, let's see. I'll come here and you can see this clustered index scan. It is a scan because customer ID, we are trying to get the data from both the tables. So you can see here, if I expand this, you can see clustered index scan retail db dot orders. So this is the orders table and it is getting the orders. Even the where clause it is putting here pending payment. If you see here, this clause order status not equal to pending, It is moving it more towards the storage so that we do not get extra records. We want to apply filter as soon as possible, right? Since it is able to do that, it has moved it initially only so that we only get the records that we want. Otherwise, why to have unnecessary records for further processing, right? So it tries to move the filter down, right? It is also called as predicate push down. That means filters are applied as soon as possible, whenever possible, because it should not give you wrong output ideally, right? If it feels that okay, it won't give you the wrong output, and it can move filters down so that we cut unnecessary data as early as possible, it will try doing that. And that's what you can see here. So whenever it's getting the data from orders table, it is applying this filter condition also, right? And you can see this arguments, same thing will be mentioned here. You can check this out. And output list, what all columns it will give you finally, it will only give you the customer id. From this only it will give what? Customer id, because other columns are not required from this table. You can check this out. So from your orders table, it is only giving you customer id, nothing else. I hope this is clear. That's where output columns list show you. Because why should it take other columns into consideration when it's not required? So it is eliminating unnecessary data in terms of the filter or in terms of the projection initially only. Fine. So now talking about the second scan that's happening, that is on customers table. So you can check this customers, and now uh, here what it's doing is it is again getting what all columns? Customer id, because that's required for join. So from both tables customer id is required, but what other column is required from this table? City, right? So only two columns it is taking, and remaining it won't take, I mean, forward. So kind of it has applied filter on orders table and just getting customer id from there. It has, I mean, it is just taking customer id in city from the customers table. So kind of eliminated a lot of data in the very initial stages, very starting, right? So this is how it is. Now, after this, what happens? After this, what happens? This do a join. Now, do not worry about hash match join or merge join. I'll talk or I'll cover in a separate video what are the different kinds of joins. It's not about inner join, left outer. I'm not talking about that. But how exactly server or SQL server is doing it internally, right? Hash join or merge join or it is a nested loop join, I'll talk about in a separate section. Do not worry. So now once we have these two tables, it has read these two tables, it is doing a join on it. So what is the, I mean, first it do uh, from, right? And then it do join, right? So it reads two tables. So this is the order from and join. After that, what it's doing, and this join also I will show a little bit here. So if you see here, join, what condition is there? Customer ID equal to customer ID, right? In both the tables, and it's an inner join, and you can check the argument if required, and you can see the output list is city, because city is the only thing we want to take forward now, right? So that's great. Now, what is the next thing that happened? The next thing that it's doing is it is doing a grouping aggregate. We have group by, right? So I'll write here after join, it's doing group by. Now, remember, along with your from whenever it's reading the data, it has done the where clause also, but not in all every case. It can be done here actually. Sometimes it has to do after join. I'll tell you a scenario. For example, let's say you are joining two tables, and after that you are doing a filter based on, let's say you are concatenating one column from orders and another column from customers, and then based on that you are doing some filter. Then before joining, how does it know that after concatenating these two columns from two different tables, how the data looks? So in that case, it has to do that after join only, right? So there can be cases where your filter happens after join, but whenever it can do before join, it will be more inclined towards doing that. I hope this is clear. So if you actually see in articles and all, it says from join and then after that where. But where can be moved at the very initial stage whenever it is possible for the system to do. After that we have group by, which we have seen in our case also, it's the same case. Fine. After this group by, we have what? So we have join, we have group by. So group by I'll show you in this. So you see this aggregate, and if I go here, you can see since we are doing count star, that is the expression it will have to calculate, right? It will have to calculate count star. And what are the two columns now? City, comma, expression 1007. 1007 is nothing but count star, because these are the two columns we are talking about in group by, isn't it? So you can see this, right? And you can check this out at your end also. Aggregate is done, and you can see in this plan the cost is there: 10%, 33%, 36%. I will have a separate session where I talk about it, but just to let you know, when you are doing performance tuning, you are more inclined to check the operators where cost is high, because those are something where you have to focus on so that you reduce the cost. If it is 0% and all, then it's something where you should not be worried, because it's not taking much of the time or resources, right? For example, if optimizing this one, I would focus more on, let's say, this hash mesh inner join, this is 36%, or to some extent I will focus on this one, right, where the cost is more. But right now in this session, my intent is not to tell you how to do performance tuning in this query. I'm just telling you the flow, right, how exactly the SQL query is executed logically. So you we have done this group by. After that, this is basically what we are trying to do is we are casting it. So it's a very simple operation where we are casting that count star to int. If you go here, you can check. So we do not have to really worry too much about it. Compute scalar, and this convert implicit integer. I mean, so we are converting count star into integer. That's a very simple operation. That's it. It's performing, right? And now whatever new expression is there, it's giving the name as 1004. You can check, right? And what are the output columns now? You can check this: city, comma, expression 1004. That means integer casting of count star, right? Earlier it was count star, but now it's just having a implicit conversion of it. Okay. Now what is the next thing that is there? Filter. Filter in the sense having clause. So if I go here, and in this, I'll show you filter where, what is this expression 1004? Count star greater than 10. Where do we have this condition? Count star greater than 10. If you see here, count star greater than 10 is like a having clause, right? So it is trying to filter the records based on this condition. And let me move ahead. If I go forward, you can check this out, where count star greater than 10. And after that, what are the things in output list? Still the same. It won't change till the end now, right? So you can see, if I hover, does it come? No, it's fine then, no issues. That's why I have the text mode on, because of some issues at my end. Now after this filter, what exactly is happening? So I'll write here group by having. Having is nothing but where, right? Filter. And then after that we have sort. So I will show you this sort. So if I hover on it, it says total number of rows, right? That so total number of rows per execution 562, right? And now if I actually go there in the sort, you can see we are sorting it based on descending order of count star. You can check this out, and we are retrieving the results. So this is how it is, and after that it's like printing the results. So after that we are printing. So this is how it goes. So generally remember this point, that if you see officially, then it will look like this when you see documents from join where, but where can be clubbed with from when retrieving the data, right, or scanning the data. It can apply this where, so that it's like a predicate push down and we eliminate, I mean, data as early as possible, so that we deal with lesser data. Then we have group by, then we have having, select. Now, do not get confused with this select, because this select shows before order by, and whatever we have seen as per us, our select is here towards the end, right? Order by is this and select is coming at the end. Remember, this select is not something like the select that we see as part of ordering in the documents. This select says that, let's say, if we have any functions in the select, it will be calculated this time, right? Whatever select we see in the diagram is like print statement, think of, and it will be always there in all the plans, right, with cost 0%. So do not worry about this select. Think that this is of no value right now, whatever you are seeing select here, right? And then we have order by. Limit I will show you, I have not talked about it right now. I hope this is clear. Now what I will try to do here is, for example, I am saying group by city having, can I say total greater than 10? Total greater than 10. Can I do that? See, I have given this alias as total, right? Count star as total. Can I do this? Let me try running this. And it says invalid column name total. Why it's doing that? In having, why it's not able to read? So you can see this. I mean, basically, the select clause comes, that means aliases and all will be taken into consideration when coming to select here later. Right now, aliases are not into picture as of now, right? So if I have done count star, I have to refer it with count star only. I cannot use the aliases because select comes later in the list, if you see, right? So for example, in my select, I have this count star as total. Select is not evaluated as such till now. Select will be evaluated after having. So that is why aliases cannot be referred in the having clause. And that's where it was failing. So that's why I have to refer it as count star. I hope this is clear. I'm trying my best to convey it in the best way. I mean, let's see how it goes and how much you are able to grab. And I'll be doing a series of sessions on this, because things cannot be explained in one session, honestly. It's just like an overview right now that I am giving, but super, super important, honestly. So now let us do a slight variant of this query to understand more. What I will do now is, let's say, I will say, what I will try to do, I will do one thing. I'll make a slight change in this query. I'll take this query, right? I'll take this query, and what I will do is, I'll put it here. Everything is working fine, correct? Now what I will do, I'll change this having clause. In this having, group by having count star greater than 10. Instead of count star greater than 10, what I will say, having city, equal to, let's say, Phoenix. It's one of the city, right? I'm doing this. I have a particular reason to show you this. Ideally, I should not be writing this in the having, but I want to demonstrate something. That as simple as that. Okay, and I'll say explain. Now you can see it first reads the data from both the tables. It is having a join and then group by. There is no having clause. There is no having clause. Then where has that gone? I mean, are we not filtering the data? We are filtering, but system is smart enough because system says that when I know that I have to just get the data for city equal to Phoenix, then while doing the reading from tables initially, why don't I just get those records? That is, it will push this filter down to the storage layer and it says only get me those records. See how beautiful the system is. I'll show you here. Let me run this. Take here and put it here so that I can show in the text format. And now, if you see here, I will again put it down. Okay. So you can see here where city equal to Phoenix. It has pushed it at the very, very bottom so that we are eliminating unnecessary records as early as possible. But when we are saying we are having count star greater than 10, that it could not push to the storage layer because I mean count star greater than 10, that means first group by should execute, then only it can know that count star is what number. But in this case, there is no requirement of doing group by, then only we will get to know. No. At the starting only we know, okay, I mean we can filter based on city equal to Phoenix. Right? So sometimes you have to understand that it's not that what I mean these steps are given by documents and all. It might not follow this. On a general note, it will follow this. But sometimes it will shuffle these around or it will do differently so that you have a better plan or a optimized plan. Right? System is intelligent enough. So I'm saying do not always follow this that okay it should be like this. No, not necessary. I'll show you one more example. So what I will do now, I will again take this, not this one, I'll take the previous one and make some changes. Okay, what I will do now is I will let's say what I will do, select top three. Okay, I'll now have this top three command. Select top three. This is like a limit. I want to have only three records. City count star as total from orders, join customers on orders dot this where order status not equal to pending, group by city, right? Group by city, and let me remove the having clause, right? Group by city, order by total, right? And let's say not even this, I want to, or even this does not matter, right? I want to have this. I'm saying I want to get top three cities from where maximum orders were placed. Actually I want that. So let me run this command, right? And run this. I will say explain. So you can see here, first it reads the data from both the tables, then it do a join, then it did a group by, right? After that, it is doing a sorting, right? So you can check this out. It's doing a sorting, uh, order by basically, order by towards the end, which is as per our this thing that after group by only we are doing this sorting and all, so it's all fine. And after that it is getting you the top few records, top 1%, right? So that's how it is behaving. So let me even run this query here to show you more. So initially, what it's doing, it is doing a clustered index scan on both the tables. It's doing a join, right? And let's me do see if any filters it has moved. So it has moved only for the orders table where order status not equal to pending payment. Okay, that's great, right? Then it's doing a join. Then it's doing a group by, right? Sort top three. Now all of this is fine and this is as per what we were expecting, correct? Now what I will do is, let me again go back and tell you one more thing. If you hover on this arrow, it says that okay, this command has given 562 rows here to the sort. Now has it done all the sorting and then selected top 3? No, system is smart, and what it do is top n sort. That means it would have found the maximum and then the second maximum and third. It has actually not sorted. And that's where you can see it is top n sort, it is saying, right? It would have done a very, very quick sorting. It would not have sorted all the results. It would have just got the top 3 only, right? Top 3, if there are 1,000 elements and if I have to uh, sort all, for example, if there are 1,000 numbers, if there are 1,000 numbers, right, different numbers, and I want to get the top 3 from this, there are two ways. Either I first sort all the 1,000 numbers and then get the top 3. This is one way. Or you can scan all the numbers one time and select the topmost, then select or go through all the numbers and select the second topmost, and like that. So there can be a faster way of doing without doing the actual sorting, and that is what it actually says when it says sort top and sort in the brackets, right? So you can see this. The sorting itself is giving you 3 elements actually. I hope this is clear. Now, so this is like optimization system has done internally. Now let us slightly again fine tune the things, change it. I will make a slight change in this query. What I will do is I will now have having clause, group by city, having count star, count star, let's say uh, greater than 100. I am having this. I am running this query. Let me run and say the explain plan. Okay. Now what I am trying to say, I want to get top 3, but before that I am filtering based on this criteria that okay, count start should be greater than 100. Ideally, it's a very logical query, but I want to show you certain thing here. What I am trying to say here is, if you see the order of execution, first it read both the tables, then did a join, then did a group by, then did the having clause filter basically, right? This is the having clause, and then it did the order by, right? And then it gave the records. This is very much in lines with the official thing which generally is put on documents and all, right? You can check this out. That order by having is coming before the order by. If I run the same query here, you will understand it much better. right? You can see here it did a full clustered index scan. Then it did the join. Do not worry about how it has join. I'll have a separate session on that. And then it did group by, right? Group by where we have count star, right? And then it did a implicit conversion into integer. Then it applied the having clause, right? Where count star greater than 100, and then it sorted it based on descending order. Awesome, right? Isn't it? So now again here the sorting it's doing is optimized one where it might not be sorting. It is doing a top and sort. Very quick sort. So that finally after this only three results are there. It's not spending time in doing every sorting. No. Now let me make a very small change here and then you will wonder how come things have changed. Right? Let me say count star greater than 10. Count star greater than 10. Remember what we had right now is filter first and sort later. And I just changed the value of count star from 100 to 10. And let's see. I run it. And again, I explain the plan. And you can see the sort is coming first now and filter is coming later. See, the beauty of the engine is that engine knows, I mean, based on statistics, how to optimize the query. It's not that you always think that, okay, whatever is given in document, this is how it has to go. No, system can bypass this rule. System can follow a better approach. Now here you see sorting is happening first and filter is happening later, right? Because see, I mean, system knows that in when it goes through this route, it can be faster, right? Because now it is saying if I am doing sorting anyways, filtering will become easy, right? Because I am saying that okay, I want to get records which are more than 10, right? That means kind of if we are doing filter here first, I will tell you what I'm trying to say. There were two scenarios we have seen: count star greater than 100 earlier and count star greater than 10. These are the two scenarios. Here what happened, first we have in order is we got the filter first, right? And then we got the sort. Here we are getting the sort first and filter later, right? Now it's very hard for us to determine why system has done, but system would have statistics to understand that if it do it this way it will be faster, right? As simple as that. We do not have to think too much, but what I can think from my mind that what would have happened here is, in this case, since count star greater than 100, when we do filter, kind of it will give us very less rows actually, and then sorting becomes easy on that. Because now this value is greater, that means it will eliminate a lot of rows and will give very less rows, so that sorting becomes easy. That's why it would have followed this approach. And when we are saying count star greater than 10, that means there will be still lot of values which will come up in the results, right? And then we have to do almost sorting on all things. So system would have thought, let me do sorting first. And then anyways, when I'm doing sorting, after that, the filter can be that after a certain point, I can take all the records that will come in filter because I'm saying greater than 10, right? So once I reach to 10, after that, all the records I can take, right? So kind of we are not eliminating too many records here. So system thinks even if I do sort here, it can be beneficial first. But in the previous case, it might think that okay, since we are eliminating a lot of records, right? The result set after filter will be very small. So small number of elements have to be sorted. So let me follow this route. This can be one approach. My thought process can be different, but system knows all the statistics that what it will do so that it performs faster, right? So I am trying to say, although we say that this is how it works, but there can be cases that this is not how it works, right? Interesting. And we will try to dig deeper. From my side, I have tried my best to convey things as per my understanding. At some places even I might have gone wrong in my understanding, right? There is no doubt, because not everything is available in terms of documentation and all. Some things we think as a human mind logically, which can be incorrect also, but that's my thought process to this problem, right? And if you have a different thought process, do mention in the comments. And if you have not subscribed to my channel, do subscribe. I'll make sure I will have this series in a way that you people enjoy it to the level best. And I will give my wholehearted effort in this series to make sure this is one of the best series available on YouTube. And I will go so deep that none of the person has gone. Right? So with this, we will wind up. But again, quick recap of what we have learned. Initially, we saw that how to see the explain plan. Right now, I'm using the Azure SQL database. Right? You can use anyone, and I'm seeing the explain plan. I've shown you that we have different objects. There is a cost associated with the objects. A thick line means more data is getting transferred. And you see this plan from right to left, top to bottom. We talked about the indexes, clustered index and non-clustered index. Clustered index is the one where data is kept intact in the table, so that physical ordering of, or physical storage of data is impacted in the table. But when we talk about non-clustered index, we create a separate thing, just like the index at the start of the book, where we first check there and then go to the actual pages, right? So it's like a two-step process, which will be little bit cumbersome but still beneficial, right? So we can have only one clustered index on a table, but we can have more than one non-clustered index on a table, and indexes make our life easy. And seek is faster, scans are slower, but again, you cannot always say, just like I have shown you, that whatever we say might not be true always. Same way it goes with seek and scan also, right? For a very small table, I mean, kind of, scans can also be faster than seeks, just to let you know. Okay. Now, we talked about various scenarios and we saw various things with lot of different changes in the queries, that how exactly our plan goes, right? Sometimes we have seen sorting before having, and then sometimes we are seeing having before sorting. So it goes very differently, very, very differently. But generally, if someone asks you what is the order of execution of query, you have to tell this. But you can say that this is just a very generalized case. It can change based on the statistics the system has, and system can take a better plan in place to approach my query. So with this, let's end the session. If you have not subscribed yet, please do, and I'll make sure I'll keep on adding such interesting videos to this playlist. Thanks a lot. Hello friends, Sumit this side from Trendy Tech. Now I am restarting my SQL playlist, which was a big hit that time. Now the first topic that I want to cover is CTE, Common Table Expression. Now, as I promised, I'll be coming with advanced concepts, and trust me, a lot of people get stuck with CTE because this is an advanced concept which does not come in basic concepts as such, right? So let us start to look what is CTE, what is the advantage, and how to use. Now, just to give you a context, you might have worked on subqueries, but writing subqueries can be a pain when we are writing complicated queries which involve a lot of nested subqueries, right? That is where CTE or common table expression can play a good role. So I'll write here and take it very slowly. So basically, the whole point to use CTE is to make sure we simplify the complex queries. So this is to simplify the complex queries, right? And now any query which involves the role of subqueries can be written as a CTE, right? In most of the cases. And that will be very much readable. So it improves the readability of a query. It improves the readability of a query. Right? Now, with just theory, you might not understand. So I'll take an example side by side and then I will keep on talking about it. So let's consider we have a orders table. Select star from orders. Consider you have a orders table. I'll run this. And we have 4 columns. This orders table has 4 columns: order ID, order date, order customer ID, and order status. I'll write it. I have an orders table, right, with 4 columns: order ID, order date, and then we have order customer ID. Order customer ID is nothing but the customer who has purchased the order. So it's equivalent to customer ID as such. So order customer ID. So basically the customer ID who purchased this order, and order status. There can be various order status, whether order can be closed or pending, many things, right? Now, if you see in this table, order ID will be a primary key, unique, and order customer ID can repeat because a same person or same customer could have placed many orders, right? I mean, if you purchase on Amazon, will you purchase only once? No, you will purchase many times, and that's how you will place multiple orders, right? So same way, there can be multiple customer IDs here. Now, what we want to find out as the very first thing is, we want to find out customers who have placed. So basically, I will rephrase this. I first want to find the total amount of orders each customer has placed. So total orders each customer has placed, right? This is the first thing that I want to find out, and based on this I want to find out all the customers who place the orders which are more than average of it. That means customers who order more. And how do we get to know? We will first find that, okay, how many total orders are placed by each customer. Then we will find the average of it. And people who are placing total orders which are greater than this average, we are looking to look at that. Those are like premium customers who are ordering more than others, right? Who are ordering more than the average which people order. So I hope I am able to communicate this well, that we want to find out people who places more orders. And how to do that? First, we will try to find out total number of orders placed by each customer, and then we will find the average orders given by each customer, right? And then people who are doing more than that are the premium ones because they are ordering more often. That's what I wanted to communicate. Okay. So now, if I want to do this using my subqueries, how will I go about achieving this? How will I go about finding people who place more orders compared to others? Right? So I want to find out premium customers. And what's the definition of premium? Who places more orders, right? And how do we calculate? By just judging it with the average. If it is more than the average, it's premium, otherwise not. So initially, the first solution 1, that I want to use here, I want to use a subquery approach. A subquery approach, that how to find this out. So what I will do is, I will say select order customer ID, this one, order customer ID, comma, right, count star do not judge me on this star now, because my intent is not to tell whether it is count star or count one or count some column. I'm not teaching that, right? So select order customer ID comma count star from which table? Orders, where now group by order customer ID. If I do that, what I will get? And moreover, I will place some alias also here as total orders per customer. Total orders per customer. If I run this, what I am going to get? I am going to get that how many orders are placed by each customer. So it will give me total number of orders placed by each customer. So let me try running this. So if you can see, select order customer ID comma count star as total orders per customer from orders group by order customer ID. I am grouping it based on order customer ID, so I should have it here and I should have one aggregate column, right? And we can get this. Let me run, and you can check here that customer whose ID is 2917 has placed 6 orders. Customer whose ID is 5834 has placed 4 orders, and so on. Some people would have placed 10 orders, 16 orders also, right? All of that. So what we have done till now is we have find out the total number of orders purchased by each customer. This is the first thing. Now, are we looking to find this? No, this was just an intermediary result. Our main goal was to find the average, right? The average amount, the average amount or the average number of orders placed by each customer is what we want to find out. So what I will say, select AVG average, and then what I have to give here, this column, select average total orders per customer, and I will give some alias name because this average will give me some field, right? I will give it as name as AVG orders per customer, right? From this, thing, and whatever I have placed in here, since I'm using SQL Server, I have to give some alias name, right? A temporary name. I have given this. So if I run this, what should I get? What should I get? I should get the average number of orders placed by each customer. And I am using a subquery here, inner query here. You can see which is the inner query? This one. And what is the outer query? This one. So that means first the inner query is executed, then the outer query will be executed. Let me run this. Right? So I am able to find out the answer that on an average, each customer places 5 orders. This is what I have found out. Right? So, and I have used a subquery approach. So solution 1 using subquery. Our final thing was different, that we want to find out premium customers who orders more than 5 times, which we will do later. But for now, let's try to have a problem statement that what is the average number of orders a person places. Average number of orders placed by each customer. Placed by each customer. And we have used a subquery approach to do that. Now, the title of this video is, what is the title? CTE, Common Table Expression, or we can say with clause. Now I will show how to do this using a with clause or using CTE. The names are used interchangeably, so do not get confused. With clause or CTE means the same. Now solution 2 is using CTE or using with clause, whatever you want to say. Okay, let me see if video is getting recorded or not. Yes, it is. All good. Fine. So now I'll talk about the syntax of CTE. What we have to do is, so basically whatever we have written inside, right, can go as a first statement. So we have to say with. So CTE starts with clause, as the name suggests, with also here, right? So with, what next we have to do? We have to give it some name, right? So we will give name, let's say total orders. With total orders, we'll place some column list here, do not worry, as, right, with total orders as, and here you will write your actual query. So whatever you have put it in the inner subquery, you can put it here. I'll put it here. Select order customer ID, right, comma count star as total orders per customer from orders group by order customer ID. This is what I have here, right? And now ideally you can avoid this column names, but it's a good practice to give column names here. So I will give the same column names here. Select this comma total orders per customer. I will again repeat the syntax with, and then treat it like a temporary table, total orders, but it's not a temporary table. I will explain that later. But it's a alias for you to, when you want to refer this, how will you refer? So you have to give it a name, and this is that name. So with total orders and these two columns which are coming from the inside query, we will place it here. Good practice to do that. I'll talk more about this, but do not worry now. As, and then we write the actual query inside this brackets. Select order customer ID, comma count star as total orders per customer from this. So whatever was my inner query, I have made it as my with statement. Now, as I said, total orders is not a table. We will get results which are like temporary result set stored in memory, but not stored somewhere on disk and all. It's not an object in the SQL store. It is basically a result set held in memory for time being when we are running the query. Now we can use total orders as if it is an actual table. We can use that and get the results. So what we can do now, we can say select AVG, and we can say average uh, total orders per customer, okay, as we can give a name as average orders per customer, okay, from what is a table which you think of. Ideally not a table, but this is the thing, you can refer it this way. Select average of total orders per customer. That's what we have done earlier. Select average of this, right, from this. But in this case, since we have already named it as total orders, we can place. So basically, you think that in this query, this part is replaced by total orders. As simple as that. And after the with clause, the select should be the first statement. Select, insert, update or delete, anything we can use, but we generally use select as such. So it should be the first statement, otherwise it won't work. And you can have one statement only. It's not that after this select you write another select. It won't work. Only one select statement. And this entire query has to go together when it runs. It cannot be that you first run this and you are trying to run this later. No. When we run this entire thing, that time only the with clause is executed, and the result of this is stored in memory as a temporary result set. It's not created as an object anywhere. It's not stored as such permanently anywhere, right? It's not a table, it's not a view, nothing. It's just a result set held in memory, materialized. right? And then we can refer it later in the immediate next statement. If you do not do that, it will give you an error, right? So let me first run this subquery, which we have already done, right? You can check this out. Average orders per customer is 5. Now let me try running this as well. And average orders per customer is 5. Exactly the same results we have got. But now, if you see, right now you might not see much difference because even this subquery is very simple. But the moment you talk about nested subqueries, a subquery inside another query inside that, a lot of these things, it will be very, very messy. It will become very, very complicated, and even you yourself will not be able to read the code if you read it after 2 days, right? That is where the beauty of CTE or the with clause is. It says that use this feature and try to write readable code so that 1 year later also if you come, you will say that wow, this is a clean code which I'm able to grab easily, right? Because if I see this statement by itself, it tells me just forget about with. If you just think of this select, it tells you very clearly select average from total orders per customer from total orders. That means we understood that we would have calculated total orders and then we can check how we have calculated. But if you see this as a whole, you won't get the complete perspective when you're checking the subquery thing, right? We will make this subquery complicated, then you yourself will realize that okay, it is significant readability gains that we get. I hope this is clear, right? I have executed it using both ways, subquery as well as the with clause. Now generally when we write subqueries, we tend to write something like query 1, which is, let's say, the innermost, right? I'll increase the font. And then outside we write another query, query 2, and then on top of it we might again write one more query, query 3, right? This is how we write the subquery thing. And it can get really, really complicated because kind of we start reading it from here, then we have to understand what's the logic in query 2 and then what's the logic in query 1, right? Because we are used to read it from left to right, and the left query is just the wrapper query. It does not give us the complete perspective we can get from CTE using the with clause, where the same thing would be written like query 1 and then finally query 2 and then query 3. This is how the flow of the CTE will be. So this is, I would say, subquery, right? And then this is the same thing. If we are doing using the CTE, it will be this way. Now you tell me which one is more readable. Definitely this one, because it's more of a logical, organized plan, step by step. So it's a linear step by step way that we interpret and write it, and which is very easy for us to grab. Fine. So now let's go one step ahead in this. What we will try to do is, till now we have calculated the average, number of orders placed by each customer. Now what I intend to do is, I want to find out all the customers who places more than this average quantity, or who places more than this average number of orders. The premium customers I want to find. So I want to find premium customers who places more orders than the average number of orders. What is the average number of orders? We have got 5, right? So who places more than 5 orders is what we want to get now. And the same thing we will try doing using the subqueries as well as CTE. and then you will truly say that this makes sense now. Let's see using subquery how to find that. So whatever we have used here or done here, let me quickly use that, right? So the inner query gets you the total number of orders. The outer query gets you the average number of orders, right? Now what should I do here? How do I proceed? So let me just quickly check what exactly we have done. Okay, and fine. So what we have to even do now is we can say select star from, right, and then we can use this total orders query again. I'll explain you, do not worry. Let me first restructure this query a little bit and then I'll explain you. Select star from, select order customer ID, count star as this, uh, group by order customer ID, and let me give it a name as, let's say, total orders. Okay, and then I'm saying join, select average, this thing, okay, and then I will give a alias, so I'll give the name here as average orders just to be more meaningful, and then I will say on total orders, dot dot total orders per customer. Do not worry, I'll explain you if the query works, otherwise I'll rectify this query. Average orders dot average orders per customer. Okay, and this should be fine, I believe. Okay, let me try running this, and if there is any syntax issue I will rectify, and after that I'll explain you. Okay, incorrect this on. Where is that? Join on total orders. Okay. Okay. So you can see I have written a subquery approach to find this, and we are able to find total orders per customer 6, 9, 7, all of that which is greater than 5. You can clearly see yourself. That means we are able to get the results using the subquery approach. And now let me explain you the subquery quickly. So what we have done is we we basically have written a subquery earlier or a query earlier which can give us the total orders, right? So you can see select star from, and then consider that you have two tables, total orders and average orders, right? And then basically you want to join these two tables on the total orders that are placed. So basically kind of you have to take it in a way that that basically your total orders which are there should be greater than average. That's what the condition we have placed on. It's not a equal to condition, it's a greater than condition, so that we only pick those orders from both the tables, right? So now if you see here, it's very straightforward, total orders and average orders which we have pre-calculated, but we have to perform a join here. You can just have a look. So select order customer ID, count star as total orders per customer from orders group by this, total orders, and then average orders. So we have already pre-calculated that, we are using that statements again, but you can see this query here. And if I do a control F, you can see same thing we have to repeat here. right? Same thing, because when we found the average orders, we have to use total orders query, right? So this definitely has to be reused here. We cannot kind of reference this here again. So you can see there is a lot of duplication in the code, which makes developers life tough and more make the code bulky, unnecessary. And apart from this would be creating a performance impact also, because it would have to calculate this again and again. This would run separately and this would run separately. If we would have calculated it one time and referred that, it would have been more performant, right? So you can see this becomes really a issue in this case. So all what we try to do logically is, we have total orders, we have average orders. All we want to say that, let's consider these are two different tables, although these are not directly tables that way. So we are saying, okay, give me all the orders, right? Where orders, I mean, the total orders are greater than average number of orders. And average number of orders, this will roll out to 5 actually. If you know, this will be amount which is 5. And we are getting the results this way. So now you can yourself sense that this is not a good way of writing, and it can really get very complicated. I have given line spaces and also it's looking easy again, but if you see, this is how it will be. And then if this is how it will be, then do you feel it's good? I do not see so, right? This is really not that great. If I give you this query, you will definitely take time to understand, oh, what's happening? I do not get it. So complicated. Now, same thing we will try to do using your common table expression, and let's see how to achieve that. So, what we will do using common table expression is, we will say with, right, with, and we will say total order. See, it's a three-step process. In whatever we are doing is a three-step process for the query we are writing. Number one, we calculate total orders. Calculate total orders per customer. Number two, calculate average number of orders for each, for the customers. And the third thing, and what's the third thing? Third thing is, again, get to know the customers who are premium. Get to know the customers who are premium. And definition of premium is people who purchase more than the average times. Okay. So it's a three-step process. Now, when we see this query, you won't relate that, okay, we are doing logically this way, because it's complicated using subqueries. Now, with CTE approach, it gets super easy. So we will say with, and whatever we have to calculate first, we will calculate logically. So we will say with, and then I will give it a name as total orders. I can give any name, but good to give a more meaningful name. And then I'll give a list of columns. I am keeping it blank for now as, and I will give a query here. And that query is to calculate total orders per customer. What's that query? I'll take it from here, this one. So select order customer ID, comma count star, group by this. So this will give me total orders per customer, right? And then I will give the same list of columns here as a good practice, comma total orders per customer. This is my first step that is done. I hope this is clear. If I say select star from total orders, I should get this result. Select star from total orders, then I should be able to see these results. Let me check that. I'll come here, I'll run this, and we can see I'm able to get total orders placed by each customer. step 1 is done, right? Now let me extend it further. I do not want to use this here because my intention is not to calculate total orders by customer. That was just one intermediary step. I have given a comma and I can write more of with statements here. It's not that just one temporary result set we can create more to make it easy. But you won't be using with keyword again. You just give a comma and then name of the other result set. It will be average orders. If you see, first calculate total orders and then second is calculate average orders from the total orders created. So I will say average orders, okay, and then what I have to give the name here, I will give later as here what query I have to write. How do I calculate average orders? I'll go up and then I'll take this query, select, or I'll write it only, no problem, because it's a small query that I have to write. Select AVG average of what we want to get, average of total orders per customer, right? Select average of this as AVG orders per customer, okay, from total orders. I'm using this result set now, total orders. You can check this, right? I'm using this result set. Quite easy to understand. You can check this out. So first temporary result set and then we are creating second temporary result set. I'll give this same name, sorry, this name here. I can avoid it also, but it's best to give so that it becomes more readable. And then I can say here select star from average orders. So you can see we use step 1 and step 1's result is used in step 2 and then finally step 2 whatever result we are getting we are printing it. So it is in a sequential fashion we are writing top to bottom. Makes life easy. And we can see there are total 5 average orders placed by each customer. All good? Now, my intent is not even to do this. I want to go beyond, right? So, what I have to do now, the select query, see, the temporary result set that I have to create, these two are enough for me. But my query requires a small join because I have to join this average orders and total orders in order to get the results. Because then only I'll be able to compare the total orders, this thing, total orders per customer with average orders per customer. How do I compare these two columns? These two columns are spanning across two tables. That's why I require a join, a simple join. So let's do that. Select star from, right? Select star from, what is this total orders? Consider both of them are tables. Ideally, it is not, but consider both are tables and work with them that way. Join average orders on, okay, total orders. So we have to tell what's the criteria on total orders dot total orders per customer greater than average orders dot average orders per customer. As simple as that. And trust me, when I was writing subquery, I also got confused for a moment, right? And with this, in CTE, it becomes super easy that the control is in our hand. We won't deviate. It's a very, very logical approach that we said, okay, first we found out total orders, by each customer. Then we found average orders by each customer. Then we are doing a join on these two result sets. So easy. Super, super easy, right? And I will run this. I should get the same answer. Let me just try showing you. Hopefully we do not get syntax error, and we can get, or we are getting the same answer. But which one is more easy to interpret, you can yourself understand. One is this query, which is through subquery, and one is this with the with clause, right? So with this, I have explained you practically that we follow a step by step linear approach when we are writing CTE. But when we are writing subquery, it's a very different approach, and the human brain cannot interpret it actually. So the most important aspect why we use CTE or the with clause is to make it more readable and the query gets simplified. Performance gains and all, I'll talk now, but it's not truly that we think we will get huge performance. In this query, whatever we are writing, definitely it will be more performant also, because the same subquery we are repeating multiple times. If you see this one, right? This one, you can check that we are writing, sorry, here we are writing it two times exactly. And when this subquery goes more and more nested, definitely all this redundancy will increase only. So not recommended, right? So let's discuss more theory about CTE. We have seen practically, and now the theory will be a cakewalk for you. So CTE defines a temporary result set that you refer within another select, insert, update, or delete statement immediately following the CT. What do I mean by immediately following the CT? If I do not give it here, then it won't work. If you think that we can just run this, it won't run. Let me show you. If I just run this, it won't run, right? And moreover, if I give two select statements, for example, before this, if I have select star from orders, right, it might fetch results for this, but after that it will fail, because it will not understand what is this total orders and what is this average orders. It won't understand. I'll show you. If I run this, it might show you some intermediate results, but after that for this line it won't identify total orders and average orders, right? You saw the result sets, that means this line worked, but when it comes here it won't be able to recognize, because we can only use it in the next immediate line, then only it can recognize, otherwise not. I hope this would have made some sense actually. So I will write it here. CTE defines a temporary result set that you can refer in select. Just like we are using select, you could have used insert also, you could have used update also, you could have used delete also, statements, right? Immediately that follows as CTE. Immediately follows the CTE. If you do it later, it won't work. I hope this is clear to you. If I remove this line and if I run this, it will work. I hope this would have made sense. Okay. Now CTE is not stored in database as an object. It is a temporary thing held in memory, and very temporary. I mean, this scope is only defined for this. That means it gets calculated, and then once we are done with the query, it's all lost, right? So it's hold in memory. There is no object that is getting created. Also, one more thing, what is the role of this columns? Do we really have to put these columns? I said it's a good practice, but do we really have to put? See, in this case, in our case, we can eliminate this, right? I'll show that. For example, I can eliminate this, let's say, and it should ideally work fine, right? So what is the whole purpose? Why should we put? See, I'll tell you, sometimes what happens when we are doing a join on two tables, might be same column name is coming from two tables. That time when the column names are not distinct, then we have to tell what columns we have to use, right? Then we have to tell what columns we have to use, or we have to give it a different name. For example, I'll show that. I'll make a copy of it, right? I'll take a copy and I'll show you some things. For example, I say order customer ID once again here, order customer ID, right? Comma this. I'm using this column name two times. Consider it's coming from two different tables. Let's say we have done a join and all. Now, one thing is that if here we have three columns now, and here we have two, definitely it will fail. I'll show you that first of all. We have to remove this line. Okay, it will fail. Total orders has more columns than that were specified. And the other way is also that if you remove both of this and have two here, then also it will fail. So the number of columns should match if you are giving that, first of all. So if you are having this, then number of columns should match, exactly match, number one. And if there are two different columns here, then what we have to do, we cannot even remove this. If we remove it, it will say there are duplicate column names. In this case, it becomes mandatory to have this here. I'll show that. The column order customer ID was specified multiple times for total orders, right? So in such a scenario, when we do not have distinct column names coming out, we have to put this. And here we can give a different name. For example, let's say order customer ID and then order customer ID 1 we can say. Because if I again give the same, it won't take. And then finally total orders per customer. What I am saying is, first of all, it's a good practice to give this column names here. And in case if the values coming are not distinct, then it becomes mandatory to give. And the number of columns should exactly match, right? So now I will run this and show you that whether this is working or not. I'll remove this select star from orders here. And let's see. And we can see this is working all fine. So I hope you would have understood what's the role of these columns here. Ideally, good practice to give, but not required always. But when it is required is when the columns that you are getting from here might not be distinct and will be repeated. So that's where you have to definitely give this and give some other alias name so that the system takes it. And this number of columns downside and here should exactly match. If there is a mismatch, it will again give an error. I hope this is fine. Now, talking about performance, a lot of people say CTE improve the performance, right? People say CTE improve the performance. Yes, it can, but only in some cases. CTE can improve the performance, but not always. Sometimes it might degrade the performance, right? Now it depends on the database implementation that is there internally. Might be Postgres has a different implementation, MySQL will have a different implementation, Oracle will have a different implementation. It depends on database to database also. But nowadays databases are smart. They are saying better you do not think about optimization, you write your query because it's giving you more of simplification or more easy way of writing or readable code, and I will try to make sure that your performance is not getting hurt. Generally databases are coming in that mode to do that, right? For example, in what scenarios CTEs can give performance, right? So CTEs have been originally implemented with an optimization intent, if you ask me, right? Kind of, we are telling system that okay, I am writing this query do materialize it and keep the results in memory, which I can refer through this name because I will be reusing it again and again. So with a very positive intent, we have said, please calculate these results and keep in memory because I'll be reusing these results for performance gains. Right? So in such scenarios, when we are reusing things again and again, just like in our purpose, it will give performance benefits. But in some scenarios, it can degrade the performance also. What can be the aspect where it degrades the performance? Let me tell you. For example, I will talk about Postgres implementation. Postgres, right? So basically, Postgres SQL, right? Here, before version 12 of Postgres, the implementation was in a way. For example, let's say you have select star from orders, right? This is a query that you have. Now, if you write a CTE on top of it, just for the namesake, let's say you say with orders CTE as select star from orders. Select star from orders. Let's say here we have where order ID equal to 10,000. Now we are saying with order CTE as select star from orders, and here we are saying select star from orders CTE where order ID equal to 10,000. Now, since I am using MySQL implementation, I will show you here there is not a no problem. If I run this query, right, and I right click here, say command palette and run query with actual plan. If I run this and I see, you see that estimated cost 100 and it has gone for clustered index seek. That means some indexing is working. That means we do not have to search one by one. It's quickly searching it and it took very less time to have this 0.047. Now, same way, if we are using this CTE with order CTE as this and select star from order CTE where this thing, how much time will it take? It will take roughly the same time, right? If I show you 0.028, almost the same time, and if I open command palette and run with this thing, I still see same clustered index seek coming into play. But now think it this way, if truly it is materializing it, ideally in this case it is not materializing, I will tell you why. If it would have materialized, what it would have done is it would have taken all these rows and put it to this order CT temporary result set in memory, and then from that it would have again searched for order ID 10,000, and trust me, on CTE, right, the indexing does not work properly, so the indexes are not performant. That means even though when we are searching this, it might have looked entire thing. So it would have done two scans. One is when putting all this data to order CTE first in memory, all the records, and then searching all the records all the way to find this number 10,000 because indexing would not have worked fine. So if ideally this would have materialized, that means if this would have been calculated and stored into this, it would have taken a lot of time. But in this case, it's not happening because system is smart enough and it would be not doing that. So system is taking a call whether should I materialize this or not. In this case, it do not feel that materialization will benefit, so system has not done. If you ask me in Postgres SQL before version 12, it would have definitely materialized it and it would have taken a lot of time. So I'm saying it sometimes depends on database implementation, that what they do. Right now you are mostly using CTE or with clause for your, I mean, readability gains, not for performance gains. Performance can get degraded, but systems are smart enough now. They say that do not worry, you just think about your readability. I'll take care of performance. If I feel I should materialize it, I will. If I feel I should not, then I will not. I hope in this scenario you understood that definitely this is not getting materialized. If it is, then it would have taken a lot more time. So, as I said before, version 12 in Postgres, right? If I would have done this, it would have taken a lot of time. But now, after or from 12th version of Postgres, right, or even in Oracle, there is a concept that it will not materialize all things. It will judge whether it should do or not. But still, if as a developer you say that no, I have written my code, I want this to be materialized, then there are hints that you can say materialize or not materialize, and it will do that way, right? So from version 12, there is a concept of system taking care by itself. But if we want to hard, I mean force, right, force it on the system that no, you do not judge by yourself. I am saying that it has to be materialized. Then a hint could have been given in version 12 and beyond, right? So basically, now systems are smart and they are doing it inline, kind of. What they would have done is they would have written the same query here, actually, right? So systems are putting it inline. That means when they feel that okay, CTE would have degraded the performance, they are not materializing it, and system is kind of putting it inline. That means the same definition it will keep here, but from our side we won't see that. We will get the same performance as we would have got with subquery. So as I said, many people think that CTEs give better performance. It can in certain scenarios when we are like doing a lot of repetition of code, but it can backfire also, where it can degrade the performance heavily by doing materialization of queries or tables, and indexing won't work. Moreover, materialization also takes time, right? It has to do one full scan, all of that, because all the other optimizations will go for a toss. So more than helping us in optimization, it kinds of backfires in optimization. That is where systems are more intelligent to understand whether they should materialize it or not. I think I have talked about it gracefully. This is quite important to know, and very much important. All the systems would be working on those directions now, ideally. I hope with this we have covered CTE in a good amount of depth. I have tried my best to convey the things in the right manner. If you have liked this video, then hit the like button. Do mention what new topics you want me to bring next. And trust me, CTE, I want to cover a little more by having more examples. What I would do next is I'll have some lead code examples which I will try to solve using CTE instead of subqueries, so that you get more comfortable with it. The moment you understood CTE, right, you will be trying to solve almost all the problems with that, all the complicated problems with that. That will save a lot of time, that will be much more readable, and it will look very, very graceful also, right? So if you have not yet subscribed to my channel, do subscribe now. I will be bringing the best top-notch content in SQL. I promise that, and I hope you would have liked the video. And do mention in comments what are your thoughts. Thanks a lot. I'll stop the recording. Enjoy.